Hello. Numbering rule, and this is okay. Yathalaiba Wasim Bhai. Okay. Let me check whether I'm visible, audible. Hey everyone, just to let me know, am I audible as well as visible to all of you? Welcome, vanakkam, suswagatam. Yeah. Very good. I think I'm perfectly audible. Kids, just to let me know in the chat section that your Baba HSP is properly visible to all of you or not. I want to see green hearts along with some fire in the chat section if you can hear me, if you can see me perfectly. Hey kids, everyone, just to let me know. Just to let me know, everyone. Can you hear me? Yeah. The screen signal, Gopika Lakshmi, Sahana, and Ashmita, and very good. Chetan, a perfectly audible as well as visible. Kids, I would like to see the Josh in the chat section. Then I will say anything. Then I will talk to you. Then I will let you know that chemistry pedicare. If you're thinking like chemistry pedicare Radu customer, I would like to say it's romba sulubham. The things which are looking idiyappam murku will become awesome. What I said in Tamil, it's if you're thinking that chemistry is tough, it's not tough. It's very easy. I will make it simple. But I want to see, yeah, that's really awesome. I can see everyone can hear me, can see me. Now kids, before I start, I would like to see your presence in the form of, yes, smashing the like button. Everyone smash the like button. I want to see that everyone has smashed it or not. Likes should get increased. Then I will talk to you kids. I want to see your attendance in the form of likes. What's going on kids? Yeah, they should increase. Just like your brain is going to get increased. I want to see kids, how much hard work I have done. Let me show you. Let me first of all show you my hard work for you kids. See, you know that I never take slides, but how much hard work I have done for you. See kids, let me show you. Just to save your time, because your time is precious, what I have done, let me show you kids how many slides I made for you kids. Let me show you the demo of those slides. See kids, see what I'm going to give you. See how many slides. Can you see what is going to happen? Can you see how much hard work I have done just to save your time? For this, I want to see just fire in the chat section. For Baba HSP, yes, I want to see fire in the chat section. If you are really, I want to save your time. And I will start from the beginning. I'm not going to give you choice that from where should I start, because if the beginning is not good, if the beginning is not proper, then you are going to lose each and everything. So kids, what I want to say, I want to see fire in the chat section. Just fire, just fire, just fire. Hey, walaikum salam, assalamu alaikum. Namaskaram, suswagatam. Yeah, my kids, I can see your love. I can see your respect for your Baba. That's really awesome, kids. Really awesome. Now, kids, it will take time. Okay, it will take time to complete this whole syllabus without leaving even a single stone, right? I will not leave even a single thing, and my focus will be on solving questions, all type of questions which have been asked or which can be asked in the coming exam. This time the examiner will definitely give you a tough paper, so I want to touch those questions also which can be asked, which we call tough questions, right kids? Now my dear students, let me check number of figures are coming. So if I start over here, then it's okay. Let me check. Now kids, I will move in the sequence. First IUPAC, then structural isomerism, then geometrical, then optical, then conformational, and then GOC, the backbone of organic chemistry, and then hydrocarbon. So you have to make a promise that each and everything you are going to keep in your hippocampus. For that promise, I want to see green hearts, because you are far away from me, or you can say I am far away from you people. The only thing which can make a strong bond in between us, that is your emojis, right? With proper dedication, you have to give the answers whenever I'm going to ask questions. So I want to see green heart for this. Just you have to make a promise to yourself that you are going to attend this lecture up to the last, and you have to see my energy level. My energy level will be same even if it is 5 a.m. or 6 a.m. in the morning, right? I will teach you each and everything. Yes, with speed, but without leaving even a single stone. Let me see, let me check it out, what my kids are saying. Wow, kids, really awesome. Salute for your dedication, and I will teach you like my own kids with 100% accuracy. Mark my words, categorically I am telling you this particular point. Now I am going to start. Yes. So why the likes are not that much, kids? You are stingy in giving likes. What is this? Why likes are less? Right now 800 people are watching. Make everyone, please. It's a humble request. Hey kids, if you're not following the rules, what is this? Everyone, okay, you will do this. I have full faith on you. Let me start. I know that you are going to do that. Hey everyone, are you ready? Say yes. Wherever you are seated, say to yourself, yes sir, I'm ready. How's the Josh? Your hippocampus, your volume of your hippocampus should get increased so that it should occupy, it should absorb maximum. Now, yes, it's going to get started. Yeah, ready, set, go. IUPAC, yeah. Now, in the IUPAC, the most important thing is how to remember the sequence. You should remember the sequence. Same. Come on, the sequence. Carboxylic acid is on number 1. Remember that. I have divided in 3 to 4 parts so that you can remember this. carboxylic acid, then sulfonic acid, then anhydride, then ester. Car is moving along with Salman for a better ride. Anhydride towards the garden of Ester. Acid halide, carboxamide, amide. So 6. Right now make a promise that these 6 are in your brain. All carboxylic acid and derivative. This is the father. Carboxylic acid and its derivative. Leave sulfonic acid. They will not give you sulfonic acid in the examination. Carboxylic acid and its derivative. This is category 1, like tricolor of flag. The Caesarea color, saffron, then white, then green. Divided 3 colors, tricolors. In the first category, saffron one, it's carboxylic acid and its derivative. Second one, cyanide, isocyanide, aldehyde, ketone. Leave that. Leave the green one. This is there in your brain. Carboxylic acid, sulfonic acid and its derivatives. Then cyanide, isocyanide, aldehyde and ketone. This much is there. Show me thumbs up. Follow my rules. I will make you perfect. I want to see thumbs up in the chat section. If you are following it. Is this much gone to your brain? So everyone, let me check it out. Let me check it out. Is this much grown to your brain, kids? Do let me know in the chat section. Thumbs up. Then only you can become perfect. If you want, if you really want to become perfect, follow carboxylic acid, sulfonic acid, and don't read all these. Don't read it out. Carboxylic acid, sulfonic acid and its derivative, just this much. Cyano, isocyano, aldehyde, ketone. Cyano, isocyano, aldehyde, ketone. Cyano, isocyano, aldehyde, ketone. Say everyone, cyano, isocyano, aldehyde, ketone. And then alcohol, mercapto, amine and double bond and triple bond, right? Leave it. Carboxylic acid and its derivative. Cyano, isocyano, aldehyde, ketone. That much you have to remember, right? Okay, now see. Once again the names. Carboxylic acid, sulfonic acid, acid anhydride, ester, acid halide, amide, cyanide, isocyanide, aldehyde, ketone, alcohol, thiol, amine, unsaturated, right? Now, what's written? In one organic compound, the senior most functional group will act as secondary suffix. Remember, mark my words. In one organic compound, the senior most functional group will act as secondary suffix. Rest of all other junior groups, if present, then don't give preference to them. They will act as prefix. They will act as substituent. Mark my words, this is the mistake made by majority of these students. Once again, I'm telling you, if there is an organic compound, one organic compound, the senior most functional group will act as secondary suffix. Rest of junior groups, if they are present, they will treat it as substituents like alkyl group. What I'm saying, let me come back. Suppose if I say that there is an organic compound and in that cyanide is present and alcohol is also present, then cyanide will be secondary suffix, alcohol will be treated as prefix. If I say there is an other organic compound, there is alcohol and thiol, then alcohol will act as secondary suffix and thiol will act as prefix. Whenever somebody is acting as secondary suffix, it is having one name. If it is acting as prefix, then it will have another name. I will tell you all the names. Whenever the organic functional group that is acting as secondary suffix, it will have one name, and at the same time, if another compound it is acting as substituent, it will have another name that is known as prefix. So, see, junior functional group will act as prefix. In an organic compound, only senior most functional group will act as secondary suffix. Junior functional group will act as prefix. See. Note, alkyl, nitro, alkoxy, halo, etc. will always act as or behave as prefix. They can't act as secondary suffix. They can't act, they will always, these will always behave as prefix. Okay. So, let me show you the compound. Okay. It's gone. So let me give one example of it. Suppose if the compound is like this, just see CH3 CH COOH CHOH CH CH double bond O and CH double bond CH2. Right? This is an organic compound. If somebody is asking who is the senior most, who is the senior most, I want to see the answer in the chat section. Who is the senior most? Let me write down. This is X, this is Y, this is Z. So I want to see your answer in the chat. Who is senior most? Who is being senior most? Let me see in the chat section. Write down. Who is senior most? Let me see. Let me see. I can't see. I can't see. Who is senior most? So definitely this is secondary suffix. This is secondary suffix. And this will act as prefix. This will also act as prefix. One thing is clear. I think this is clear, right? This part is clear. Now, this is the format. You have to keep this format in your brain. Then only you can answer the questions. You know that in English, there is one word. Prefix you will add just before the name of that word and suffix you will add after it. So the main thing is this word root. Remember that. This is the main thing, this word root. Before prefix, after suffix. Now suffix are of two types. Suffix are of two types. Primary suffix and secondary suffix. From where you will get secondary suffix? Secondary suffix will come from the functional group, the senior most functional group. That will act as secondary suffix and that will be at the last, because in English we start from left and then we move towards right, and the secondary suffix will be at the last. Keep in your brain, mark my words. Primary suffix you have to use for carbon-carbon double bond, that is alkene or alkyne. They will always fixed. Carbon-carbon multiple bond, their position is always fixed. They will never act as junior or senior. Now, this is prefix and this is position of prefix. This format is clear. It's written clearly. Position of prefix, prefix, word root, primary suffix, secondary suffix, carbon-carbon double bond, carbon-carbon triple bond, senior most functional group. Is this clear? This format is there in your brain. Keep on showing green hearts or fire. If it is clear, I want to see green hearts. Fast, fast kids. Your emojis means a lot to me. Your emojis means a lot to me. That is the signal that till now everything is clear, because I have to check. I have to cross check that my kids are moving along with me. Okay, now see kids, now see. Parent chain selection rule. Parent chain selection rule says select the longest possible chain, as long as possible, along with the senior most functional group if it is present in the compound, if it is present, and carbon-carbon multiple bonds. Select the longest possible chain with continuous carbon atoms as long as possible, including senior most functional group if present, along with maximum number of carbon-carbon multiple bonds, right? Now let me explain it. Let me explain it. See, if I say that CH3, CH2, CH2, CHCOOH, CH, CH double bond CH2, 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 CH2 and CH3. This is your organic compound. Now what I said, select the longest possible chain of continuous carbon atoms as long as possible containing secondary suffix along with multiple bond. Secondary suffix is present. Now multiple bond, where is the multiple bond, kids? The multiple bond you can see here is the multiple bond. Can you see? So this is our parent chain. Is it clear to all of you? This is our parent chain. Although it is having only how many carbons? 1, 2, 3, 4, 5 carbons. Then also this is our parent chain. If you are going like this 1, 2, 3, 4, 5, 6, 7, 8, 9, that is wrong parent chain. Remember my dear students, that is going to be the wrong parent chain. You have to select longest possible chain of continuous carbon atoms as long as possible, but you cannot ignore secondary suffix. You cannot leave the multiple bonds. You cannot leave the multiple bonds. Is this point clear? Otherwise, number of students, they are making mistake at this point only, right? Now, one more compound I am going to give you. Just see, just focus over here, right? If I write down like this, CH3, CH2, CH2, CH double bond CH, CH3, CH2, CHOH, CH, CH double bond CH2, CH2, CH3. Now which is our parent chain? Which will be our parent chain? Just see, this is OH attached with carbon, right? This is multiple bond and this is multiple bond. So this is going to be our parent chain. Is this part clear? I hope this is very much clear to each and everyone. I don't think there is any doubt. Let me see in the chat section. Any doubt to anyone? Just do let me know, kids. Is there any doubt to anyone? Just do let me know in the chat section, kids. This point is clear. Now see, parent chain selection rule. In case of 2 or more equally long chains, if more than 1 equal longest chains are possible, then what you will do? Then see, the chain with maximum number of branches will be taken as parent chain. If 2 or more than 2 equally long parent chains are possible, then which parent chain we are going to select as the parent chain? The one with maximum number of branches. Just see. Numbering rule. We will come to the numbering rule, but let me show you this. Let me show you the example of it, right? Let me show you the example of this. Suppose if I write down CH3, CH2, CH2, CH, CH, CH3, CH, CH3, CH3, CH, CH, CH3, CH3, CH2, CH2, CH3. This is the organic compound, right? Now see, if I say kids, I'm going to select this as the parent chain. Just see how many carbons are there in this parent chain. Just see kids. Just see 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there in the parent chain. Now if I say that I am going to select this as the parent chain, how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7. That was having 8, but this is having 7. Now see, if I say I am going to select this one, just see, if I am going to select this one, the white one, now how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8. There, 8. There, the green one was having how many carbons? 7 carbons, and this red one was having 8 carbons. Now, just see, if I say the red one was having how many branches? 1 branch and 2 branches. It was having 2 branches. That is the neglected, because only 7 carbons. Now this white one is having how many branches? The white one, 1 branch, 2 branch, 3 branches, and the 4th branch, 4 branches. It is having 8 carbons along with 4 branches. Now kids, do let me know which is your parent chain. Do let me know in the chat section which chain you are going to select as the parent chain. Tell me the color. If it is clear to each and everyone, kids, do let me know in the chat section which parent chain you will select as the parent chain. Which chain you are going to select as the parent chain. I want to see, kids, in the chat section. Do let me know fast, kids. Quick. White one, very good. I can see, very good. That's really awesome, everyone. The white one is our parent chain. That means this is clear to each everyone. Now, numbering rule. We are coming to the numbering rule. Numbering should be done. First, let me read it out without seeing. Numbering should be done in such a way that the substituted carbon atom should get lowest possible number. Who is the substituted carbon? The carbon where something is added. Numbering should be done in such a way, that the substituted carbon atom should get lowest possible number. Now let me show you how the example of it. Suppose if I say that this is an organic compound, CH3, CH2, CH3, CH2, CH3, CH2, CH3. It's very clear that this is our parent chain, PC. This is the PC. But if I do the numbering from this side, 1, 2, 3, then the 3rd carbon substitution is coming. If I do the numbering from this side, 1, 2, 3, then it's coming on 3. It's ties, so that you can do the numbering from either side. Both sides it's correct. From both sides, numbering is correct, right? Now, if I give you another compound, I'm going to give you one more compound. Just see, if I write down like this, CH3, CH2, CH3, CH2, CH3, and CH3. Once again, just focus over here, my dear friends. This is our parent chain. It's fine. This is the parent chain. Now, if I do the numbering from this side, 1 randa mono. 3rd it is coming. If I do the numbering from that side, 1 randa. It's coming on 2nd. Which one is correct? Definitely this is correct. and that is wrong. The right hand side numbering is correct because this is the substituted carbon and it is getting lowest possible number. Kids, whenever you are able to understand any rule, just show me the green hearts. That is going to be the signal that you are able to understand. Kids, if you are really getting it quick, I want to move with very high speed, but by making it clear, the concept clarity matters a lot, kids. So keep on showing green hearts. If you want more examples, I will give you what. Let's move very fast. Now see, kids, numbering rule, lowest sum rule. By chance, if the substituent is coming at the same place, that this numbering rule is getting failed, then you have to apply lowest sum rule or locant rule. Let me show you how you will apply. Just see, if I tell you that this is our parent chain, this is our parent chain, right? Now let me do the numbering from left hand side. 1 2 3 4 5 6 7 8. The substituent is coming on which position? It's coming on third position. Now if I do the numbering from that side, 1 2 3 like here, 3 4 5 6 7 8. Now the substituent is coming on third position. From here also it's coming. From left hand side it is coming on third position. From right hand side also it is coming on third position. So the numbering rule got failed. The first rule of numbering, that got failed or not? Yes, that got failed. Now what we are supposed to do? That lowest sum rule. But lowest sum rule, sometimes students are getting confused. So let me tell you simple rule. This is coming, this group from that side is coming on third, from this side it is coming on third. So leave now this one. This is coming at the same position from both the sides. So just think about it, from which side it is coming earlier. 1 2 3 4, it's coming on fourth position. 1 2 3 4 5. So that one is correct definitely. But for this, chemistry says, yeah, we will make one rule. Chemistry, according to chemistry, they are going to make one rule for this. Just see, locant rule. What is locant rule? Just see. If they are doing numbering from this side, they are saying it is located on third, it is located on fifth, it is located on sixth. 3 plus 5 plus 6. How much? I don't know maths. Do let me know in the chat section. 5 3 8 and 6 14. And if we do from that side, where it is located, 3 4 and 6. 3 4 plus 6 13. Am I right? Which is lowest? 14 or lowest? 13. Here 13 is lowest. So this is correct. This is correct and that is wrong. And this is wrong one. Kids, how many got it? Locant rule, lowest sum rule. Once again, show me green hearts if you really got it. Your emojis, your signal matters a lot to me. If you really got it. Yeah, Sahana, Meena, Shreya, Ketone, everyone. That's really fantastic. That's really fantastic. One more. Okay, one more. Kids are saying one more. Okay, let me show you one more. See. CH3, CH2, CH2, CH3, CH3, CH2, CH3, CH3. Locant rule is applicable or not? Just do let me know. Locant rule is applicable or not? First, I'm asking locant rule is applicable? A option yes, B option no. So yes or no? I want to see yes or no. Yes or no? Let me check it out whether you are able to understand or not. Yes or no? Yes or no? Not applicable. B. Very good kids. Really awesome. You are genius. You are genius because this is the parent chain and from that side it's coming on second position and from this side 1, 2, 3, 4. So no is correct. Now it's not applicable. Now I'm going to give you another example. Just see. If I write down CH3, CH2, CH3, 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 CH2, CH2, CH3, CH3. Once again, I want to say Locant rule is applicable or not. Locant rule is applicable. A yes, B no. Let me see. Yes or no? Yes or no? I will make you perfect. That's my guarantee. No, you kids are really genius. Genius. So I will increase the level. I will level up. See, this is our parent chain. And see, from that side, it's coming 1, 2. Second, it's coming on second. And from this side, 1, 2, 3. It's coming on third. So not applicable. So now I'm going to give you one more question. Just see to it. CH3, CH2, CH2, CH3, CH2H5, CH2, CH2, C2H5. No, it will become easy. It will become easier. CH3, CH2, CH2, CH3. Now, Locant rule is applicable or not? A, yes. B, no. Yes or no? This time Locant rule is applicable or not? Applicable or not? This time Locant rule is applicable or not? Fast, fast, fast. Now this time some kids got stuck. This time some kids are giving wrong answer. Now see kids, see the longest chain is this one. Now see, if I do the numbering from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's coming on fourth. If I do the numbering from that side, this side, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is coming on 1, 2, 3, 4. Fourth. It is coming on fourth. Tie. See? 4 and 4 tie. It's on fourth. It's on fourth. So first rule got cancelled. Now we have to apply Locant rule. Now see, from the left hand side, it's coming on 4, 5, 4, 5 and 7. 4 plus 5 plus 7, 16. Am I right? Now from right hand side, it's coming on 4th, 6th, 7th. 4, 6, 7. 17th. Am I right or wrong? Am I right or wrong? Which is lowest? This one is lowest. So this one is correct. This is correct. And that is wrong. This is wrong. Am I clear, kids? Am I clear? You got it, everyone? If yes, I want to see green hearts. If it is clear, I want to see green hearts, kids. Just do let me know in the chat section, everyone. Right side numbering, kids. If your answer is correct, those who have given the correct answer, I want to see green hearts from their side. This one is correct. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now 5. This one is correct. That is wrong. That is wrong. This one is correct. See, 1, 2, 3. It is coming 3, 4. Then after 4, 5th. And from that side, it is coming after too much time. I think you got it, kids. You got it. Very good. Very good. Now let's move towards third one. Even what, think about even if this also gets failed. Even this also gets failed. See, let me show you one example. Let me show you one example. CH3, CH2, CH, C2H5, CH2, CH, CH3, CH2, CH3. Now see, this is our parent chain. Agreed? This is our parent chain. If I do the numbering from this side, 1, 2, 3, 4, 5, 6, 7. So it is coming on third. Now if I do the numbering from this side, 1, 2, 3, 4, 5, 6, 7. So it is coming on third only. So N got failed. N got failed. Now what we are supposed to apply? Locant rule. Locant rule is also getting failed. See, 3 plus 5. How much? Left hand side. 3 plus 5 is coming out 8. Right hand side. 3 and 5. 3 plus 5 is coming 8. Both got failed. This got failed. This got failed. Now what we are supposed to do? We have to apply alphabetical order. What we are? Alphabetical order. Alphabetical order. It is starting with E, and that is starting with methyl. Who comes first in the ABCD? Who comes first? This. E comes first. Alphabetical order. So this is correct and that is wrong. How many of you got it? NLA rule. NLA rule. Just show me the green hearts if you really got it. If you really understood, I want to see green hearts, kids. Kids, I'm making my best efforts. Everyone just focus on his studies only. Don't focus on rest of the things. Just stop chatting, kids. Focus. I want to make your future bright. Very good. Very good. That's really awesome. That's really awesome. Now, see. Can you tell me from which side we will do the numbering? Numbering rule, alphabetical order, and tricolor. And when N is getting failed, if L is also getting failed, apply alphabetical order. Which side? Left hand side or right hand side? Do let me know. Left hand side or right hand side, kids? Really, I have done a lot of work for you, kids. Really, I have done. Notes I will send in Telegram channel. Right to left. Yes, this one is correct. Very good, kids. Really awesome. Really awesome. This one is correct. 1, 2, 3. It's ethyl. That one is correct. Now, same. What's next? Wow, numbering rule, the priority order. Once again, tricolor, the priority order, right? Just see, then I will frame out one question on this. Just see this, what's written. Try to read it out. How many of you are able to understand it? First, the secondary suffix, preference order, priority order. First, the secondary suffix, then primary suffix, then prefix. I will give one compound. If you have read it out, then I am going to give one compound and you have to tell me, okay, have you read it out? Or I need to explain it. First you tell me, have you read it out? If yes, show me green signal, green hearts, then I will frame out one question immediately. Immediately I am going to frame out one question based on it. Kids, you are taking too much time. Fast, fast, kids, fast. Okay, see, I am going to frame out one question on this. CH3, CH2, CH2, CH double bond CH2, CH, CH double bond CH, CH, CHO, CH2, CH2, CH3, CH2, 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 CH3. Now there are two questions. First question is the PC. PC means parent chain. The parent chain is having how many carbons? How many carbons? Answer it. This is my question number 1 to you people. The parent chain is having how many carbons? Let me see who is going to give the correct answer. The parent chain is having how many carbons? Some people are saying 11, some are saying 10, some are writing so it's a nice question. It's really a nice question. See kids, really nice question. Now it's a time to answer it. Just see, this is our parent chain containing multiple bond and the secondary suffix, containing multiple bond and the secondary suffix. This is our parent chain. So how many carbons it is having, kids, in the parent chain? A numbering will start from secondary suffix. This is our secondary suffix because senior most, and this is your multiple bond. So numbering will get started with 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons. Answer is 8 carbons. The parent chain is made up of 8 carbons. Those who got correct answer, they can show green hearts for themselves. They can show green hearts for themselves. If your answer is correct, you can show green hearts for yourself. Kids, if your answer is correct, you can show green hearts for yourself. Yes, kids. Very good, very good, very good. That's really awesome. Now, see kids. Now, let me start with carboxylic acid. Are you ready for carboxylic acid? R, C, double bond O, OH. This is carboxylic acid and its secondary suffix is oic acid. Oic acid means in alkane, if you add to alkane, if you add oic acid, definitely it will become alkanoic acid. Alkanoic acid. Alkanoic acid, right? Now, see, carboxylic acid, the secondary suffix is oic acid. Prefix is carboxy and chemical abstract name is carboxylic acid. See the slide and then I will explain each and everything. Really nice slide, kids. Do let me know in the chat section. The slide is really good. The efforts made by your Baba HSP kids, do let me know. How is the slide, kids? You don't know how to appreciate. See how much hard working your Baba is, kids. I will explain each and everything. If you're really liking it, at least I deserve your green hearts. Welcome, Vanakkam. Everyone just wake up. Vanakkam. Welcome, Suswagatam. Very good, very good, very good. That's really awesome. Now see, kids, I will tell you how to use it, But before moving ahead, just see. These are the names, 5 names. 1, 2, 3, 4, 5, 6. You know, it's IUPAC name, anyone can write. Methanoic, ethanoic, propanoic, butanoic, pentanoic, hexanoic. Everyone, easily you can write. It's easy kill question for IUPAC, but journal names. Its journal name is formic acid. Everyone knows formic acid. It is acetic acid. It is propionic acid. Propionic acid. It is rancid butter, butyric acid. Butyric acid. But anyone tell me the name of these two? This one, 5 carbon. Let me check. Those who are saying fast, let me check who is going to write down the name for 5 carbon. Yes, 5 carbon. Do let me know. Anyone? Surya, welcome. Sahana, 5 carbon. Do let me know who is going to write. Let me check it out. Who will write? 5 carbon. No one. Till now, no one. Valeric acid. Remember this. Valeric acid. And 6, caproic acid. So these two names holds a lot of weightage. These two names are very, very important. Just focus on these two names, kids. Generally, you will miss your marks over here. Generally, you people are going to miss your marks over here. So just keep my words, kids. Very, very important. Very, very important. Very. Valeric and caproic acid. Now, carboxylic acid, dicarboxylic acid. Dicarboxylic acid means whose N factor is how much? N factor is 2. We can say the basicity of acid is 2. That means replaceable HR2. Now, how to remember these names? Just remember one trick. Baba HSP tricks. Ohms, gap, GAP, gap. Everyone say, wherever you seated, ohms, gap. Everyone say, ohms, gap. Now, how it is going to help you? Number of CH2 in ohms gap, number of CH2, 0, 1, 2, 3, 4, 5. It's looking like 0. O is looking like 0. So 0 CH2, 0, 1, 2, 3, 4, 5. See, everyone is having 2 COH. The CH2 is 1. 2 CH2s, 2. Adipic acid, 4 CH2s. You will see 4 CH2s. How is the trick? Ohms gap. This is Baba HSP trick. If you're really liking it, I want to see some fire in the chat section. My hard work, you have to appreciate my hard work. If you're really liking it, show me some fire in the chat section. Ohms gap. Everyone just say ohms gap. Very good, Himza. Very good. Ohms gap. Revise. Keep on revising ohms gap. That's really fantastic. Now see. And remember that it's glutaric acid, not glutamic acid. Glutamic acid is amino acid, and it's malonic acid, not malic acid. Okay, glutaric acid. Now, carboxylic acid, secondary suffix. Now let me explain all three. Secondary suffix, prefix, and chemical abstract name. Tricolor. Once again, see that tricolor. How much time I am saving, kids? Really, I am saving your time with this hard work. Now see, this COH. This is our parent chain. This is our parent chain. Numbering should start from that side. 1, 2, 3. What do you call it? Propanoic acid. Propanoic acid. Propanoic acid. Now see kids. One COH, one more COH, one more COH. The parent chain will be of how many carbons? Just see to it. Parent chain will be of how many carbon atoms? We can select this to be the parent chain. Now who is left? Who is left? Which is we are not able to count in the parent chain. This COH is left. So the COH which is not the part of parent chain will become prefix. Remember that. So I will write down 1, 2, 3, 4, 5, 6, 7. The parent chain is of 7 carbon atoms. Now this is left. See, in between parent chain and this COH there is CH2. So this is carboxy and this is methyl. Once again I am telling you, carboxy methyl. So at 4th position, so we'll write 4 carboxy methyl, methyl for CH2, carboxy methyl heptanoic, heptane dioic acid, heptane dioic acid. Remember this E will be there. Now in this 3 COH are there and they are directly attached to the parent chain. We can select this to be the parent chain. This is the rule made in 1989. 1989 they made one rule. If all they are attached to the parent chain and they are more than 2, that means we cannot count them in the parent chain, then this is chemical abstract name used as secondary suffix. What do we call it? 1, 2, 3. Chemical abstract name will be used as carboxylic acid. So we'll write propane, 1, 2, 3, tri, not the oic acid, not the carboxy, tri carboxylic acid, tricarboxylic acid. I hope this is clear to all of you. All the 3 types of names are clear to all of you. If yes, I want to see some green hearts. If it is clear, if it is clear to each and everyone, I want to see some green hearts. Very good, very good. That's really awesome. That's really awesome. Fantastic. Now let me move further ahead. Now see, before I move ahead, I want to give you one question. What's that? Sulfonic acid. Just wait, just wait, just wait. See, if I give you compound like this, what do you call it? What do you call it? We all know in 1989 general name was included in the IUPAC. We call it benzoic acid. What is another name? I want to see another name. Benzene carboxylic acid, carboxylic acid, benzene carboxylic acid. I hope this is clear to each and everyone. It's clear. Now if I at the same time, if I give you another compound like this, and another compound like this, now can you find out any difference in these 2 compounds? Is there any difference? Yes sir, there is difference. What's that? The difference is, sir, this is directly attached to the parent chain, so we'll say cyclohexane. We'll say it cyclohexane carboxylic acid, carboxylic acid, cyclohexane carboxylic acid. But here this COH is not directly attached to the parent chain, so we cannot use chemical abstract name. You have to do the numbering 1, 2. So you will write 2-cyclohexyl and ethanoic acid. You should know where to use the chemical abstract name and where not to use the chemical abstract name. If this point is clear, then I will move ahead. Just to let me know with the green hearts, green signal, green leaves, whatever you can use, but you have to use green if it is clear, kids. I want to see green signal if it is clear. Everyone, just Sahana, very good. Saran, very good. Irakulu, fantastic. Carboxylic acid is the chemical abstract name. Now see, some students are using, why not oic acid? If you are using this in the parent chain, you cannot use this. This is cyclic part, that is acyclic. Any one thing you can use, so it is chemical abstract name. And in chemical abstract name, there is carboxylic acid, not the oic acid. Examiner will give you cycloheptanoic acid, cyclohexanoic acid. Don't go for that. It's cyclohexane carboxylic acid. I hope this is clear to each and everyone. Now, I'm going to give you one question. Let's see how many of you can do this question. Okay, I will give you 2 chocolates. If your answer is found to be correct, you will get 2 chocolates. You will get parcel, right? Now my question is to the public, position of hydroxyl group. I will give you options also. Option 1, A option, 1, B option, 2, C option, 6, D option, nota, none of the above. None of the above. Let me check it out. What's your answer? Quick. Let me see how many of you are intelligent, really intelligent. Oh, kids, some are really intelligent, others they have missed it. Those who got correct answers, show me the green hearts. The correct answer is, numbering should start from here, 1, 2, 3, because this is secondary suffix. First we'll think about secondary suffix, then this is multiple bond. We have to go to multiple bond. This is just a substituent. It will act as substituent only, so leave it, don't count it. It is substituent because it is being junior functional group. Junior, in the starting only I have told you it's being junior functional group. So 1, 2, 3, 4, 5, 6. So those who got it correct, oh my God, everyone got failed. Maximum students have given second answer. Maximum kids got failed. Kids, I was thinking that 6 is written on B. This is the trap. You got stuck, kids. Oh my God, kids. What is this? Only very few students got the correct answer. Oh my God. You got failed. Maximum students got failed. Oh my God, kids, what are you doing? This is secondary suffix. This is senior most. Functional group. Can you understand? This is senior most functional group. After senior most, see the multiple bond. Priority order was secondary suffix, then multiple bond, and then it was the prefix. And the junior functional group act as prefix. I hope everyone got it. Everyone. So in this way, I'm supposed to give one more question. Otherwise, you will get failed in the examination. Just see, Baba is going to give you another question. 90% kids, definitely you are going to get failed over here also. 90%. Now my question is, once again question is, position of OH Position of hydroxyl. Let me give you options also. A 5, B 4, C 3, D none of the above. This time kids, you have to give the correct answer. I will watch, I will see. I'm going to keep everything, each and everything. Everyone, I want to see the correct answer. What's your answer? So the correct answer is C. Who is the secondary suffix? This is the secondary suffix. After this, giving number 1, this is multiple bond. I have to count, I have to give number 2, number 3, number 4, number 5. So this is correct. Many students, what you must be doing? 1, 2, 3. Maximum students must be going like this. 1, 2, 3. That's why wrong. The previous question also, see, maximum students are going like this. They are thinking OH is functional group. 1, 2. They are going like this. But remember that I have told you number of times that after senior most, this is the junior, so it will act as like substituent. So you have to give preference to multiple bond. Remember this. 90% students will go like this. 90% will do the mistake. First of all, do let me know this question was clear and this question is also clear, because these two questions are going to kill your selection, because maximum students, they don't know this thing and that's why they are getting failed. First of all, do let me know in the chat section that everyone, you are getting your mistake or you're thinking like my answer was wrong. You can think like that Baba's answer is wrong. You can go like that also. Oh, you know, you need your chocolate. Yes, it will be there. It will be there. Kids, now tell me how the studies are going on. And I'm not only teaching kids. My experience, you know, why people call me Baba. I have given rank 1. Tanishka Yadav. I'm Haren Singh Parihar. Did my MTech in 2004 and 1999 gold medalist in chemistry, MSc, JRF GATE. AIMS 3rd rank, Mehak Arora. His brother, 715, Suez Arora, 5th rank. Chaitanya Mittal after Mehak Arora, AIMS 4th rank. That time AIMS was taking separate exam. I haven't given my introduction. This is my introduction. Why the people are getting ranked? Because where everyone is doing mistake, I'm going to tell you where to rectify. If you're really liking it, I want to see in the chat section. If you want more such type of questions, show me fire in the chat section. This is your Baba HSP. I will show you sometime the ranks, the people, those who have got rank, kids, and those who know me. Okay, let me give you one more question. Let me give you C. And before giving you a question, let me tell you one thing. Before giving you question, let me tell you. Let me take out charger. My mobile is getting discharged. So let me take out charger and let me put it on charging. The question which I am going to give you right now, 90% of the kids, once again, you are going to get failed. The question which I am going to give you right now, 90% of you will get failed. Now tell me, should I give you or not? The question which I am going to give you right now, 90% of you are going to get failed. Should I give you? If you want, I want to see fire in the chat section. See, question is COOH, CH2, CHOH, CH2, CH, double bond CH, CH2, COOH. Question is position of hydroxyl group in PC. Let me give you options also, but I will not give options. I will not give. You have to tell me in the chat section. You have to tell me. I want to see in the chat section. I want to see in the chat section. I want to see in the chat section. Oh, great, kids. Now you have grown up. Maximum people have grown up, kids. Wow. Kids, really awesome. Now you have become HSPN. Now you are my student. See, the senior most secondary suffix is over here also, and the secondary suffix is over here also. Now this is your junior. Junior functional group will be treated as prefix junior. This is junior, so it will act as prefix. And this is multiple bond. So I have told you the priority order: secondary suffix, then multiple bond, and then prefix. This is the priority order. So 1, 2, 3, it is coming on third position. 1, 2, 3, 4, 5. So this one is correct. 1, 2, 3, 4, 5, 6. So 6 is correct. Answer is 6. How many of you got correct answer? Can show green hearts, green leaves, green singlet for themselves. Then I will give one more question, and definitely in this question maximum people are going to get failed. Maximum people will lose this question. See, I am going to give you a question. Ready? See, question is, yes, question is 90%, this time 90% will get failed. Are you ready? Then do let me know. Are you ready? 90%, I challenge, 90% will get failed. COOH, CH2, CHOH, CH2, CHC2H5, CH2COOH. Once again, the question is position of hydroxyl group. Do let me know. Let me see. And you can also check what answer you are giving. Okay. I've told you that 90% of you will get failed. 90%. Now there is tie. Some are saying, maximum are saying A, 1, 2, 3. And some are saying 1, 2, 3, 4, 5. Now there is tie in between 3 and 5. Am I right? Now you must have seen the result. Now, once again, do let me know what is the answer. Let me see. Once again, the poll is getting started in between these two options. Let me see. Really nice question. Really nice. So kids, you can see it's really a nice question. Really nice. See, this is your secondary suffix. This is your secondary suffix. Now, the one who is giving 3 as the answer, that kid is wrong. Why this kid is wrong? Let me tell you that he is thinking this is a functional group. That kid, he or she is thinking that this is the functional group. But remember that, mark my words, this is junior functional group, and junior functional group will be treated as prefix like this, as substituent as prefix. They are equal. There is no functional group. The functional group is acting as like substituent. Remember that this is acting like substituent. Now you have to follow numbering rule. Numbering rule is failed. Locant rule is failed. Alphabetical order, nulla, NLA, nulla, NLA, nulla, nulla rule. And this is in the nulla rule is coming with E, ethyl. This is with ethyl, and that is with hydroxy. Which alphabet comes first? Do let me know alphabetically which will come first. Everyone do let me know alphabetically. This will come first. So the numbering will be from this side. Kids, you got it or not? Everyone got it or not? Fifth is the correct. If you got it correctly done, you can show green hearts for yourself. If your answer is absolutely correct, show green hearts for yourself. And you're liking it. Everyone is liking it. This is really going nice. Fantastic. Now last question I'm going to give you, then I will move ahead. Last one question. So your concept should get very clear that COOH, CH2, CHOH, CH2, CH, C2H5, CH3. Now once again the question is position of methyl. Position of methyl. Do let me know. This is your question. Position of methyl. Let me check it out. What answer you people are going to give? Yes. Some are giving 3, some are giving 6, some are giving 5. Let me tell you what should be the correct answer. See, first of all, this is ethyl. Rub it. Make it CH2, CH3. Now the parent chain will go like this. The parent chain will go like this. Got it? This is your parent chain, right? Now 1, 2, 3. 1, 2, 3. Tie. Numbering got failed. Locant got failed. Alphabetical. This is methyl starting with M, and this is hydroxy starting with H. Who will get preference? H comes first. So 1, 2, 3, 4, 5, 6, 7. So 5 is being the correct answer. Those who have done it correctly, give marks in the form of green signal. Green signal. You can show me green signal. Now let's time to move ahead. Till now, if everything is clear, you can show me green hearts along with some fire in the chat section. So that sulfonic acid. Now sulfonic acid, wherever sulfonic acid is attached, it will not be as prefix. No carbon, so no chemical abstract name. Simply one question will be asked like CH3, CH2, SO3H. What do you call it? 1, 2. So you will write down its name as ethane sulfonic acid. Ethane sulfonic acid. I hope you got it. It's useless. No one is going to ask this name. So let's move ahead. Acid anhydride. When you eliminate out water from acid, two acids are combining, then you will get acid anhydride. So oic anhydride. Let me show you. No prefix, no chemical abstract name. Oic anhydride. Suppose if you are using two acetic acid molecules and removing water, so you will get CH3, C double bond O, C double bond O, CH3. So there is symmetry. So I would use the word symmetrical. Symmetry is there. So breaking is also there, breaking in the chain. So either you can count 1, 2 or you can count 1, 2. Alkanoic anhydride. So athenoic anhydride. Now if you are using two different acids, So two different acids will give you two different, means like H, C double bond O, O, C double bond O, CH3. Now see, there is not symmetry, asymmetric. This is having one carbon, this is having two carbons. So one carbon meth and two carbon eth. So eth alphabetical comes first. So ethanoic, methanoic, anhydride. I hope this is clear to all of you kids, because it's very simple. So no one is going to ask it in detail. So simple questions will be asked. So let's move ahead. Let's move here. Ester we have to study in detail, because number of questions can be framed out on ester. But you're liking my hard work. I have prepared slides so that no difficulty should be there. Remember that. Alkyl, alkanoid, when to use that, when to use carboalkoxy, when to use alkoxycarbonyl, and when to use chemical abstract name. I will show each and everything. But you are ready with full josh. I want to see fire in the chat section if you're ready with full josh. If full on josh is there, fire in the chat section if you're ready with full josh. Because this was very, very important, kids. Very, very important. Now see, kids. See, everyone. Just see. Let me explain. This we have to study in detail. Now, as secondary suffix, CH3, CH2, CH2, C double bond O, O, and remember this part. Why I'm talking, whatever is written over here, suppose methyl is written over here. First, you are supposed to write down the name which is attached with oxygen. Remember that. Anything which is attached to oxygen, you have to write down that. Methyl. Written methyl. Written. Now you will do the numbering. 1 to the carbonyl carbon, from this carbonyl 1 2 3 4, butanoate. If you're listening carefully, then I'm going to give you one wonderful example of it. See, but it's written like this: CH3, CH2, CH3, CH2, CH2H5, C double bond O, O, CH3. Which part you are supposed to write down first? Remember that this part which is attached to the oxygen, you have to write down it first on number 1. Methyl. First write down methyl. Without thinking anything, write down methyl. Now do the numbering. Numbering 1, 2, 3, 4, 5, 6. This is M methyl, this is E ethyl. Now you have to think about alphabetical wise who is coming first. E. Don't go for that. Don't compare with the alphabet. Don't see the alphabet of this. Don't see the alphabet of this. But this is the parent chain. Whatever is attached in the parent chain, you have to see the alphabet. This is M, this is E. E is coming first, so you will write methyl, 2-ethyl. Now 4-methyl once again. Now the word root is 6, hexanoate. But it's clear to each and everyone. I want to see once again. No need to say the green leaps or a green signal. Anything green, kids, I want to see. The green. Greenery should be there. Yes, I want to see everything green. Now, very good. You got it. Now, where to use chemical abstract name? Let me show you. Chemical abstract name. Suppose if it is given like this. Now the first part you have to write on this one. This is attached with oxygen, ethyl. Now see kids, this is directly attached to this. So write down cyclohexane for this, cyclohexane. And now this part is carboxylate, 8 carboxylate. I hope this is clear to each and everyone. Each and everyone it is clear. Now its prefix as a prefix. Now see, this is secondary suffix 1, 2, 3. This is junior group. So don't count it in the parent chain. Remember this. It cannot be the part of parent chain. Remember this. 3, 4, 5. So if I move from this side, 1, 2, 3. Both the side it's coming same. Now see, this much part is carboxy and carbonyl. And this much part is methoxy. So what I have told you, its prefix, just see the prefix. Carboalkoxy or alkoxy carbonyl. Carboalkoxy or alkoxy carbonyl. So how to use it? Carbomethoxy. At which position it is located? Third. 3 carbomethoxy and pentane dioic acid or pent dioic acid. I hope this is clear. This is clear. Carbomethoxy, right? Now by chance, I think it's clear to each and every one of you. I think it's clear to each and every one of you. Now let's move ahead. One question I'm giving to you kids. One question for you. You have to answer it. Okay? Ready? Now just write down its name, then I will disclose the name and you have to check it out whether your answer is right or wrong. Okay, so just check it out. So let me see the parent chain. My parent chain is of these many carbons. Is this your parent chain? If your parent chain is correct, then only you can write down the name. Now see, this is secondary suffix. This is junior, so it is prefix. This is multiple bond, that's why it is the part of parent chain, and this is also substituent. If this much is clear, then only you can write down the name. Otherwise, you can't select the parent chain, then definitely your name is going to be wrong. Now, if this much is clear, then see carbo and ester. This is ester, butoxy. This much is butoxy. This much is butoxy and this is carbonyl. So it is numbering 1, 2, 3, 4, 5, 6, 7. 3 butoxy carbonyl. And this is propyl. So 5 propyl and 7 hept. The primary suffix is 6 N-oic acid. Now, how many of you understood? It's a lengthy one. How many of you understood? Just to let me know in the chat section. How many of you got it? Wow, very good, caps. You are trying it, and that's really awesome. Those who are Sahana, very good. Kids, how many of you got it? Do let me know how many of you got it. Carboxybutyl also you can write. Butoxycarbonyl or carbobutoxy also you can use. The examiner can use carbobutoxy also here. Examiner can use carbobutoxy also, or carbo. Both are correct. Both are correct, right? Those who have got it, I want to see green hearts, kids. How's the Josh? Really awesome. So I'm going to start with acid halide. It's very simple. Acid halide, secondary suffix oil halide, haloformyl, carbonyl halide. I will use all three. Alkanoyl halide, haloformyl, and carbonyl halide. I will use all three. Kids, I have done hard work for you. Just do let me know in the chat section. Really, I have done hard work for you. I made these slides. Can you see? Now let me explain. One, two, three, four. Butanoyl chloride. Butanoyl chloride, right? It's simple. Now if I use now, see who is important for me. Definitely 1, 2, 3, 4, 5. You have to select the correct parent chain and then do the numbering. If these two things have done properly, then this will act as prefix. Carbonyl chloride, haloformyl, chloroformyl 3, chloroformyl, pent 4, and this E will delete out. See, this E will delete out because in chemistry there are vowels A, E, I, O, U and Y. These are vowels, right? Now, let me tell you one more as a chemical abstract name. Now see, if it is directly attached to this, now what you will say? Now you have to use, this is the parent chain. Now you have to use chemical abstract name. 1, 2, 3, 4, 5, 6. Cyclohexane. Carbonyl chloride. Carbonyl chloride. I hope this is clear. Each and everything clear? Is clear? Yes. Now, amide. This will take some time. This will take 3 to 4 minutes. It's important. See, alkanamide, carbamoyl, carboxamide. Just see. Everything, if everything is moving in the right direction, I want to see some fire in the chat section. If everything is moving, okay, just focus on your work. Don't say anything. Just focus on your work, kids. Everybody is important. Now see, let me tell you, let me teach you, kids. Okay, ready? Now see. CH3, CH2, CH2, C double bond O, NH2. Just see, this is the senior most. I will say 1, 2, 3, 4. Butanamide. Am I right? Butanamide. But if I use like this, CONH2, CH2, 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 CONH2, there is no problem at all. Don't use chemical abstract name because 1, 2, 3, 4, 5 pentane diamide. Now you will say, sir, what is this? This is wrong because you have not used the word 1 and 5. It started from here and ended over there. This is the start point and that is being the end point. No need to indicate the number. If you are indicating, that's your choice. That's right. But if it's not mentioned, then also it is correct because it has to start from here and it will get end over there. So it's absolutely correct. But the problem will arise when you are provided with compound like this. Now you cannot count all the three. You cannot count all the three. So definitely you have to make this as the parent chain and you have to use chemical abstract name. Are you getting my point? Everyone, are you getting my point? The history is getting repeated. Chemical abstract name you have to use 1, 2, 3. What do you write? Write down in chat section. Propane 1, 2, 3 tricarboxamide. Carboxamide. Am I right or not, kids? Am I right or not? And it's coming 3 times, but if it is coming in the ring even once and directly attached to the ring, for the ring directly attached to the ring even once, then you will use chemical abstract name because 1, 2, 3, 4, 5, 6 cyclohexane carboxamide. I hope this much is clear. Now I'm going to tell you when to use it as a prefix. You know the drill. You know very well the drill as a prefix. See to it. Just see to it. If I write down CH2 double bond CH, CH2, CHCONH2, CH2COOH, just see to it. Just see to it. That is our parent chain and this is what? This is the prefix. This is the parent chain and this is the prefix because it is junior functional group. You know, in the starting I've told you, right? So 1, 2, 3, 4, 5, 6. What should be in the name? Carbamoyl. 3 carbamoyl hex 5 N-oic acid. Till now everything is clear. Let me have a sip of water, kids, just to let me know. Till now it's everything is clear. If yes, I want to see some thumbs up, fire or green heart. After this, I'm going to tell you each and everything. Some people are spamming. Okay, so don't focus on them. Okay, you do one thing. If they are spamming, at the same time you can put green hearts or fire. There, the spammers won't be able to do anything. Kids, when they start spamming, you put on fire. Put some fire, then they won't be able to spam. Kids, that is the best way, I think. Let me check it out. Let me check it out. once they are spamming kids, at the same time you put green hearts or fire, they no, right now I can't give you break, kids. I have to complete this. I have to complete. I'm not going to give right now break. Okay, let's move fast. Okay, before I move ahead, just do let me know in the chat section my speed you want to increase more or it's perfect, because I'm teaching each and everything. I want to see in the chat. Let me sit in front of chat. Do let me know in the chat my speed is okay, because I am telling you each and everything in detail, or you need it to be increased a bit. Okay. So fine, fantastic. Okay, fantastic. I want to see each and everything. And one more thing, after this chapter you want to study GOC or isomerism. After this, do let me know in the chat section. After this you want to study GOC or isomerism. What do you want to see? Just do let me know. GOC or isomerism? GOC or isomerism? GOC. Everyone is going for GOC. Okay. So after this I will start with GOC and I will make you perfect. That's a promise, kids. That's really nice that you are responding, kids. After this I will start GOC and this was my guarantee, I will make you perfect, right? Okay. So cyanide, let me give you each and everything in one. So see, this name you have to remember. Its journal name is very important. Journal name is very important. Why, kids? Let me tell you. Its journal name is very important. Why I'm telling you? This much is O. Why O? Let me give you one reason. Suppose if I write down like this, just see everyone. Kids, remember that the most important thing is accuracy. People are thinking of speed. Speed will come automatically once your accuracy is good. Am I right? If I'm perfectly correct, I want to see some green hearts in the chat section. What I'm saying, once your accuracy is there, speed will come automatically. So don't go for speed, just focus on accuracy. If you are agreed, I want to see some fire. Now see, kids. Monovalent, one valency. Its name is benzyl. Everyone say benzyl. Say everyone benzyl. Monovalent. Only one valency. Monovalent. Benzyl. Divalent. Benzyl. Everyone you have to say, if you really following my words, say benzyl, divalent. Benzo, trivalent. Benzyl, benzo. Say this is going to give you marks. Benzyl, benzo. Benzyl, benzo. Now with this much you will see trivalent. This has been trivalent. So 2 carbons trivalent, you will use aceto. This is aceto. And this one is nitrile. This is very important, because when Ames was taking separate exam, once Ames has given one question. Let me show you that question. What Ames has given the question. Ames has given the question like this: CH3, CH2, no, CH3, C triple bond N, and Ames has asked which name is correct. Which name is correct? Now see, first name. If I take only this much, and this is what? This is what? Just to let me know what is this. Oh, what happened? Hank. This much is iso, and if I take this carbon also, what you will say? You will say iso buty benzyl, benzo, trivalent, isobutro, and this is nitrile. This name is correct. He has not asked the IUPAC name, just the name. Isobutronitrile. Now see, CH3, CH3, C triple bond N. So you could have also given the name isopropyl, and that is cyanide, isopropyl cyanide. This is also journal name. Now you could also have gone for this, CH3, CH3, C triple bond N, and you will call it 1, 2, 3. This is the IUPAC name. So 2-methyl propanenitrile, 2-methyl propane. All three names are correct. If you got it, then show me some green hearts. Chandranath, what are you doing, kids? Whenever somebody is doing something wrong, you can keep on showing green hearts or fire, then he will not write anything. That is the best strategy. No need to block. You can show emojis, then his messages or her messages will not be there. Yes, fast. Everyone got it. Everyone, is it clear? Yeah, I know he is lying or whatever. Don't worry. Ignore him. Ignore. Number of diversions are there in this world. Ignore. Just ignore. Focus on your work. All they will go. They will vanish. Now, isocyanide. It's very simple. Let me write down over here also. CH3, CH2, and C. Now breaking in the chain, this is coordinate bond. So 1, 2. Ethane isonitrile. Very simple. Ethane isonitrile. This is simplest most. No need to write anything. No chemical abstract name is there. Isocyano is the prefix for this. Let me write down. See, cyanide over here. Cyanide, CH2, CHCN. Now tell me whether chemical abstract name will be used or not. Write down chemical abstract name will be used or not. The answer is yes. We have to use chemical abstract name. And 1, 2, 3. Propane. 1, 2, 3. Tricarbonitrile. Right? Is it clear? Now, aldehyde. This will take some time. So try to maintain the accuracy over here. It will take some time. The secondary suffix is al. Alkanal prefix are aldo, formyl, and oxo. Oxo is used in special name. I will teach you in carbaldehyde. Let's go one by one. Are you ready for this? Everyone ready for this? Let me tell you. Just see to it. Just see. If I write down something like, simply if I write down like this, CH3, CH2, CHO. It's very simple. Anyone can write down 1, 2, 3, 4. Butanol. It's simplest, right? Butanol. No problem is there. If I write down like this, now you know the drill. CHO, CH2, CHO, CH2 CHO. Now you know that chemical abstract name will be used or not. Will you use the chemical abstract name or not? Yes, sir. Propane 1,2,3 tricarbaldehyde. Very simple. Propane 1,2,3 tricarbaldehyde, right? Any problem? No problem. Now let me give you one question. Let's see. COOH CH2 CH CHO CH2 CH C2H5. Now number of students are going to get failed in this question. Remember that. Mark my words. Number of students are going to get failed. Now you have to tell me the position of this CHO. Position of CHO. Question is position of CHO in parent chain. Everyone, this is your question. Let me see your answer. Let me see your answer. Let me see the chat section. Yes. Everyone, I want to see your answer. Let me check it out. Who is going to give the correct answer? Let me just check it out. Who is going to give the correct answer, kids? So, some are going with 5, some are going with 3. Just see. Everyone just see. Just see. If you are writing it formyl, this is always ethyl. This is always ethyl. This is always ethyl, fixed, constant. It's being constant, but it's having two names, either formyl or aldo. If you are using aldo for this, then A comes before ethyl. So you will do numbering from here. 1, 2, 3. If you are using aldo, then 3. If you are using formyl, then F comes after. Then you have to do numbering from here. 1, 2, 3, 4, 5. 5 for formyl, 3 for aldo. So it's clear. 3 is also correct. 3 is correct. 5 is also correct. If you are using aldo, then 3. If it has been used, then formyl, then 3. Clear? How many you liked it, kids? It's a really damn good question. If you really liked it, I want to see some fire in the chat section. Let me see some fire in the chat section. Thank you, Sahana. Really interesting or not? Really good or not? Yeah, this question has already been asked. It's already been asked in NEET examination. Now I'm going to tell you use of oxo. Let's see oxo use. Special case, you have to use the name oxo. Just see. If I write down like this, now see, numbering should start from here. 1, 2, 3. Now just to take the longest parent chain, if you have counted it, this is the part of parent chain. What is left? Only this is left. This is the left part. So you will say 4-oxo. Otherwise it is used for ketones. 4-oxobutanoic acid. At the same time, if I write down another compound like this, see, if I write down like this, C double bond O H CH CH2 CH3 CH2 CH2 COOH. Now see 1, 2, 3, 4. If I'm going to this side, I will get 1 carbon, 5. But if I move toward this side, I will get 6. So 6 carbon is the longest chain. Now I can use aldo or formyl. This will not be the part of parent chain. Here it's the part of parent chain, part of PC, but here it's not the part. You got it? Because we have to select the longest chain. We have included it just to make the chain longest. If you got it, I want to see once again green heart. Let me check it out. It's clear. You got it or not? If you got it, I want to see some green hearts. It's clear or not? Clear. Gotcha. Very good. Everyone got it. That's really awesome. Really awesome. Let me see the chat section. Everyone, it is clear. Very good. Now see, let's move ahead. Ketone, it's very simple. So ketones like CH3, CH2, CO, CH3. It's very simple. What should you call it? We will call it butanon or butane 2-on. It's very simple. Suppose if somebody has given you a question like this. Now, what you will write down its IUPAC name. It's very simple. First 1, 2, 3, 4, 5, 6. Satisfied? Now 6-ethyl. 4 keto or oxo, whatever, it's your choice or his or her choice. Cyclohex. 2 E will be there because this is carboxylic acid. 1 carboxylic acid. I hope this is very much clear to each and everyone. Very much clear? Okay. Now alcohol. Alcohol is simplest. So CH3, CHOH, CH2, CH3. 1, 2, 3, 4. Butane 2-all. Right? No carbon, so chemical abstract name is not there. When to use hydroxy, let me show you. When to use hydroxy, suppose if the question is given like this. So 1, 2, 3, 4, 5. What should be the name? 3-hydroxy. Now you will call it hydroxy because it's being the prefix, and pent 4N1L. Got it? Everyone, are you getting my point? Everyone, is it clear? It's clear. Now thiol. Now let me show you thiol and mercapto. I'm going to give you very good question based on this. Being these are friends, but can you please let me know what's the position of SH? Position of SH. Question is position of SH. Yes, do let me know in the chat section. Let me check it out. What's the position of SH, kids? Fast. Very good. Now you have become very intelligent. Oh, somebody is writing 2. No. SH. Now see. This is senior most, second is suffix, this is prefix, this is being prefix, this is also being prefix, this is your multiple bond, so primary suffix. So after giving importance to secondary suffix, we will give preference to this. Am I right? So 6, so its name will be, IUPAC name will be 6-mercapto, but this is first, so 5-ethyl 6-mercapto cyclohex 2 and 1 all. Satisfied? Everyone satisfied? Let me remove my shoes. I'm feeling some difficulty, so just let me remove my shoes. Kids, you are really liking it? Let me see the chat section. How many of you are really enjoying it? Write down in the chat section. My writing is okay. Kids, are you able to read it out? My writing is okay. Let me see, kids, in the chat section. I'm sitting in front of the chat. Let me check it out, kids. Kids, at least hit the like button. Smash it. Smash the like button, kids. Yes, kids. Why not in? No, it can't be in. Let me tell you. It's O. It's a vowel. It's a vowel. It's, if I put E, that is also vowel. So both the two vowels can't be there. Two vowels can't be there. You got it, Sahanaji? Sahanaji, you got it? Two vowels can't be there. Let me check it out. You got it or not? Okay, got it. Okay, now see, kids. This is over and out. Now secondary suffix. Okay, this is over and out. Ether. Now ether will require some time. Okay, let me tell you. Ether, simple ether. If I write down simple ether, if I write down simple ether, so like CH3O, CH2, CH3, which is smaller one. This is smaller, so this is alkoxy and that is alkane. So I will write 1-methoxy ethane. Got it? Clear? This is simple ether. No problem in simple ether. But if the ether is like oxyrane or oxa system, first let me write down oxa system. What is this oxa system? If oxygen is present twice or more in acyclic or even once in monocyclic, in cyclic. Let me show you. In this oxa system, oxygen is counted as carbon. Oxygen will be counted as carbon. Let me show you. CH3, O, CH2, CH2, O, CH2, CH3. From which side oxygen is coming earlier? This side. 1, 2, 3, 4, 5, 6, 7. So you will write 2, 5 dioxaheptane, right? Now if it is coming in cycle like this, you know, well-known compound. So 1-oxa cyclopentane. I hope this is clear to each and every one of you. It's clear? Clear. Now see, ether as oxyrane, What is oxyrane or epoxide? Oxyrane or epoxide. Just see oxyrane. If I write down compound like CH3, CH2, now see, kids, this much part is oxirane. Remember that this much part is oxirane. Are you listening? Are you listening? Cyclic part is oxirane, and this oxygen other than carbon will be given as number 1. Now I have to move that side or this side. This will be decided by alphabetical order because N got failed, L got failed, alphabetical order. This is ethyl, that is methyl. Ethyl comes first. So 1, 2, 3. Now how to write down IUPAC name? See, 2 ethyl, 3 methyl oxirane. Now another name, how to write down the second type of name? See, one more type of name for this. We can write down like this. See, CH3, CH2, CH3. Oh, just see. 1, 2, 3, 4, 5. So 2, 3 epoxy pentane. I hope you got it. Everyone got it? If yes, I want to see green hearts. Kids, Josh should remain. Now after this GOC is going to come. After this GOC is going to come, kids. Josh should remain very high. I want to see the Josh. Kids, how is the Josh? Do let me know, kids. Priority order already I have explained. Already the priority order I have explained in the starting only. Kids. Break I will give you. I will give you break, kids. But let me complete. Okay, how many of you want to get it repeated? Let me give you another example. See, let me tell you once again. Just see everyone. If I write down like this, CH3, CH2, CH. Oh, kids, remember this is the 3-membered ring. Always remember, whenever somebody is using the word oxirane stands for this 3-membered ring. Let me enclose it. This 3-membered ring is known as oxirane. Clear? This 3-membered ring is known as oxirane. This part is clear? Oxirane. Or I can write epoxy. Epoxy is only oxygen, this much part, epoxy. But 3-membered ring as oxirane. What I am saying, let me write down over here also. CH3, CH2, CH3, and this oxygen. If I write down this oxygen, and if I am thinking of this oxygen only, then this is epoxy. Now if I write down epoxy, then this epoxy is coming from that side earlier. 1, 2, 3, 4, 5. So 2 and 3, it is located on 2 and 3. I will write down 2 and 3. This is epoxy. 2, 3 epoxy and pentane. One thing is clear. Now if I am considering this whole, this is oxirane. Now I have to give numbering 1 to this. Now that side is methyl and this side is ethyl. Who is coming first? E in the dictionary will come first or M will come first? Then definitely E will come first. So after 1 I will give 2 to this because that is coming earlier than 3. So I will write down that this much is oxirane. So on second there is ethyl, 2 ethyl, and third is methyl, 3 methyl oxirane. Now clear, kids? Now is it clear? Now I want to see your response. I made it clear. If really I have done a good job, Notes I will send in the Telegram. In Telegram you will get kids. In Telegram you will get notes, but first of all do let me know. Very good, very good. Now see kids, now see. One more ether I am going to show you. One more ether, that is known as crown ether. Crown ether. OCH2 CH2. This is the repeating unit, kids. Repeating unit. I would like to say this is the monomer, and the value of N should be greater than or equal to 4. Then we will say crown ether. Let me show you. O CH2 bond line notation, CH2O, CH2 CH2O, CH2 CH2O, CH2 CH2O. 4 times it's repeated. Now how to write down the name? X crown Y, X crown Y, where X is the number of oxygen and Y is the number of oxygen plus carbons, right? Now how many oxygens are there? 4. Now 4 crown. Now for each one oxygen there are 2 carbons, so 4 carbons, so 4 oxygens. For each oxygen there are 2 carbons, so there are total 8 carbon. 8 plus 4, 12. So 4 plus 8, 12. Got it? It is used as polar aprotic solvent. Polar aprotic solvent. These crown ethers are used as polar aprotic solvent in your organic chemistry. Is it clear? Is crown ether clear to all of you kids? Do let me know in the chat section. Is crown ether clear to each and everyone? Fast. Now, cyclic compounds. See, cyclic compounds. If I write down one cycle like this, if I write down cycle plus alkyl group like this, if I write down cycle plus alkyl group like this, now if I write down cycle plus alkyl group like this, now if I write down cycle plus alkyl group like this, now if I write down cycle plus alkyl group like this, all types I have written. I will explain each and everything one by one, right? See to it. Cyclobutane, clear? Very simple. Cyclobutane, no problem. Is there any problem? Just to let me know. Cyclobutane, no. 1 2 3 4, 1 methyl cyclobutane, right? No problem. Now see, same carbon, 4 and 4, then preference should be given to cyclic. 1 2 3 4, 1 butyl cyclobutane. Now here this is having double bond, so 1 2 3 4, 3 pentyl cyclobutane, 3 pentyl cyclobutane, right? Now this is having 4, that is having 5, so 1 2 3 4 5, 1 cyclobutyl, this is cyclobutyl, 1 cyclobutyl pentane. Now that one, just see this is having double bond, 1 2, 1 cyclobutyl ethane. First of all, do let me know all type, each and everything in one slide, it's clear. Then I will come to bicyclo and then spiro, then it will get completed. Till now it's clear to each and everyone, just to let me know. Show me green hearts. What's happening, kids? Hey kids, everyone, show me green hearts if it's clear. Where is your Josh? I cannot see your Josh. Kids, are you following the rules? You are liking it? Are you enjoying it? Or you need something else? Do let me know in the chat section. Do let me know in the chats and hit the like button, kids. Everyone hit the like button, kids. Hit the like button if you're really liking it, kids. Your Baba HSP's class. Each and every concept is getting clear. Baba break, I will give you at 10. At 10 I will give you. At 10 p.m. I will give you one break, okay? Okay, just wait. Now see bicyclo. Bicyclo is divided in two parts. Fused bicyclo and bridge bicyclo. Just try to understand what's the difference in between these two. Fused bicyclo and bridge bicyclo, okay? Just try to understand the difference. Will you? Just to let me know, will you try? Yes, sir. Definitely. Now see, fused. Or like this. Two cycles are there and two cycles are fused over here. Can you see? Fused. Now if I write down bridge bicyclo, then I will write like this. Just try to see the difference. If I write down like this, this is fused. Can you see the difference? I don't think you can see the difference. No. No one is able to see the difference. So I will take another page, then once again I will tell you. I don't think you are able to understand the difference in between these two. So once again try to see. Sir, I will try. Here only. Okay, just see. These are bridgehead carbons. Common carbon. Two carbons are common. Bicyclo means two carbons are common in between two cycles. In between two cycles. Just see. This is having one band and that is also having one band, and this one is having 0. Here one band, two bands, that is also having two bands, and this one is having 0 band. Here one, two bands, one, two bands, 0, right? Can you see, kids? And in this, two bands, one band. Sir, we are unable to understand anything. Sir, we are really unable to understand. Take another page. Kids, am I right? You are not able to understand. Let me see the chat. No one is able to understand. Do let me know. What is bands? Yeah. So no one is able to understand. Really? So let me make it clear, okay? So I am giving you one simple work, okay? Then it is going to get clear. Simple work. Now, suppose if I am having two carbons and 3 wires. How many wires? 3 wires, okay? So in the first wire, I have not given any band. Directly I have attached to it. Directly I have attached to this. Directly I have attached. Without giving any curve. Bent, no bent. Now, second wire, I have given 1 band, 2 bands and 3 bands. And the third wire, I have given 1, 2, 3 bands like this. I got bicyclo. Now I will say this is my common carbon, and these common carbons are known as bridge head carbon. What? Bridge head carbon. Which carbon? The white one. These two carbons are common in between two rings. Now see what I want to tell you. This is having that it's turning like one band, 2, 3. Now you're getting 3 bands. It is having 1, 2, and this is having 0. Can you see? This is having 2, this is having 3, that is having 0 band. Now you are able to understand bands. Now how to write down its IUPAC name? Bicyclo decreasing order bands 3.2.0, and total carbons are 3, 2, 5, 6, 7. So heptane. Now I think a little bit you are able to understand. This time little bit you are able to understand. Something you got. Now how many of you want to understand totally? Now see, let me show you another one. Just see another one. These are 2 common carbons. Now see, I'm going to draw the bands. 1, 2, 3, Zupac. 1, 2, Zupac. Now this is bicyclo. Now see, bicyclo, what I will write? 1, 2, 3. 1, 2, 1, 3. Dot 2.1 octane. Now I think you are able to understand. See, these are common carbons, bridge head carbon. Now 1, 2, 3 bands, 1, 2 bands, and this is having 1 band. Now I think a little bit clarity is coming. Okay, those who are still unable to understand, then let me show you. Already this compound is made like this. Now try to understand the answer. These 2 are common carbons. Now this side how many bands? 1, 2. And that side how many bands? 1, 2. Here how many bands? 1. So what I should write? Bicyclo. Then what should I write? 2.2.1 heptane. How many of you got the clarity, kids? How many of you got the clarity? Now, if you really got it, then I will tell you 3D model of it. Just see the 3D model of it. If you really got it, then only I will show you the 3D model. 3D model. See, kids, if they have given you compound like this, they can give you like this also. See, kids, this is 3D model. Now how to understand it? See, this is the bridgehead carbon. I can draw it like this, bridgehead carbon, right? Now this is having 2 bands, so I have drawn 2 bands. That is having 1, 2, 3 bands. 1, 2, 3 bands. Now that is having 1 band. So these 2 are same. This is 2D and that is 3D. So its name will be bicyclo 3.2.1 octane. I think that bicyclo it's clear. If it is clear, then I want to see green hearts. Kids, I have tried my level best with all No, let me tell you what is the difference between fused and bridge. Okay. Some kids are asking difference between fused and bridge. Okay, let me show you. In fused, at least there is one thing that is combining it directly. This line is combining it directly. That means bicyclo 2,2,0 hexane. That means 1 0 will be there. 1 0 will be there. In bridge, there will be no 0. Nobody will be 0. Means without 0 bent, like this. Like this, all they are bridge. No 0 bent. Without 0 bent. Without 0 bent. Means these are the bends. These are the bends. Are you getting my point? And these are the bridge head carbons. Bridge head carbons. Are you getting my point, kids? Now I think it's clear what's the difference between bridge and fused. Everything is clear, then show me green hearts. If really it's clear, kids, then last one, I will tell you spiro and then it's clear. It's clear. Kids, I want to see green hearts if really it's clear. Everyone, fast. I want to see green hearts. Break, I will give you. Let me start GOC. Let me teach inductive effect, then I will give you a break. It's once let me teach inductive effect and its application, then I will give you a break. Okay. Now, spiro. Spiro means only one carbon is common in between two rings. In between two rings. So simplest or smallest spiro is spiro. Now it's having two bends, that is also having two bends. Total 5 carbons. Now carbons were same. If the carbons are not common, means not same, then who will get preference? See, in bicyclo we have written in decreasing order. Here we will write in increasing order. There we have written in bicyclo we were writing in decreasing order. See, decreasing order. The numbers were written in decreasing order. See, decreasing. But in spiro, we will write in increasing order. Now see, this is the common carbon. 1, 2 bands. 1, 2, 3. So spiro hexane. I hope this is clear to each and everyone. So IUPAC is done and dusted. Done and dusted. I want to see number of colored hearts. Yeah, I will tell you electron displacement, each and everything. I am not going to leave anything, but kids, how is the Josh? How much you are enjoying? Let me see, kids. Let me sit in the front of chat section and let me check it out. Really you are enjoying, kids? Do let me know in the chat section. I want to read it out what you people are saying and why the likes are less. Break I will give, kids. I will give at 10. At 10 or 10:15, kids. At 10 or 10:15. You will get one break, kids. Please. At Once let me start GOC, please kids. Please kids. Bacha. Wow, real winter, thank you, please. Please kids. Let me start, please. Bacha, please. Wow, thank you, learn swear. Break I will give you. I look like Shah Rukh Khan, Prajwal Reddy. I am a simple teacher. Wow, kids really liking, really loving the way you are writing. You are liking my teaching, kids. Are you really liking? Are you enjoying, kids? Do let me know in the chat. Really, you are enjoying? Thank you, Afifa Sheikh. Thank you, kids, for your love and support. So hit the like button, make it 1.2. Make it 1.2, kids. We are loving. Thank you. Oh my God. Thank you. We are not only liking, we are loving. Wow. So nice of you. Now make a promise that you will study reaction mechanism GOC. Thank you, Prajwal Reddy. Make a promise that you will study GOC with full with full mind. With full mind, you are going to really get reaction mechanism. That is GOC reaction mechanism in GOC part 1. That is GOC part 1 I am going to take. Okay. Thank you. Thank you, kids. So let me start GOC. Everyone, are you ready for GOC? Let me start with GOC. Okay, before I start GOC, this is your Baba HSP. In GOC, first I will tell you inductive effect. See, this is your Haren Singh Parhyar, chemistry expert. I've done MTech from HBTI Kanpur, GATE, MSc, JRF qualified. It's not 20, already 26 plus years. Now produced AIR 1 to 17, a number of selections, right? Now, before I move towards GOC, I want to show you something, kids, right? That is the thing for your future, related to your future, kids. Do you know who is he? Do you know? R. Wasim sir, right? So, join NCERT Crux test series for NEET UG 2025. Enroll now just for rupees 799, kids, and get access to all these things. Okay. Now, second thing, this is the most important thing, kids. I would like to tell you, this is the most important thing. Unacademy unlock the champion in you. Flat 60% off on all NEET UG subscriptions. Start your NEET. This you can share it to your friends, your classmates, your relatives, and this is for you people also. Now, it's available just for rupees 4,499 if you put code HSP10 without any gap along with my mentorship. What is the code? HSP10. HSP10. This is the code, right? Flat 60% off. You can tell, you can help, you can share it to others. If you're helping it, you know that sharing is caring, and really if you are helping others, Almighty God is there to help you a lot, kids. Right? Will you do that? Let me see in the chat section what you say, kids. What do you say, kids? Will you help others? Will you help yourself, others? Do let me know. If you are helping even a single child, Almighty God is really going to help you a lot, kids. No, Jaswant, it will not, cutoff will not increase. It's our thought process. We are thinking like this. There are number of seats. Bacha, kids. Wow. Now, kids, I'm going to start GOC. Now, let me start GOC. Then free mock tests are also there before actual exam. See, 10 free mock tests before actual exam. Your gateway to NEET UG 2025 success along with this. And this is 13 April 2 to 5 p.m. kids. Now, test flow is like this. Join Nimbus batch, Titans batch, Nexus batch, this Nimbus batch. Number of batches are there, kids, and plus and iconic features are there, and rest of the things I already have explained now. So let me move, kids, to our GOC. The backbone of organic chemistry. Are you ready for GOC, kids? Before your break, I'm going to start with the GOC, kids, and I was telling you this is your Baba HSP. And in the sequence, I was about to start the isomerism, but on public demand, on your demand, I'm going to start GOC, okay? GOC, I am going to start GOC. Let's kill it, kids, GOC. Now, in GOC, I will start with reaction mechanism. Some people also call it reaction mechanism. GOC full form is General Organic Chemistry. General Organic Chemistry. Some people also call it reaction mechanism part 1. What do you call it? Reaction mechanism part 1. What is included in GOC? What I'm going to tell you, let me tell you. First of all, let me tell you the bifurcation of GOC. Okay, let me tell you, kids, what I will tell you over here. You should know, you have got full right to know, sir, what you are going to tell us. Okay, let me tell you in this GOC, what things I'm going to tell you, kids. Inductive effect. What? Inductive effect and its application. Inductive effect and its application, right? Whatever I am writing, it will come over here. Inductive effect and its application. Second thing I will tell you, hyperconjugation and its application. Hyperconjugation and its applications, right? Hyperconjugation and its applications. Now then I will let you know mesomeric effect and its applications. Mesomeric effect and its application, and this is also known as what? Resonance. Resonance, kids. Okay, Now, once you understand these things, their applications, along with their applications, you will say, kids, now, yeah, that now I'm very, very good in organic chemistry. Now you have to apply your full brain. These four things holds a hell lot of weightage. I would like to say these four things are the backbone of organic chemistry. Let me tell you, kids, these four things are really the backbone of organic chemistry. I would like to say backbone of OG, organic chemistry. But you have to apply full brain, kids. You have to go through it. You have to keep the things in your brain. Let me see in the chat section. Are you ready with this? Not you have to sit silently. You have to answer. You have to show green hearts, really, if you're liking it and if you are able to give the correct answer. First of all, make a promise that yes, whenever you need break, I will give you, kids. I'm with you. But you have to make a promise that yes, sir, we are ready for this. Everyone is asking for break, kids. First of all, I have told you that even I am in need of break. You know, I'm taking here IIT JEE and Advanced at Jaipur offline. I'm taking IIT JEE and Advanced, right? Now, kids, it's for you right now. I'm not asking to give break or not to give break. First, I will teach inductive effect and its application. Then only I will give break. After getting your response for inductive effect and its application, then only I can give you break, kids. Yeah, I will complete hydrocarbon. This class will go. I will not take care of whatever the time is going on. That I will not think. Even if it is going to be morning 5, I'm here to take the class. I'm not thinking of the time, kids. I'm there. I will teach. I will complete each and everything. Okay. So, let's it go. Let's it go, kids. Now, let me start with inductive effect. Are you ready? Let me start with inductive effect. Inductive effect. Okay. So, kids, before I start inductive effect, you just take your copy. And hit it like this. This is the page of the copy. Hit with the pen like this, vertically like this. Once you have done this, you have applied force. Now turn your page and just put your finger below the page. Just put your finger below the page where you have applied force. What you feel that the page has gone a little bit on the other side, but page has not left any space. It has not torn out. It has displaced slightly towards the other side. Now see the second page, little bit less effect is there. Now see the third page. Some of you can feel the effect and others can't feel. Now see the fourth page. Some of you still can feel. Now what does it mean? That some books write that it is valid up to 4th carbon, some are writing 5th carbon, some are writing 2nd carbon, some are writing 3rd carbon. So see what happens, kids. Just see what actually happens. If I say carbon, 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 all the carbons, if I say they have catenation, no problem till now, no problem till now, they all are having catenation, the electron distribution is equally. But suppose one carbon is attached with halogen, any halogen, this is halogen, so who is being more electronegative? Then definitely halogen is more electronegative than carbon. So this halogen is more electronegative, it's more electronegative. So what it will do? It will try to withdraw these electrons towards that side and it will get partial negative charge. So that is electron withdrawing group, and this is electron donating group, so we'll get partial positive charge. Am I right? This carbon will get little bit less charge and this carbon will get lesser charge, and according to system they are saying that this effect is valid up to third carbon atom. Rest of the carbons are not getting any effect. But if you see all the pages, they all are affected, but this effect is decreasing as we go away. That means if we go away from this, if we go away from this halogen on this side, the inductive effect, this effect decreases. So this is distance dependent. As we go away from it, the effect of this halogen or any other electronegative effect, any other electronegative atom is getting decreased. So how to define inductive effect? So I would like to say how to define it. So see the definition. Inductive effect is defined as the permanent effect in which electron is slightly shifted towards more electronegative atom, forming a covalent bond. Remember that, forming a covalent bond. It's valid up to third carbon atom. Decreases with increase in distance, decreases with increase in distance, right? Decreases with increase in distance. So if I make benzene ring, I hope this one is clear, this page is clear to each and everyone. Any doubt you can ask. Generally what happens in online, students are not able to ask the doubt, but you know, this is your Baba HSP. If you have any doubt, you can ask. I'm here to answer it. Any doubt you can ask. Most welcome, kids. Any doubt, you are most welcome, kids. You can ask your doubt. You can clear your doubts. Any doubt, kids. I'm here to answer your any doubt. That's the most important thing, kids. Yeah, I will give you questions. Okay. Yeah. After third carbon, it becomes negligible. After third carbon, it becomes negligible. After third carbon, becomes negligible, It is valid up to third carbon. For example, let me show you. If I draw this benzene ring, and if I add some group over here, this X, now it is attached over here, so this is known as ortho with respect to that. This is meta and this is para. What will you say? Once it is going to withdraw the electron, from where the effect will be maximum, it's del negative. So this will have maximum del positive, am I right? This will have little bit del positive and this will have least del positive. So I would like to say inductive effect will be maximum at ortho, then meta, and least will be at para. Gets right? Now you are able to understand. Then I will explain with the help of questions, but till now this is clear, this is clear, this is clear. If each and everything is coming to your brain, if it is getting clear, then only you will be able to answer the questions. Now see the kids, these are two types. Inductive effect is of two types. Just see what are these two types. You have to know the order, kids. If you really want to answer the questions, you have to understand each and everything. Inductive effect is mainly of two types. Inductive effect is mainly of two types. Just see. One is being plus I, another one is being minus I. What do you mean by plus I and minus I? This is the most important thing, plus I and minus I. When we are getting plus charge, when somebody is donating electron, like NaCl, Na has donated electron, the one who is donor, electron donor, remember that electron donor is plus I. Who is minus I? Cl has gained electron acceptor. This is the most important thing, kids. Electron acceptor is. That's why this is known as EDG. EDG. What do you mean by EDG? Electron donating group, kids. Electron donating group. Are you getting my point? And what do you mean by this? Electron withdrawing group. Okay, now I'm going to give you the whole power of these minus I and plus I. Plus I, the donor, minus I, the acceptor. Now see, kids, all minus I will write down. Minus I means electron withdrawing groups. Are you ready? Then only you can answer the questions. Kids, do let me know. Are you ready? And you have to remember it. You have to learn it. Then only you can kill the question. Just see. NF3 positive. NF3 positive. NR3 positive. SR2 positive. NH3 positive. Now how will you learn it? That is the $1 million question. Now I'm going to give you a trick. Otherwise you won't be able to answer the questions. I'm going to give you a trick. If you want to have it, you can have it. Okay, let me see how many of you want to know that trick. If you don't need, no problem. You can learn it like this. If you really want trick, then write down. Yes, no break right now. I'm not going to give you break, kids. I want to teach. You have to study. How many of you want trick? Write down fast. Then only I will give trick, because without trick you won't be able to do the questions. Okay, everyone is writing that you need trick. Okay, see. New friend Narayan. What I'm writing? New friend Narayan. What I'm writing? New friend Narayan. New friend Narayan. New friend Narayan. Gone to your brain. New friend Narayan along with Shahrukh and positively charged Neha. Along with Shahrukh and positive charge Neha. Is it okay? Along with Shahrukh. Along with Shahrukh and along with Shahrukh and Neha, positive charge Neha, right? Along with Shahrukh and Neha. One line is clear. Now second line. This was the first line. Now let's see the second line. Second line means after this, right? Second line will be after this. Now see. NO2 SO3H CN RCHO COOH. Now what is the trick for this? Naughty Salman created scene in Rancho's car. What is the trick? Naughty Salman, naughty Salman created scene in Rancho's car. Naughty Salman created scene in Rancho's car. Now two lines are clear. You're liking the trick. If really you're liking it, then I will complete it and I will give you complete trick kits. Do let me know in the chat section. Let me see that how many of you are really loving it. No one is going to give you a trick like this, and that's why people are not able to solve the questions. Yeah, those who have given cyanide this side, that's wrong. Remember that this is the correct one. And that's why Naughty Salman created scene in Rancho's car. This is perfect. This is the true one. Cyanide is not greater than SO3H. Wrong. If anywhere it is given, it's not correct. Clear? This much is clear, kids. Thank you, Sahana. Thank you. Thank you. If you remember it, then only you can solve the questions, kids. Let me complete it. Let me complete it. Let me complete it. Got it? No. Let me complete it. C category. Category C. Let me write down C1. COR. Halogens. In halogens, fluorine, then chlorine, then bromine, then iodine, then OR, alkoxy, then hydroxy. Remember these two. These two are very, very important. People are doing mistake over here also. In these two also people are doing mistakes. So remember this. This was the C category. Now see D category. In D, there is nothing. Amine, then phenyl, then hydrogen. It's like this. Total I have given minus I. You have to remember it, otherwise you won't be able to do the question. This is the sequence. Clear? Can you keep it A, B, C, D? 4 categories. Can you keep it in your brain? If yes, I want to see green hearts. Then only I will tell you plus I, and then I will tell you the application. Kids, don't worry for the break. Kids, we have to study number of things. Kids, fast. So everyone just repeat what I have written. New friend Narayan along with Shahrukh and Neha. Say everyone, new friend. Kids, otherwise I'm not going to tell you. You have to repeat along with me. If you're not repeating, then what's the use giving this trick? Kids, along with me, you have to repeat what I'm saying. Just see what I'm saying. New friend Narayan. Everyone say new friend. Kids, if you're thinking that you are very, very intelligent, you won't be able to solve the questions. Really, if you want to get 100% marks, say new friend Narayan, along with Shahrukh and Neha. Where Neha has gone? Neha is missing. Oh my God. Let me write down Neha once again. Where Neha has gone? Oh my God, what is this? So everyone say once again, everyone just say new friend Narayan along with Shahrukh and Neha. Repeat, I want to see the chat. New friend Narayan along with Shahrukh and Neha. Repeat it fast. New friend Narayan along with Shahrukh and Neha. Once again kids. New friend Narayan along with Shahrukh and Neha. Now after this, naughty Salman created scene in Rancho's car. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. If these two lines are clear, these are the longest one, then you can do all the questions. Once again, just show me green hearts if these two lines are clear to all of you. I want to see green hearts if these two lines are really clear to all of you kids. Fast. You have to follow what I'm telling you, then only you can do all the questions. Otherwise not. Everyone write on the chat section. Everyone, really I want to see your energy level. New friend. New friend Narayan along with Shahrukh and Neha. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. New friend Narayan along with Shahrukh and Neha. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. Now, I think it's clear to each and every one of you. Now, I'm going to give you the order for plus I. Plus I means electron donating groups. The one category, A category, negative charge. There, the category 1 was, the first liner one was positive charge. Although they are being electronegative atom and they are withdrawing electron, they are already electronegative elements and they are having plus charge. This is substituted with fluorine. Fluorine is maximum electronegative. All three fluorines were pulling electrons. So now see the first line, I will say negative charge one, CH2 negative. NH2 negative. CH2 negative. CH2 negative. NH2 negative, O negative, COO negative. This is stabilized by resonance, stabilized by SPR. SPR means stabilized by resonance. So this is the order. No trick for this because they are based on electronegativity, so no trick. Now B category. More the number of alkyl groups, more will be plus I. Remember that. More the number of alkyl groups, more will be plus I. Now CH2, CH3, and if I talk over here the isotopic effect, then I will say CH2. So let not compare hyperconjugation over here. I will write just the isotopic effect CT3, CD3 and CH3. In these three there is being isotopic effect. If you want to know the isotopic effect, I will tell you here. It's isotopic effect. Let me tell you about isotopic effect. Here it's applicable isotopic effect. Because if tough questions are coming in your examination, then they will ask based on isotopic effect. Let me explain it, okay? Let me show you this isotopic effect. See, if I make bond of carbon with protium, so protium bond length is less, so it's like this. If I make carbon's bond with deuterium, then deuterium is donating more electrons, so it's over here. And if I make for tritium, although tritium is found in very small amount, it's being radioactive, so tritium will be hits very. So tritium will lie over here. Now let's compare these two, because tritium 1,3, that means N by P ratio is 2/1, the most radioactive. So it is not found or very less found in nature. So let me show you this one. Remember that more the number of electrons. So how the electrons will be more? They are isotopes. They all will have same electrons, but according to meson theory, that transition is happening. So let me write down over here, more the mass, more will be electron donation. Now don't think like that they all are having one electron, then how the more electron donation? That is due to meson theory, but not required. More the electron donation, smaller will be the bond length, smaller will be the bond length. Smaller will be the bond length. So who is donating more electron? This is maximum electron donor, and that is least. Whenever tough question is going to be asked in the examination, they will ask based on this. Let me see, kids. Everyone was in need of break, but kids, you know, that's for you people only. I'm not giving break. Please forgive me, kids. Please. I'm doing each and everything for you people only. Just say that you are not thinking bad for me. Oh, very good, Sahana. Very good, Sahana. That's really awesome. E. coli R by. Please, kids, do let me know that you are not going to scold me. It's for you people only, kids. Khana khane de. Dinner break. At least let me explain one application, please. Oh, brain is not working. Okay. Okay, I will do one thing. How many, just wait. How many of you need break? I will give at 10:30. Okay, I will give at 10:30. How many of you want? How many of you want break? Then I will give at 10:30. Real winter, thank you. How many of you want break at 10:30? Let me check it out. Okay, no need of break. See, kids. Okay, continue. See, so let me continue, then I will give break. Okay, let me first continue. Now see, kids. Let's see, kids. You are really genius. Really genius. And see, let me show you that kids, they are not in need of break. Just let me show you where to show. Let me show you, kids. See. Continue. See, kids. Down, number 1 is also there. See, kids. Just see, kids. Just see. Dinner break I will give you at At 11 I will give you break. At 11 p.m. I will give one break. Okay, at 11 p.m. Sure, for sure, at 11 p.m. I'm promising you, kids. At 11 p.m. I will give you one break. Done. At 11 p.m. I will give you one break. First break. Just do let me know in the chat section. At 11 p.m. I will give you one break, kids. At 11 p.m. I will give you one break. Okay, very good. At 11 p.m. Okay, at 10:30. Okay. How? 10:30 I will give you first break. Okay, it's 10:30. Some people are saying that charging is required. They want to charge their mobile, kids. They want to charge their mobile. So it's done. 10:30. Okay, 10:30. Done at 10:30, right? So applications. Let's see the applications. Applications of inductive effect, right? How many applications we will deal with? Total 5. First, the stability of carbocation. Second, the stability of carbanion. Third, the stability of free radical. Fourth, the acidic strength of carboxylic acid. And fifth, the basic strength of bases. Okay, these 5 applications we are going to deal with, in total 5. First application is stability of carbocation. But for that, just see what is being carbocation. Just see carbocation. Everyone, do you know carbocation? What is carbocation? First is stability comparison. Carbocations. What's another name for carbocations? Carbonium ion, or according to IUPAC, carbanium ion. According to IUPAC, right? How these carbocations look like? Cr3 plus, only 6 electrons in valence shell with positive charge. electron deficient entities. Electrophile, Lewis acids. So they are in need of electrons. They are in need of electron. They are beggars. Electrons is like money and atoms like human beings. Remember that, what I'm teaching. And what always I say, I always treat electron like money. I always treat electron as like money. And I always tell my students that atoms are like human beings. Atoms are like human beings. This is the best analogy. We can see human beings. We are thinking that everything responsible is human beings. Human beings are getting bonded. But the thing responsible for making bonds is the money, 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 money. Am I right, kids? This is my analogy, and I move like this only. We cannot see electron, the money, with our naked eye, but we can see human beings. Human beings are going to purchase pizza. They will donate money. Pizza one will take money. Now, see, kids. Just see how you will understand easily. Let me make you perfect in this, right? Let me have a sip of water, kids. Keep on drinking water. It's very high temperature, so keep yourself hydrated. Now remember one rule. Whenever you do question, remember the rule. What's the rule? Doctor, nurses and purses. What's that? Doctor, nurses and purses. Can you make it clear what's this doctor, nurses and purses? Whenever there is tie, we will give preference to distance, then number, then power. Whenever there is tie, always give preference to distance rule, number rule, power rule. Distance rule, number rule, power rule. Okay, whenever there is tie, whenever there is any problem, that remember distance, number, power rule, DNP rule. Which rule? DNP rule. Will you be able to keep it in your brain, kids? Just to let me know, DNP rule, always whenever there is any problem, always we have to follow distance, nurses, person. Distance, number and power rule. Very good. Now see, kids, I'm going to frame out one question. Just see to it. Everyone, just see to it. Carbon plus charge, CH3. This is the simple most which you will study at your school level. Tertiary butyl. Another one, C positive, CH3, hydrogen, isopropyl. Now, C positive, CH3, H. Now the last one, but not the least one, carbon positive, H. I'm going to give you the feel. Just see. Now this carbon is saying, hey, I'm having only 6 electrons. Mamma mia, I'm having only 6 electrons. So neighbors are saying, hey, carbon, don't cry. I will donate electrons. Medhuva, slowly, gradually, we are donating electron, because we are electron donor, electron donating groups. So they are donating electron, kids. they are donating electrons. So this is feeling very good. Hey, I'm getting electron from this side, this side, this side, all the three sides I'm getting electron. Yay, I'm feeling happy. I'm so happy. So carbon is getting electron from all the three sides. Carbon is feeling happy that wow, although whatever the electrons are coming, they are not one electron, they are just partial. So it is having +1 charge, but they are decreasing. Suppose it is donating 0.1, 0.1, 0.1, so only 0.3 electrons are coming. So the charge will not go completely, it will be present. So suppose if it is giving 0.2, 0.2, 0.2, then 0.2, 0.2, 0.2, 0.6, but this is complete one positive charge. Still the charge will remain over there. Now kids, if I say by chance this one is donating 0.1, 0.1, 0.1, 0.1, all three are donating 0.1, 0.1, 0.1, 0.1, 0.1, 0.1. So still the charge is 0.7 over there, but charge is decreasing from all the three sides. So stability is increasing. One point is clear. If you see here, this is donating and this is donating. So charge is decreasing. The magnitude of positive charge is decreasing. So stability is increasing this much. Here only one alkyl group, so charge is decreasing 1 times, so stability increasing. All they are electron deficient, but who is the least electron deficient? Here the charge dispersal is maximum dispersal of charge. I hope that, because see kids, if I tell you in this the charge is getting dispersed from three sides. The charge is getting dispersed from three sides. Here the charge is getting dispersed from three sides. Just see three sides. Here only from two sides, and here from one side, and there no charge dispersion is there. Kids, see, just see, let me show you that from this, in this, charge is getting dispersed from three sides, from two sides, from one side, and no dispersal of charge. So this is having least charge because all three friends are helping. These three friends are helping. Here only two friends are helping. Here only one friend is helping. There is no friend. Can you see, kids? Are you getting it? Just to let me know in the chat section the what I'm trying, my hard work you are getting. So this is the order of stability, and I would like to say that the carbon is attached with 3 carbons is not known as 3-degree carbon. The carbon which is attached with 3 carbons, 3 degree, 2 degree, 1 degree, and 1 degree. One point is clear, the stability order in this way. This is more stable than this, and then this. So this is the stability order. Let me see your reaction in the chat, how much you are really got it, kids. The first try, how much clarity is there, kids? Show me green hearts if really you are liking it. If you really got it, kids, do let me know in the chat section. Everyone. I want to see your reaction. The way I was explaining how much you liked it. But bacha, I'm not going to replace it with ethyl, because then hyperconjugation will come into play. Somebody is asking, if we replace methyl with ethyl, then number of alpha hydrogens will decrease and the hyperconjugation will come into play. Till now I haven't explained hyperconjugation, so I will not put ethyl. Okay, now see, kids, if this is clear, then let me, I would like to ask the questions. Okay, you have to answer the questions, kids, right? So plus charge, plus charge, plus charge, plus charge. Okay, now let me write down, this is being A, this is being B, this is being C, and this is being D. Before I put over here anything, okay, before I put over here anything, right, first of all, do let me know who is the friend, who is the friend of carbocation. Carbocation are being electron deficient. So stability, if I ask you one simple question, stability of carbocation, stability of carbocation is directly proportional to whom and inversely proportional to him. So they are electron deficient, they are in need of electrons. So who is electron donor? Plus I. So plus I will act as their friends and minus I will act as their enemy. Am I right or not? And the kids who are always getting confused, remember that a friend in need is friend indeed. Poison kills poison, money begets money. The carbocation is having plus charge. The one who is having plus charge, its friend will have plus charge. Nice trick. If you can't get it, plus friend is plus, minus friend will be minus. This is the trick. You're liking my kids on, are you liking my tricks? Let me know in the chat section. Really enjoying my tricks? Whatever the tricks I'm giving you, kids. Oh, it's 10:30. Okay, break time. Okay, kids. And let me give you 1-2 questions, then I will give you break. Okay. Okay. I will give at 10:40, kids. Sure, for sure I will give. I will give at 10:40. Okay. Super duper tricks. Thank you kids, thank you. Now this is a trick. Now see, okay, let me give some questions, then I will give you a break. Okay, kids, don't worry, let's practice some questions, then definitely, really kids, for sure I will give you a break. Yeah, yes. रुको, आप चले जाओ, अच्छा। Kids, you must be thinking where Baba has gone. Somebody was there. I told him just to bring something for dinner. I was managing for dinner. Okay, let me see what's your reaction. What's your reaction? What do you say, kids? I asked him to bring something for my dinner. Okay, now see, kids. What happened? It's stuck. Okay. So, break, I'm going to give you one question, then break. One question, then break. One question, then break. Okay. If I put here NO2, if I put here chlorine, if I put here nothing, and if I put here methyl, then do let me know the order. Most stable, then less in decreasing order. Stability in decreasing order. Stability in decreasing order. Let me see the chat. Let me see the chat. Let me sit in front of screen and let me see. D, C, A, B. Sahana, oh my God. That's really... Wow, fantastic. Your answer is 100% correct, Sahana. Marvelous, marvelous. Now see, kids, how to do it. See, this is the friend plus I. Plus I is the friend. It will donate electron. It will donate electron. See, it will donate electron to this and charge will get decreased. Charge will get decreased. It is going to donate electron, kids. Charge will decrease. Are you getting my point? Definitely it is going to donate electron, the electron donation, so charge will decrease. It is getting help of electrons, so charge will get decreased. Now see, kids, here no friend, and these two are enemies. They are electron withdrawing groups. Can you see, kids? They are being electron withdrawing groups. They are electron withdrawing groups. They will withdraw electron. They are withdrawing electron and charge is getting increased. This is having more power, and this is having less power. So it will also increase the charge, but not that much. So most stable is D with the least charge. D, then C, then B, then A. This is the stability order. How many of you got it, kids? Show me green hearts if you really got it. If you really got it, I want to see green hearts in the chat section. Really, if you got it. Now, second question. Then after 2-3 questions, sir, it was DCBA. DCBA. Yes, it's DCBA. Yeah. It's Sahana wrote DCAB. Oh, ho. Sorry, kids. It's DCBA only. DCBA only. Now let me give you some questions, then I will give you break. The second question, just see the second question. If I write down over here, Cl, 2Cl, here 1Cl, here 2NO2, and here 2 methyls. Now tell me the order. Let me check it out. What's the correct answer? Wow, kids, you are really enjoying. Wow. Break, I am just giving in 2 minutes. Just in 2 minutes, I am giving the break, kids. Really, I am going to give you. At 10:40, yeah, 1-2 minute. I am just giving in 1-2 minute, kids. Sorry, kids. Just within 1 or 2 minutes. I'm sorry. I'm going to give you a break. Now, see, kids. This is plus I. They are donating electron. They are just donating electron. Can you see? They are electron donor. So the electron is going like this, and charge is getting decreased, right? charge is getting decreased. And these are electron withdrawing, they are withdrawing electron, they are withdrawing in this way. So charge is increased. Are you getting my point? Charge is increased too much because its power is also too much. Here also they are withdrawing electron withdrawer, minus I, powerful minus I. So charge is increased, and this one also electron withdrawing group minus I. So charge is increased, right? Can you see how the charge is moving, kids? Can you see how the charge is moving? Everyone just see. They are donor, electron donor. They are just electron donor. Can you see? They are donating electrons. So it's getting help. And these are electron withdrawing. They are electron withdrawing. So they are just increasing the magnitude of charge. Can you see how the charge is moving? Which side the charge is moving? Can you see, kids? So which one is having least charge? You can see very clearly, kids. Everyone, can you see very clearly? Everyone, just to let me know it's clear or not, which side electron is flowing. Is it clear? Are you getting my point, kids? Just to let me know. It's a nice representation I'm showing you, kids. Do let me know the nice representation I'm showing you. This is giving electron and they are taking electrons. So the flow is like this, flow is like this, flow is like this. Can you see the electron flow, which direction the electron is flowing, kids? They are donating electron, they are withdrawing electron, it's withdrawing electrons. So it is maximum electron withdrawing because its power is maximum. This power is less, but 2, there is only 1. Nice representation, kids. If you are really liking it, the way I am explaining, the way I am using this technical thing. So D is at the best. After D it's B. After D it's B, and after B D, then B, then A, then C. If this was your answer, and now I'm going to give you a break, then show green hearts for yourself if this was your answer. After this I'm going to give break. Okay, now the break time, really the break time. Yeah, now I'm giving you break. Now tell me, show me green hearts if you're really liking it, the way I'm trying my efforts, kids. Really liking it, then show me green hearts. Now I will give you break for dinner break. It's 45. That means it's 10:45. 11:20. Let's meet at 11:20. Okay. So let's meet at 11:20. It's break time, dinner time. Okay, kids. Okay. Say yes and thank you. Welcome back, all my dear students. Are you there? See my punctuality. Oh, I'm late by 5 minutes. Your Baba is late by 5 minutes, kids. Just give me a second, kids. Just a second. Hello. Sorry, kids. I was gone for just for a minute. Sorry for that. So, are you with full Josh? Am I audible and visible to all of you kids? Just to let me know. Fast, fast. Show me some fire in the chat section. Yeah, you will get in the Telegram channel. Don't worry. So, show me green hearts along with some fire in the chat section if you're ready. I want to see that. Let me send in front of the chat and let me check it out because my mobile is also got discharged. Let me put on charging and let me check it out, kids, how it's moving. Yeah, my kids, that's really fantastic. I can see the green hearts along with fire in the chat section. Wow, kids, I will give you the best knowledge, the best, because you deserve it. It's really awesome, really awesome. That's really fantastic. Yeah, let's it go. Let's it go now. Now see, kids, I'm going to give you one tough question, and then that will decide your knowledge. Okay, I'm going to give you one tough question, and that will decide your knowledge, right? Are you ready for that? Just do let me know. Are you ready for this, kids? Do let me know. Tough question, toughest question, one toughest question I'm going to give you, and let me check your knowledge, kids, right? So one toughest question I'm going to give you, kids. Let me put two NO2s at this place. Two NO2s at this place. Let me put one chlorine over here. Let me put one methyl at this place. And let me put one methyl at this place. Do let me know what's your answer for the stability in decreasing order. I'm waiting for your answer. Let me check it out. What answer you are going to give? Let me see in the chat section. Fast. Let me see the correct answer in the chat section, and those who are new to this channel. Okay, DCBA. Let me check it out. These two are friends. Divide and rule. Always go with divide and rule. These two are friends. These two are enemies. Now, here two enemies, but distance is too much. Here only one enemy, but it is nearest. So definitely it will withdraw maximum electrons. So here I would like to say DNP, distance, then number, then power. So this will increase charge. Too much charge will increase, charge increase, so stability decrease. Here distance is too much, so charge will increase only little bit, and this is too far, so its help will take time, so charge will decrease. And here it is nearer, so great help, charge will decrease too much. So maximum is D, then C, then A, then B, A, then B, A, then B. How many of you got correct answer? You can show green hearts for yourself. Your answer is correct for the stability order. This is the answer. Let me check it out. How many of you got the correct answer? Yes. Kids, do let me know in the chat section if your answer is found to be correct. Let me see, let me check it out in the chat section that your answer is correct. Yes, everyone, fast, quick. I can't see your green hearts. That means no one has got the correct answer. That's indicating, okay, if your answer is correct, yeah, now I can see. Now, that's really awesome. Now let's deal with carbanion stability. So I hope that everyone is ready for carbanion stability. Second application, that's carbanion stability order. Where the pen has gone. Yeah, can't see. Carbanion stability order. Carbanion. Now, what is carbanion? Just see, kids. Cr3 negative. Now you can see Cr3 negative. That's, I can show you like this. This is having one extra electron. It has taken one extra electron from somebody. Now protons are remaining same, but one extra electron. That means electron wants to go away. Electron wants to go away. That means carbon with negative charge. That means electron efficient. Electron efficient. Efficient means nucleophile. It loves somebody's nucleus where protons are residing, Lewis base, and it says I wanna what? Wanna donate electron. Wanna donate electrons. So I can say it's when electron donating groups, 8 electrons with a negative charge, extra electrons. So it wants to donate electron. Just give me a second. So kids, so this carbon in carbanion case wants to donate electrons. So carbon is having negative charge. Can you see? So will you answer one question? Will you answer one question? The stability of carbanion. If somebody is asking the stability of carbanion, so answer my question. Stability of carbanion. So what I've told you, the trick, once you do, let me know. This carbanion, carbon is having negative charge. Negative, who will be the friend of this negative one? Do let me know in the chat section. Will be directly proportional to what? Minus I, and inversely proportional to plus I. Now reverse order. The one who was helping carbocation is not helping over here. Can you get it? So it is acting as friend and this is acting as enemy. I hope this point is clear. Now you will never get confused. This is the best trick. This is the best trick. Once, even if you're forgetting it, then also it will work and you will never be in problem. That minus charge, so minus I friend. On carbocation there was plus charge, so plus I was the friend. How good is the trick? And I will not move in that way that you are not able to understand anything. I want to see, let me see in the chat section, you are liking this trick. The plus, somebody was having plus charge, then the plus I was the friend. Somebody is having negative charge, then gets Show me green hearts if you're really liking it, and then I will give question. Once again here, never forget to apply DNP rule. DNP rule, distance, number, power. This will always be applicable, so never forget it. Never forget to apply this distance, number, power. Now I'm going to give you question, okay? I hope that everyone is ready. Everyone is ready. Now I'm going to deal with the question. Now this time, in place of plus charge, what I'm going to do, I will put here negative charge, negative charge, negative charge, negative charge. Just see, I will put here negative charge because this is carbanion and this is being carbanion. So I will put here negative charge. The one who is decreasing this charge, the one who is being decreasing this charge will stabilize carbanion, right? And the one who is increasing charge, we will use the word intensifying. Remember the word. Let me tell you the word. What is the word I am telling you, kids? That word is anyone. That means if there is carbanion, if there is carbanion, if there is carbanion, see negative charge. So I would like to say minus I are decreasing or dispersal. They are responsible for dispersal of charge. This is a little bit tough English. So simple English is decreasing the magnitude of negative charge. Simple English is that is decreasing magnitude of negative charge. Decreasing magnitude of negative charge, and plus I for this, plus I are intensifying. This English you can get over there, intensifying this particular vocabulary, intensifying the charge, intensifying the charge, or simple English minus I, dispersal of charge. Yes, decreasing magnitude of, intensifying the, increasing magnitude of negative charge. I hope that everyone can understand this vocab. This is really important and required because it's not easy thing. They can give you the statement also, so you should know the statement, then only you can find out the correct answer. Otherwise it will be a tough situation if you're not able to understand these two things. Clear to each and everyone? Clear? Do let me know. So if these points are clear, then I'm going to explain, or I'm going to give you a question. This is negative charge. That means this is being carbanion and there is being carbanion. So the question, let's see whether you will be able to do it or not. If I put here NO2, if I put here fluorine, if I put here chlorine. Now tell me the order. I want to see the order in the chat. If you're really getting, let me check it out, the chat, what you're writing fast. And kids, hit the like button if you're new, and I want to see the sequence. Let me check it out how many of you can. Fantastic, kids. A, B, C, D. Now see, divide and rule, just eliminate. This is just having all plus I. This is all plus I. That means plus I, what plus I is doing? Plus I is donating electron. So the charge increased. Charge increased, stability decreased. Stability decreased, right? Now this is withdrawing electron. This is withdrawing electron. That means charge is getting decreased, stability is increased. This is powerful, better than this, because fluorine's minus I, electronegativity is more electronegativity, so more minus I, so it will withdraw electron better than chlorine. Am I right? So charge decreased more. And here NO2, one nitrogen and two oxygen, they are more powerful electron withdrawing group, so they are better electron withdrawing, so charge decrease very much. Can you see the order? Everyone just to let me know, those who are new, everyone just to let me know, can you see the order? Can you understand what I am telling you, kids? This is giving electron, this is giving electron, and they are withdrawing electron. They are withdrawing electron. This chlorine is withdrawing electron, and this is the withdrawing too much, and this is withdrawing less than NO2. So you can see clearly who is going to be more stable. So the answer is very much clear. You can easily answer that. This one, A, after A it's B, after B it's C, and after that it's D. How many of you got the correct answer? Congratulations, congratulations. If your answer is really correct, I want to see in the chat section. Yes, so I have got clear-cut answer. That answer is A, then B, then C, then D. Do let me know in the chat section. This is the stability order. I want to see in the chat section. Yes, just fast, kids, fast. One more question I will give you, and then I will proceed to free radical. Free radical, yes. Very good. That's really awesome. Really awesome. Everyone, you are getting the point. How many of you are getting for the first time? How many of you are really getting it for the first time? How many of you are able to understand it for the first time? Okay. Now, I'm going to give you a little bit tougher question. Let's see. If I put Cn at this place, if I put here N positive F3 over here, if I put one chlorine, one more chlorine over here, and if I put one methyl over here, then what do you think? What should be the order? Let me see in the chat section. What are you writing? What should be the order for stability? Then I will say you are genius or not. Let me decide. This is what you are asking for. What Sahana has said and what you are demanding for. Okay? Okay? Thank you, Sahana. Now, let me see whether your answer is right or wrong. See. Cyanide, NF3, this is having maximum minus I. Maximum minus I means maximum electron withdrawing, so charge will decrease. Now here charge will decrease. Now here their distance is too much. They are 3 but too much distance, so charge will decrease little much. But these are electron donating groups plus I, so charge will increase. So who is having least charge? So let me check it out. Your answer is right or wrong. Let me check it out. Your answer is right or wrong, kids. So most stable is B. After B, it's A. After A, it's C. And after C, it's D. How many of you got the correct answer? Green hearts for yourself. So Carbanion is done and dusted. If your answer is correct, then I would like to say Carbanion is done and dusted. If any doubt, you can ask. Let me check it out, the chat section. Any doubt? Then you can write on the chat section. Yes, any doubt you can write down in the chat section. Now free radical, third application is free radical stability, that is third application, free radical stability. Kids, you are not sitting alone, your Baba HSP is along with you, so don't think that you are alone and you are feeling like what's happening. I'm here, I'm over here, right, to help you a lot. Now see kids, free radical, what do you mean by free radical? Cr3 negative, it's like this, carbon R, and the electron is present in unhybridized pure p orbital. It is carbon with 7 electrons, carbon with only 7 electrons in valence shell. So it is electron efficient or deficient? Definitely everyone can let you know that electron deficient entity, electron deficient, but it cannot accept a lone pair, so it's only carbon deficient. So if I talk about inductive effect, then it will be like carbocation, right? Like carbocation. Electrons, so it's very simple. I can write down here the free radical. I can draw free radical and you can easily answer it. Easy question, you can easily answer it, that if I put here free radical, it's being free radical, it's being free radical, it's being free radical, it's being free radical. Now if I write it's 1 degree, and if I write down here it's methyl over here, so hyperconjugation will also be there. So this one I can write down like it's CH2, CH2. Now let me write down CH3. Now let me write down CH3 like this, and here let me write down CH3. Now tell me the stability order. So the answer will be very clear. Everyone can decode it, that no alkyl group is there, so it will be at the last. 3 alkyl groups are there, 3 alkyl groups are there. Can you see? So the C after C it will be B, after B it will be A, and after A it will be D. So it will be at the last. Done and dusted. Now it's new day started. So everyone, yes, thumbs up for yourself. New day started. Those who are with Baba HSP kids, these people, these students are the luckiest one, because you are having those guts to sit for this thing. This is going to give you future. Those who are not able to sit for this much of time, they can't do anything, because once you are going to become doctor, you have to do operation sometimes for the 7 hours, 8 hours. So let me see in the chat section that everyone is enjoying the new day. Good morning, good morning. Lalita, okay, I will explain. But everyone, I want to see the energy for the new day, Tuesday, that is Hanumanji's day. Good, good. I can see Sahana, happy views, Mahalakshmi, Gautami, everyone. That's really awesome, really awesome. Now see, why I have framed out this option. Once I'm going to teach hyperconjugation, I have to maintain this constant, all days constant. Now see, only this is getting help from this side. Can you see? One people is helping. Now in this two people are helping. This one is also helping and this one. So double help, it is getting double help. Now here this one is also helping, this one, this one. So number of people are helping this. So this will get maximum electrons. So this is most stable C. This is getting two help, two sides help, two friends. It is having one friend, no friend. Three side friend, three friends. It is having three friends. Friends are plus I, plus I. Three friends, three side help is coming. One friend, only one friend. It is having just one friend. And this is having two friends. 2 plus I. Now you got it. Lalita. Lalita, is it clear? Do let me know in the chat section. I am here to help you a lot. Is it clear, Lalita? Dawn number 1, welcome. You have to show your all the abilities because I know that you are very good. Okay, now the best thing, the fourth application. Fourth application is the best. Let me tell you kids, fourth application, that is acetic strength. Try to understand because number of questions will come from here. This portion, number of questions will be asked. See kids, acetic strength. I am going to tell you the acetic strength. Are you ready kids? Do let me know. Are you ready? Next application is acidic strength. Inductive effect application is acidic strength. Acidic strength. This is going to be the fourth application. Are you ready kids? Now, if I ask what is an acid, everyone will say the one who can donate proton. But remember that it is not going to donate proton. It's the aqueous medium, polar protic solvent like water, which is going to snatch its electron and it will become RCOO negative after electron donation. And this is weak acid, so there will be equilibrium. Remember that organic acids are weak acids. First of all, you should understand that organic acids are weak acids. Weak acids. So there is an equilibrium. Now this is having negative charge. If after donation of this proton it is getting negative charge, so charge means unstable. Remember that stability is, yes, inversely proportional to charge, and charge is like disease. Let me show you. Let me show you on another page. First of all, try to understand stability of any entity. Stability is inversely proportional to charge. Remember that what I call as charge, charge is like disease. If you eat too much, diabetes. If you eat less than protein, energy, malnutrition, kwashiorkor, marasmus, these are the diseases, or vitamin diseases, night blindness, scurvy, number of things. So whatever charge is there, whether it is plus charge or it is negative charge, if charge is there, stability is inversely proportional to charge. Remember that stability is inversely proportional to charge. If the charge is not there, then the entity is more stable than the charge entity. And if all the entities are having charge, then the entity with less charge is more stable. Remember that less is the charge, more is stability, right? Less is the charge, more will be stability. Am I right? Am I right? And my analogy, just see my analogy. Charge is like disease. Let me write down the analogy, the best analogy. Analogy Analogy. I treat charge like disease. Am I right, kids? This will make your studies simple. Simply you will become the best in your studies if you're going to follow it. This is Baba HSP's rule. Charge is like disease. Do let me know. Do let me know. Everyone just do let me know. This is the trick of Baba HSP. Charge is like disease. Less is the disease, better will be the human being. Sir, it is actually so effective. Oh my God, Aliza, Sayed, really? You're liking it, kids? I need your views. I need your comments. One kid has written, sir, it's really so effective to learn. Wow. I want to see your what you people are thinking. We love it, sir. Wow, that's really fantastic. Wow, fantastic. Okay. Give more analogies. Oh my God, really? Really you liking this analogy? Oh, thank you, Palak Goyal. Oh yeah, oh yeah, oh yeah, wow. That's really awesome. I'm so glad you're liking analogy. Wow. Now see, just see, kids. So can you see that it has become negatively charged? It has become negatively charged. So we have to think about the stability of this. This is acid. This is acid and this is known as conjugate base. Conjugate base. I can say, kids, I can tell you one more analogy. Suppose this is the hero or heroine and these people are having their jacket. Winter season they are having jacket, or this is the patient suffering with the diabetes and this is the Dionyl. This is the Dionyl, the tablet. This is the best thing. Let me write down. Let me write down, kids. Let me write down. Really, you will enjoy it. You are going to enjoy it. See, you will never forget. Never ever going to forget. If I say this is the person suffering with the diabetes, this charge is indicating diabetes. He is diabetic. Now, which tablet should be used in diabetes? That is Dionyl tablet, or I can say it's the medicine. It's the medicine. Do you think that the patient want to donate its medicine? No. But some people like the snatcher, they are trying to snatch. This is the snatcher. This is the enemy. This enemy is trying to snatch its tablet. Its tablet. This enemy is trying to snatch its tablet. Now this person is without that tablet. How is feeling? He is feeling, oh my God, right now he was having partial disease. Now he is having complete disease. So it is conjugate base is unstable. And the snatcher has snatched its tablet. This is the situation. Now, stability of an acid, the one who is more stable, the neighbors are helping by taking its electron. The one who is more stable, having less charge, will easily donate its medicine to the snatcher. What I'm saying, if this disease is less, he will not care about this medicine. If disease is less, he will easily donate its proton. The snatcher will come, hey, I want to snatch your tablet, otherwise I am going to kill you. He will say, oh, just take away. So can I say the one whose conjugate base is more stable can easily donate protons? So I can write acidic strength of an acid. I can write one statement that acidic strength of an acid is directly proportional to stability of conjugate base. Can I write like this? So this statement you must have studied hundred of times. This statement you must have studied. But this analogy of this analogy, how is the analogy? Do let me know. Once again, let me sit in front of screen and let me check what you people are saying. Do let me know. There is nothing to cram, kids, once you are able to understand. I'm sitting in front of the screen and I want to see, kids, that how much you are able to correlate. How much you are able to correlate, kids. Aliza is saying thank you. It's really awesome. Don't ask about class ending or just study. This you are studying with Baba HSP, so never ask. Aliza Sayyed is really happy, counting stars. Wow, really awesome. Now see, now I will make superb easy. So see, kids, now the negative charge, let me tell you, kids, let me tell you. Once you have seen the carbocation was having plus charge. Now who was the friend? Its stability will be directly proportional to, I have told you, the plus charge means its friend is plus I and its enemy is minus I, right? Now then we were having carbanion was having negative charge, so this was having negative charge. So for its stability, who is its friend? I have already told you that minus, so minus I is the friend and plus I is the enemy. Now in acids, carbon is having negative charge, then who will be its friend? The negative charge friend will be who? Minus I will be the friend and plus I will be the enemy. All three things are on your fingertips or not. Just see, kids, the things I'm telling you, they are working or not. Just to let me know the things which I'm telling you, they are working or not, kids. Do let me know. Really awesome tricks I'm giving you, that no need to cram. Each and everything will become superb easy, kids. Superb easy. All the things, they are going to become superb easy or not. Do let me know, superb easy or not. At least show me green hearts if the things are really superb easy. I want to see once again the chat section what you're writing. Show me green hearts. Counting stars. Thank you for these good words. Shairi Saxena, thanks a lot. Yo, these words means a lot to your Baba, kids. Very good. Now let's see the magic. Somebody is writing Baba is doing black magic. Now see the power of this black magic. So let's do the questions. Once again, you have to remember DNP rule. Now let me write down here. Let me write down over here COO negative. COO negative. Oh, what's going on? Oh, where it's gone? Okay. COO negative. No, COOH. I will write COOH. 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 COOH, right? Okay. Now let me copy it. Let me give you 3 to 4 questions. Now, before I give these questions, see, without removing even H plus, you can consider this to be negative in your brain. So no need to remove. You can, if you are having power, you can think over it. Okay. Just see, if I write down here NO2, if I write down here chlorine, if I write down here iodine, and if I don't write down over there anything, what do you think? What should be the order, decreasing order of acidic strength? Do let me know. Let me see in the chat section. Thank you, Lignes. Wow, Lingesh, thank you. A, B, C, D. Yeah, absolutely correct. Absolutely correct. See, kids, as this NO2 is withdrawing electron withdrawing group, so what it is doing, due to minus I, maximum power of minus I electron withdrawing group, this charge is decreasing too much. This is having less power, so less electron withdrawing, so this charge is decreasing, but not like that NO2, and this is having very less strength, so charge is decreasing, and this is donating electron donor, so it is intensifying the charge, and charge is getting increased. So definitely your answer is absolutely correct, that A, B, C, D is the order. A, B, C, D is the order. Now let me tell you one thing before I move ahead, that acidic strength is directly proportional to Ka value and inversely proportional to pK value, right kids? Remember this, right? Now if I give you one simple question, just see to it, very simple. One is nitroacetic acid, NO2 CH2COOH. One is being formic acid, HCOOH, and third one is acetic acid. What do you think? It's the order. I know very well that you can easily give the answer, so no need to ask del negative. Just see, its neighbor is having minus I, so it will withdraw electron minus I, and this will not do anything, and this is on the other side is electron donating group plus I, so it is increasing the charge, and that is being decreasing the charge, and it is not doing anything. So definitely I can write, kids, just to let me know, this is the increasing order of what I would like to say, increasing order of acidic strength. Acidic strength is increasing, Ka value is also increasing, am I right? But pKa value, this will have least pKa, and that will have maximum pK. Everything whatever I have written, agreed? Everyone agreed? Everyone is able to understand? Just to let me know in the chat section, everyone is able to understand? Agreed or not? Now after this, I will tell you something, kids. I will ask first of all something, then most of people will give the wrong answer. Why pK is lowering? That in ionic equilibrium you must have studied, in your ionic equilibrium you must have studied that pKa is minus log of Ka, opposite. It's the opposite in ionic equilibrium. Physical chemistry, either you will study or you must have studied, kids, right? Now I will ask one question, and I know very well that maximum people will give the wrong answer. Should I ask then, or should I not ask? I know very well that maximum kids are going to give wrong answer. Maximum people will give the wrong answer. Then do let me know, should I ask or not? I'm searching for one pen. Where that pen has gone? I can't find it out. Kids, just give me a second. Let me search for the pen. Just give me a second. Kids, Kids, I was searching for this pen. This pen was in my pocket. And for the last 1 hour, I'm searching for this pen. See what happens. Oh my God. For the last 1 hour, I was searching for this pen only. Where the pen has gone, where the pen has gone. And it was in my pocket only. I have told you, you will laugh. Definitely you will laugh. Okay, let me see what you're writing. Baba, I doubt. Yes. Ask, what's your doubt? What's your doubt? Murugan Ritesh, what's your doubt? Do let me know. Otherwise, I will start teaching. Then I won't be able to see the doubt. Kids, hit the like button. Make it 1.4. What are you doing? Why it's not 1.4? Hydrocarbon will start very soon. Let me first complete GOC. What I was telling you, yeah. I was about to ask one question, simple question, and maximum people will definitely give the wrong answer. I know very well. Negative charge. Negative charge is most stable, or negative charge is stable on more electronegative atom or less electronegative? That's the question. A, more electronegative atom option B, less electronegative atom. Yes, I want to see answer in the chat. Do let me know. Answer in the chat. Yes. Everyone is going for A. Oh my God. Everyone is going for A. Now kids, see. Remember this one thing I'm going to tell you. Okay, your answer is this. So kids, if I ask one question once again, HF, HCl, HBr, HI, who is maximum acidic? Do let me know who is maximum acidic. Out of these four, who is maximum acidic? So the answer will come like this. This is the acidic strength. So these are the acids, and after throwing its proton, it will give fluoride, it will give chloride, it will give bromide, it will give iodide. What do you think? If HI is maximum acidic, and if you don't know, let me tell you, the pK value experimentally, its pK value is 3, it's plus, no, it's -7, it's -9, and it's -10. This is the least pK experimentally determined. Least pK indicates what? Least pK shows most acidic. Most acidic, if the acid is most acidic, then the conjugate base is most stable. Most stable conjugate base. Am I right, kids? This is being least stable. But what you said that negative charge, people said that negative charge is most stable. Negative charge is most stable on more electronegative atom. You said this, but this data is indicating that negative charge is most stable on less electronegative atom. So who is right? Who is right? Now kids, you got stuck, you got confused or not? Just to let me know in the chat section that your answer got wrong or not. Your answer got wrong or not. So remember that little knowledge is always, Bicyclo is in our syllabus. Palak Goel, how much I have told you, that is in your syllabus. The amount, the content which I have given you, that is in your syllabus, right? So remember that one thing, make clear, little knowledge is always a dangerous thing. Little knowledge is always a dangerous thing. So the answer of this question will come, and then you will come to know. See, remember one point very clearly: negative charge, most important point, most important, this is most important, learn by heart. Let me tell you kids, learn it, learn by heart, learn by heart. Everyone learn by heart. This is being most important, most important. So remember it, okay? Remember this. Negative charge is most stable on biggest atom, on biggest atom. Remember this thing, biggest atom, biggest atom. Like it is most stable on iodide, then bromide, then chloride, then fluoride. Now what's that? As you said, it's most stable on always, most of the people said. What's that? So remember the B point, but see this B point later on after this point. If the size of atom having negative charge is same or almost same, then kids, then your thing, whatever said, then negative charge is most stable on most electronegative atom. Then you are right kids, then you are right, this second point, then you are right. So always remember, this is the first point, most important, then this is the second. And by keeping all these things, you can write very clearly that CH4 is least acidic, more acidic than this is ammonia, then more acidic is water, then more acidic is HF. Why kids? Why the order is like this? They belong to same period in the long form of periodic table. They belong to the same period. So carbon's electronegativity is 2.5, 3, 3.5, 4. So they have same size. They have same size if I talk about this. But if you go down the group, then HF, then HCl, then HBr, then HI, here the size matters a lot. Size matters a lot. So this is the acidic strength order. Let me write down if you're not able to understand. Those who are unable to understand, this will form conjugate base, like this will form a conjugate base. This will form a conjugate base, like, let's see their conjugate bases. Easily you will get it. Their conjugate basis is like CH3 negative. So this is going to be more stable, and H2 negative, this is even more, OH negative, and then this is even more. So the stability order of conjugate bases is like this. This is the stability order of conjugate base. Conjugate base stability order, but all these three conjugate bases are more stable than all these. Its conjugate base is more stable, its conjugate base is more stable, and its conjugate base is even more stable. Can you see the acidic strength? So let me take one more slide and then I will write down everything over here. CH4, then more acidic is ammonia, is more acidic than H2O, then more acidic than HF, then more acidic is HCl, then HBr, and then HI. So HI is maximum acidic. So the graph is going like this for the acidic strength. It's going like this. So if I write down their pK value, no need to remember pK value, but I know the pK value. It's approximately 50, it's 35, it's 15.7 at 25 degrees Celsius. It's being +3, it's being -7, it's being -9, it's being -10. So less is the pK value, more is the acidic strength. I hope this is clear to each and everyone. You can see the periodic table, you can get the analogy. I hope that everyone is enjoying, kids. Do let me know in the chat section. Everyone is able to understand, kids. And hit the like button, kids. Why it's 1.3? Make it 1.4. Let's see, can you make it 1.4? Do the black magic, you also, kids. Wow, from Kanyakumari, NULL. Yes, you will get each and everything in the Telegram group, right? Purification we will cover in class 12th. Purification will require some physical chemistry also, so we'll do later on, right? Now, acidic strength we have done. Now we are going to deal with basic strength, the fifth one, right? Fifth application, and inductive effects. Last application we can talk about. Last application of inductive effect, right? What's that? Basic strength. Are you ready for this? The basic strength, kids, okay? Fifth application. We are studying inductive effect, basic strength. Are you ready? I want to see green hearts in the chat section if you're ready, kids. Basic strength. Do let me know in the chat section with the green hearts. How is the Josh? Full on Josh. Everyone, full on Josh. I'm not liking this basic strength, so let me write down basic strength. Let's see. Yeah. Now it's lovely. Now it's looking good. Do let me know. It's looking good. It's looking good. Yeah. Now basic strength, it depends how easily nitrogen can donate its lone pair. This lone pair is like money, So I can say it in another words also, that how easily proton can attack on lone pair of nitrogen. So third way we can also say that basic strength of base is directly proportional to stability of conjugate acid. Am I right? Right? Now kids, the basic strength, now just try to see, do you feel any sleepy elements in my eyes? Just see Baba HSP's eyes. Do you see any element of sleepiness, tiredness? Let me see in the chat section what you're writing. Do you think, can you see? Wow, Mugilan. Fantastic, Mugilan. Kids, I want to see green symbol if really your Baba is doing hard work. Baba wanna see green hearts if really Baba is doing hard work. Wow, 1.4K, that's really awesome. Baba, please speak Tamil. The organic chemistry which is looking idiyappam muruku. The organic chemistry which was looking idiyappam muruku, I will make it romba sulvam if you are with me. If the people, the students who are thinking like chemistry, organic chemistry pedikiradu customer, I would like to say ille it's romba sulvam. Medhuva, the idiyappam muruku will become romba sulvam. So, my pronunciation was okay, kids? Do let me know. Murugan, Ritesh, Baba involved, Baba chlorine involves? No, only minus I, no plus I. Only minus I. Arpudham. Oh, you don't know Tamil. Okay, let's move. Okay. Okay. Let's move on, right, kids? Too much to cover up. So, just see, if I say that in your NEET only bio will decide the rank or the selection, then only one thing you have to study. But if 3 chapters are deciding your rank, then you have to study all 3 chapters. Sir, what you're talking about? Let me tell you. In the gaseous state, inductive effect is directly proportional to plus I. So let me tell you, basic strength in gaseous state. Basic strength in gaseous state, okay? So let's see basic strength in gaseous state, kids. Basic strength in, let me write down over here, basic strength in gaseous state, right? So basic strength in gaseous state is directly proportional to plus I. So it's very simple that basic strength in gaseous state, that 3 degree will be more basic than 2 degree, will be more basic than 1 degree, and then will be more basic than ammonia. Why it is this? Let me explain. So 3 degree means 3 alkyl groups, they are donating electrons. So they are donating electron from 3 sides. So maximum electron density will be here. Maximum electron density. So he will be maximum rich in money. So proton can, this is the attacker group. This is somebody who is always thinking to attack on this money, the money like electron. So it can easily accept, it can easily donate. Then 2 degree. Are you getting my point, kids? They will donate less electrons, so less electron density. And this though, only one alkyl group will donate electron. Some people will not be able to understand, so let me tell you in detail. Here 3 methyl groups are donating electrons, so electron density increased 3 much. You can say 3 much, so 3 times probability increased. Only 2 methyl groups, so electron density increased too much. This is not that too much, only too much, that 3 much, this too much. And here only 1 is donating electrons, so electron density increase 1 much. And there whatever the electron density is there, so it is maximum richest person, rich, richer, richest. Wow, good use of English. Rich, richer in electrons, and this is richest. Wow, nice analogy once again by chance. So good, are you liking it? If you got it, I want to see green hearts in the chat section, my dear students, if you really got it. Yes, kids, I want to see green hearts in the chat section if you really got it. Do let me know. Now once they are in aqueous state, then 3 types of people will decide. Once they are in aqueous state, plus I says I would like to give my vote to 3 degree, then 2 degree, then 1 degree, then ammonia. This is the first category. B says, B is what if B? B says steric hindrance. Steric hindrance says if something is too much sterically hindered, then it's very tough to reach over there. So according to this, ammonia is least sterically hindered because hydrogens are very small, so proton can easily approach over here. So it is giving its both just reverse of it, because steric hindrance is least, the crowding is least in ammonia, then 1 degree, then 2 degree, then 3 degree. See, just reverse order. Whatever this was saying, that according to me 3 degree is most basic, he is saying ammonia is most basic, just reverse order. According to him, it's very tough for proton to attack on this. See, carbon, hydrogen, hydrogen, carbon, hydrogen, 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 carbon, hydrogen, hydrogen, hydrogen. So proton can't attack on 3 degree because it is too much sterically hindered. Now third factor is also there. Third factor is hydration energy. Hydration energy says my vote is maximum for ammonia, then 1 degree, then 2 degree, then 3 degree. Let's see. These are their orders. Why hydration energy is talking like this? Let me tell you on the next page. Why the hydration energy is talking like this. According to hydration energy, let me tell you. Ammonia is a base, water is an acid. It's like here, it is acting as a base and water is acting like acid. So acid will donate its proton and it will attack over here, right? So this will become ammonium and that will become OH negative. Now ammonium nitrogen is attached with 4 hydrogens, so it will look like this: H, H, H and H, and this positive charge. Now this hydrogen attached to the nitrogen will do hydrogen bonding with whom? Water. This will be the hydrogen bonding. Am I right, kids? Now you know very well what? You know, kids, very well when somebody is doing bonding that they will come nearer. Gradually, Arpudham, Medhuva. So 4 hydrogen bonding say they will come close. Once they are coming close, they will eliminate out energy. And this due to hydration, whatever the energy is released, will be known as what? Gets energy released will be known as hydration energy, and more the bonds are formed, more energy will release. And nitrogen was already having 3 hydrogen and 1 during reaction with water it is having 4 hydrogens. So 4 hydrogen means 4 intermolecular hydrogen bonding. In 1 degree only 3, in 2 degree only 2, and in 3 degree only 1 hydrogen bonding. So maximum energy will get released over here. Getting point? My point is clear. Maximum energy will get released. Is this point clear? But out of the 3 factors, who will dominate? That is the point to be noted, my lord. So by keeping all 3 points, so by keeping all 3 points in our brain, we have to follow experimental data. We have to follow finally experimental data. That means we have to cram. This thing was the understanding part that I've told you, but then also we have to cram. Now we should have that much of knowledge for cramming also. So remember that if R is methyl, one thing, and B part, if R is ethyl, then what and how this thing will move. 2 degree most basic, 2 degree most basic, ammonia least basic, ammonia least basic. Wow, this is the same. Yeah. Now here 1 degree, then 3 degree, and here 3 degree, then 1 degree. It got reverse. Now how to cram it, how to keep it in your brain? That's the $1 million question. So let me give you once again the trick. Let me give you the trick. Just see the best trick in the world. If you see methyl is like this, And if you see ethyl, ethyl is bigger. So smaller, for smaller, the value is smaller. 13 is smaller than 31. Smaller, and this value is bigger. Can you see? 31 is bigger than 13, and this is also bigger than methyl. Let me see the trick. What are you writing? This is the trick, kids. You're liking it or not? Just to let me know in the chats. Let me see, kids. Wow, Sahana, fantastic, kids. Okay, Kavita, right. Okay, now inductive fact application is completed. Now let me move towards hyperconjugation. Another topic is hyperconjugation, kids, right? Let me move towards hyperconjugation. Hyperconjugation. Hyperconjugation, where it's gone? Yeah. Hyperconjugation is also known as, kids. First of all, let me write down the names. Hyperconjugation is also known as no bond resonance. No bond. I will tell you why these names are there. No bond resonance. They can directly ask question on this also. Sigma bond resonance. Sigma pi conjugation. And it was studied a lot by two scientists, Baker and Nathan effect. Right? These are the names, and all they are having values. Why these names are there, right? See. It deals with the stability of, it explains stability of three things. Stability of three things. What are these three things? First, alkene. Second, carbocation. Third, free radical. Right? It deals with the stability of all these three. I will move one by one because it holds a hell lot of weightage. So you have to be patient. Don't move fast. Will you give me time? Because if you really want to know, if you really want to become best, kids, you have to give some time. Don't say increase speed, do this and that. If you want to become perfect, kids, show me green hearts and thumbs up if you're ready to give me time. It's for 100 divided by 5, so 20 to 30 marks. 20 to 30 marks for sure. Okay. Okay, kids. So let me move ahead. Let me move ahead. So kids, just see and try to understand. Try to understand. Alkene. One side I will write down balance bond theory approach. Another side I will write down MOT approach, right? Molecular orbital theory approach. Two approaches will move together, right? Balance bond theory, molecular orbital theory approach, right? Just see, if I write down an alkene like this, it's looking like that this X bond is single bond and Y is double bond. But this is olefinic carbon. Its hybridization, if I talk about, this is being sp2, this is also being sp2, and this is sp3, and this is known as alpha hydrogen, and this is having electronegativity 2.2 and this is having 2.5, so it is having partial negative charge. So this will get removed. Once it got removed, it will look like the sigma bond will convert into pi electrons, and now the pi electrons will move like this. This electron will come over here and this electron will go over there. So the final structure will become like this. The single bond is getting partial double bond character. Now this was X, looking like single bond got converted into double bond, and this is Y. So these are two hyperconjugative structures. These are the two hyperconjugative structures. This is the balance bond theory, but molecular orbital theory is the actual theory, because tough question will come from here only. The actual theory is this one. This is actually the actual theory. So kids, just see, the main question will be from here. So let me draw once again this sigma bond with alpha hydrogen, and this the pi bond. You know that pi bond. So this is pi bond, and there will be pi anti-bonding molecular orbital. This is pi anti-bonding, and this pi anti-bonding is star, means anti-bonding. Pi anti-bonding molecular orbital is empty. So the sigma bonded electron will move to, the tough question they will ask, so you should know that sigma bonded electron will go to pi anti-bonding. The sigma bonding is going to pi anti-bonding. So write down sigma bonding will migrate to pi anti-bonding. Sigma bonding molecular orbital electron will go to pi anti-bonding ABMO, anti-bonding molecular orbitals. So, any doubt? I'm just coming in front of you, in front of screen. Any doubt you can ask. I'm giving you the perfect knowledge. Yes, I'm giving the perfect knowledge. Oh my God, Sahana, that's really fantastic. I need this type of students, kids. I need this type of students. I will give break at 1:30. I will give you one break at 1:30, kids. At 1:30, I will give you one break, right? Thank you, thank you. Now, kids, what are the consequences? Just see, let me tell you. To understand it, kids, you should know one thing. You should understand one thing. First of all, you should understand that if somebody is having single bond, then the bond length is, just cram it, 1.54 angstrom. And somebody is having double bond, pure double bond, if I say without hyperconjugation, then the bond length is 1.34 angstrom. Pure single bond, pure double bond. Remember that, what I'm talking about. Pure single, pure double bond, right? Just remember, pure single, pure double bond. But we have seen right now that if I am having propene, then this single bond will go, single bond will acquire partial double bond character. This hydrogen will go, this will appear, this will go. So 3 alpha hydrogens are having. So due to this, the actual structure in single bond, there will be partial double bond character. So the compound will be like this. Remember this. It will develop partial double bond character, partial double bond character. Sometimes it will have negative charge, sometimes it will have negative charge because of these 3 alpha hydrogens. So neither this is single bond, this is single bond. So you should know that this bond length is, it was expected to be like that, but it is not pure, it is impure double bond. Can you get it? Impure double bond. So the bond length will increase. I don't know how much, but it will be more than 1.34. It can be 1.35 angstrom. It can be 1.36, I don't know, but it will be less, it will be greater than that 1.34. And this was expected to be single bond. Single bond is like this, but it is acquiring partial double bond, so less than 1.45. I don't know, 1.53 angstrom, 1.52, but one thing is for sure, it will be less than that. This is clear. Single bond will acquire partial double bond character or somewhat partial double bond character, and double bond will acquire somewhat single bond character. Do let me know, kids. Okay, Palak Goyal, let me explain. See what I'm saying, what I'm talking about. If I say that this is hydrogen, and this is moving, once this is going, it's delta positive, it's delta negative, so there is negative charge. Now this will do resonance, it will come over here, it will go over there, so it will look like this. Now see, here it is having single bond, but here it is having double bond. There it will acting as double bond, here it is acting as single bond. So they are having a little bit, these two are hyperconjugative structures. Got it? They are hyperconjugative structure, and remember that number of hyperconjugative structures is equal to number of alpha hydrogen plus 1. In some books it's written only equal to number of alpha hydrogen. Remember that plus 1 will always be there, plus 1, because one hydrogen will get 2. So is it clear? So now how the stability will come due to hyperconjugation, how the stability will come due to hyperconjugation. Just see the stability. We all know that stability of alkene, you must have studied stability of an alkene is directly proportional to number of alpha hydrogen atoms. This everyone must have studied, but how? My question is how, kids, how? Just see, if I write down one alkene, this one CH2 double bond CH2, why it is being unstable? Because of this pi electron. Any electrophile will come. If I say electrophile is like eagle, see the analogy, electrophile is like eagle, and this pi electron is like parrot, this is like parrot. Now if the parrot can't move because it is localized, so it is tied parrot, can't move, can't fly, can't move, so it's easy kill for the eagle or not? Easy kill. But at the same time, if I draw this compound, now if eagle is going to attack on it, if the eagle is going to attack on it, what will happen? This will do hyperconjugation. Sometimes it will come over there, sometimes it will go. So can fly, parrot can fly, parrot can fly. So which one is easy kill? This is easy kill, but that is not easy kill, because 3 times it can fly, 3 times. Why? Because of 3 alpha hydrogens it can fly 3 times. So this is not that easy kill, this is easy kill. This is unstable, but that is stable. So more the number of alpha hydrogen, more the parrot pi like pi electron can move, more the number of alpha hydrogen, more the parrot can fly. So are you getting the analogy? This analogy is good or not? Is this analogy good or not? Kids, do let me know. alpha carbon, alpha hydrogen. I will let you know. See, let me give one question, then you can understand. Okay, alpha hydrogens. See kids, they all are isomer. The formula is C6H12, right? A, B, C and D. Now try to find out number of alpha hydrogens. How to find out? See, this is double bonded carbon and this side is nothing but adjacent to this is alpha carbon. How many hydrogens? 2 alpha hydrogen atoms, right? So the pi electron will move in this area, this much area the parrot can fly. Now here you see this is sp2 and sp2 adjacent to this 3 alpha hydrogen atoms and here 2 alpha hydrogens, right? The parrot can fly in what area? The parrot in this will fly in more area, more stable. Are you getting my point? That is having 2 alpha hydrogens. This is having 3 to 5 alpha hydrogens, more hyperconjugation. Now see this one. Just see this one. This is sp2 hybridized carbon. Can you see? And adjacent, directly attached, this is alpha carbon, directly attached alpha carbon, and directly attached alpha carbon. So how many alpha hydrogens are there? 3, 6 and 2, 8. 3 plus 3 plus 2, total 8 alpha hydrogen atoms. So in this, the parrot means pi electron will fly into this much of area, bigger than that. Now see in this. Now I want to see if you really got it. How many alpha hydrogens are there in this? 3, 6, 3, 9, 3 plus 3 plus 3 plus 3, 12 alpha hydrogen atoms. So in this, the pi electron means parrot can fly into maximum area, maximum space. So the stability order, you can see clearly the stability order is like this. Am I right, kids? This is most stable. D1 is most stable. So kids, D, then C, then B, then A. How many of you are really impressed? Really got it? Clarity, the alpha hydrogens. Do let me know. Oh my God, already you are showing me green hearts. Wow. Kids, don't say anything like that. Sahana is intelligent. Sahana got 3 times. Sahana is 3 times topper of plus batch. Kids. Sahana is 3 times topper of plus batch student kids. Thank you, Boost Gaming. So don't underestimate anyone, kids. Oh my God, Ambika ma'am is there, kids. Ambika ma'am is there. Everyone, show your love for ma'am, the best teacher for bio, the best teacher in the whole country for bio. Everyone, I wanna see green, yellow, red, whatever the hearts you are having, whatever the color hearts you are having for our lovely Ambika ma'am. Kids, see kids, just studying for long period of time with consistency, this is the best gift you got on Tuesday, kids, in the form of the best bio ma'am, the best teacher, your Ambi ma'am. Kids, say, write down something in the chats. I want to see the chats full on with multicolored hearts. Oh my God, dear students, you are really awesome. Okay, let me show these hearts over here also. How to get it? Okay. Yay! Yes! Now I can see. Now even I can see. Wow! Let me say wow. I'm getting wow feeling, kids. This is for you, ma'am. This is all for you, ma'am. This is great love for you, ma'am, from kids' sides. Wow, kids, fast. Let's make it like rocket. The heart should move on with the highest speed, with the best acceleration. Oh, thank you, Ambika ma'am. Thank you, Ambi ma'am. Thanks really lot. See, kids are giving number of hearts with full on josh. Let's see the speed, kids. Let's see the speed. You can increase a little bit more speed. I think you can do that. Let's see, kids. Wow, ma'am, wow. Kids, ma'am has given really fantastic hearts. Kids, better than your heart. See. Oh, yeah. Now the speed, I can see the speed. Really, the speed is really good. Fantastic. Oh my God, Ambi ma'am is writing. See what Ambika ma'am is writing. See, kids. That's really awesome. I'm so loving it. You made Holi, Deepavali, everything, ma'am. I'm celebrating like it, anything. Madhu, Liha, wow, Bhavna, you're following what ma'am is saying, kids. Wow. You're a big fan of ma'am, right? Oh my God. Kids, you made my day, really. The tears of happiness, they are in my eyes. Really. Oh my God, kids. Really awesome. It's fantastic. Nice feeling, kids. Really, I am feeling fantastic. And ma'am is awake at this time also. Kids, ma'am is still awake, kids. See, you are awake for your studies and ma'am is still awake for your studies. So everybody is awake for your study, the best strength, so best preparation, kids. My God, my God, my God, my God, my God. My God, see, nice DP, nice DP. See, ma'am, which color sari ma'am is wearing? Kids, do let me know which color sari ma'am is wearing. What color sari ma'am is wearing? Green. It's green or dark green? It's green or dark green, kids? Dark green. It's dark green. Which color, complementary color, will be absorbed by the sari? The sari is reflecting dark green color. What is the complementary color? If you study in your coordination chemistry, what is the complementary color absorbed by the sari? Blue. Blue. No, no, bottle green. That is the color. What color will be absorbed by? It's a red color. Blue green's complementary color is red color. So the sari must be absorbing red color. The sari must be absorbing the red color, and that's why it's looking dark green, kids. The complementary color, if you see the color wheel, then color wheel says that's blue green is becoming red and red is becoming blue green. So that's, thank you ma'am, thank you, really, thanks a lot, thanks a lot. Black too, so though there is no complementary color for the black. Okay kids, say thank you to ma'am, thanks a lot to ma'am. Yeah, yes, you got it, Prajwal. Ready? Now let's set go, otherwise we will get late. So tata, thank you, good night to ma'am, really thanks a lot. So let's come back to this hyperconjugation. So kids, now hyperconjugation, let me tell you in carbocation stability by hyperconjugation. Let's see carbocation stability, how carbocations are affected. Once again, I would like to say I will divide this in two parts. One is valence bond theory, another one is molecular orbital theory. Let me divide it into two parts, right? One is being valence bond theory, another one is molecular orbital theory, right kids? Let's see. The valence bond theory says that if I write down here carbocation and this adjacent to this is alpha hydrogen, just try to understand what is alpha hydrogen, otherwise again you will ask that this is carbocation and whatever the carbon is directly attached to it, this is alpha carbon and this is alpha hydrogen. So it will go away by leaving its electron over here. So this will be like this, carbon negative, carbon positive, and positive negative will form bond. So it got stability. How it got stability? There you can see it was having just 6 electrons and this was having 8 electrons. Here both are having 8 electrons, the octet got completed. This is valence bond theory. Now if I talk about molecular orbital theory, I will write down like this. Now just see to it kids. This plus charge, I would like to say this plus charge in unhybridized pure p orbital. Can you see this is unhybridized pure p orbital? Let me draw it in a better way. This is unhybridized pure p orbital which is perpendicular to the plane. Can you see kids? This is unhybridized pure p orbital, and it is being empty, and this is sigma electron, so this sigma electron will go to pure p orbital. Sigma bonded electron will move to pure p orbital. This is the answer. If tough question is coming, it will come from here, and it's given in NCERT. Even it's given in NCERT. Let me see in the chat section. It's clear to all of you or not? If you're not even able to understand, then you have to learn it, that sigma bonded electron will move to pure p orbital. Got it, kids? Got it? So break time. Okay, so break time, let's meet at 2. Okay, thank you, Faiza Anwar. So it's break time, let's meet at 2. Some people, they want to charge their mobile, so okay, so break time, let's meet at 2 p.m. 2 a.m. not to say p.m. 2 a.m. right? Welcome kids, welcome back. Everyone ready? How's the Josh? I want to see green hearts in the chat section if you are ready kids. We will move through questions. Let me teach hyperconjugations, the free radical, what is involved, and then we will move through questions. We will try to cover up through questions, right? So that let's see how much you can perform, right? So the free radical. In free radical, I would like to say, first of all, show me green hearts if you're ready kids. If everyone is ready, show me the green hearts. Free radical. Let me tell you the free radical stability. I want to see green hearts. How's the Josh? Do let me know kids. Yeah, ready. Free radical. Just see free radical. Once again, I would like to divide in two parts. One side valence bond theory and second side valence bond theory, and second side the molecular orbital theory, MOT, molecular orbital theory. Now see here, this is free radical. Just see kids, if this is moving like this bond will come over here. This will go along with the hydrogen, will go along with this electron. One electron it will take, because free radical will try to form free radical. Free radical will try to form free radical homolytic cleavage. In this way you will get this type of free radical. And thank you kids for coming for studies. You are going to become doctor, engineer, but I'm saying thank you because you know the value of time. Now molecular orbital theory approach, I would like to say it's being like this. And kids, here the partially filled, this is unhybridized but having one electron, unhybridized. This is not hybridized. We call it SOMO, singly occupied molecular orbital. What we say? Singly occupied molecular orbital. Singly occupied molecular orbital. SOMO kids. So the sigma bonded electron will move to SOMO. Sigma bonded electron, if it is coming in your exam, the tough question, then sigma bonded electron will move to SOMO, right? Singly occupied, unhybridized. This is unhybridized, right kids? Unhybridized. Now this was main thing about, let me see what kids are writing. Kids, is it clear? Everyone is fit and fine? Just to let me know in the chat section. Everyone, is it clear? You got it? Are you able to understand? If yes, show me green hearts. Now kids, this is all about hyperconjugation. Then there is just the application of hyperconjugation that you can do by your own. Okay, now number of questions are also there based on hyperconjugation. If I talk about the printed questions, see the printed question. A tertiary butyl carbocation is more stable than a secondary butyl carbocation. Which of the following? Because of which of the following? Do let me know in the chat section what should be the answer. If you really got it, whatever I taught you, if you really got it, did you understand? Have you understood? If yes, I want to see the answer in the chat section. Yes, fast kids. If you got it, what should be the correct answer? Let me check it out in the chat section. Let me check it out in the chat section. Fast kids. Some are saying D, some are saying C. Let's see the correct answer. Hyperconjugation. C is the correct answer. Right now I taught you hyperconjugation, so hyperconjugation is the correct answer. Now see another question. Hyperconjugation occurs in, I want to see the answer. Yes kids, hyperconjugation, if you really got it, hyperconjugation occurs in. Fast kids, fast. Quick reply. Now let me check it out. What's your answer? See, this is no alpha hydrogen. No alpha hydrogen here. There is no alpha hydrogen, and this carbon there is no alpha hydrogen. So no hyperconjugation in this. No hyperconjugation. This one, all phenyl, no hyperconjugation. This one, this side. So only third. Where it's written third only. Second should be the answer. So second is the correct answer. Now, next, which of the following compound will not show hyperconjugation? Just see to it. Which of the following compound will not show hyperconjugation? See, it is having 3 and 2, 5 alpha hydrogen atoms. This one is having alkene. This is alkene. So 3 alpha hydrogen atoms. And this is CHO. This will not show, and this is having 3 alpha hydrogen atoms. So they all will show. So this is the answer. So third should be the correct answer. Yes. Now kids, another one, resonance. We are going to start with resonance. Are you ready for the resonance kids? Because we have to see resonance in detail. Then only we can answer all the questions based on resonance. Kids, ready? Everyone ready? Is everyone ready? Do let me know kids. Show me some fire in the chat section so that I understand that everyone is ready with full josh. I want to see full on josh because that is the backbone of organic chemistry. Resonance is the most important thing. Kids, do let me know. Let me see that everyone is with full on fire, full on josh. Where are you? Yes, kids. Woo, what's going on? Yes, I want to see full on josh. What's going on, kids? What's going on? Yes. Fast. I want to see. Yes, that's really fantastic. So let's move on. Resonance. Remember that only one thing for resonance, the most important thing, that any, if I say X, Y and Z are non-metals, right? See, the trick I'm going to give you so that to solve all questions, you can solve each and every question. If there is X double bond Y single bond Z, just remember this is pi bond, okay? Pi bond. And if this Z is having double bond, this is the best mesomeric effect. Best mesomeric effect. Remember that this is best mesomeric effect. This one is best, the best. Now I would like to say, or Z is having triple bond, or Z is having negative charge, or Z is having lone pair, or Z is having positive charge, or Z is having free radical. In all these 6 conditions, mesomeric effect will always take place. And remember that mesomeric effect, if I say mesomeric effect is Tamil people. So all Tamil people are Indians. So resonance is the most important thing. Remember that it's the analogy is like Indian. If I say all Tamil people are always Indian, all Tamil people are always Indian, but all Indians need not to be Tamil people, not always. Got it? So I would like to say that mesomeric effect is always resonance, but resonance is not always mesomeric effect. This is the first thing. Now, the second thing, the most important thing I would like to tell you, remember one thing, that if, this is the note, if an atom is having double bond in conjugation, double bond in conjugation, along with any of the following then only double bond will do resonance rest of the things will remain localized. Rest of the things will remain localized. Now what are these things? Just see. Along with the double bond, if I say the things are like negative charge or lone pair or positive charge or free radical. Now you will say, sir, I am so unable to understand what you want to say. We haven't got it. We are unable to understand. Now you will say that you are unable to understand. Now let me tell you in detail so that everyone can understand it. Okay, let me tell you in detail so that everyone can understand it. Right? Ready, kids? Are you ready? See, let me explain it. Suppose if I say that this is the compound, if I put here negative charge. Now this carbon atom is having double bond as well as this negative charge. This negative charge will remain localized. Localized means not involved in resonance. Not involved in resonance. Not involved in resonance, will remain localized. On the other hand, if I say it would have been given like this, it would have been given like this, the negative charge at this place and double bond like here, this is doing resonance. Remember that this is doing resonance, it is involved in resonance, or I can say this is delocalized. Delocalized means involved in resonance. I hope you got it. No, sir, I haven't got it. give some more examples. Okay, take some more examples. No problem at all, kids. Have number of examples. I can give you number of examples. See, if I write down this compound, just see. This compound you know very well. What do you call it? You call it pyridine. Everyone knows this is pyridine. Am I right, kids? Now you see this this nitrogen is attached with pi bond in conjugation with pi bond. So this nitrogen is having two options. One is the lone pair, one is the pi bond. Which is best resonance? Do let me know. This pi bond and this pi bond conjugation is the best conjugation. So it will remain localized. So it will remain out of plane. Out of plane means will not take part in resonance. It will remain localized. Localized means what? Localized means will not do resonance. They are doing resonance. This is doing resonance. This is doing resonance. This is doing resonance. But this can't participate in resonance. Not taking part in resonance. Are you getting my point? Not doing resonance. But at the same time, if I would have drawn a compound like this compound also you know very well. This compound you know very well. What is this, kids? This is known as pyrrole. Pyrrole. Now, if you see the pyrrole, kids, you can say easily that this is having only lone pairs. So this lone pair is doing resonance with this. So this is delocalized. That means lone pair is taking part in resonance. Now I was unable to see the chat. What's going on, that you are able to understand or not. If not, then I will give you more examples, but at least you have to tell me that yes, that you are able to understand or not, kids. I'm trying my level best so that everyone can understand, kids. You are giving your the best time. Thank you. Don't talk about people, just focus. Everyone getting more examples. Okay, some more examples. Let me give you more examples. Just see. Just try to understand localized or delocalized. I am writing, just find out. This is delocalized. Delocalized means doing resonance. This is localized, means not doing resonance. This is localized, not doing resonance. This is delocalized. Agreed or not? If I write down like this, nitrogen, nothing is given over there but no pi bond, so it is localized. Delocalized. I think everyone got it. Now it's clear to each and everyone, localized or delocalized. Localization and delocalization is absolutely clear, kids. Now you can understand, everyone. Now, once the resonance you are able to understand, then you can do anything, you can do anything. Now let me tell you about resonance. First of all, the most important thing, resonance is of three types. Remember that resonance is of three types. Do you want to know what are these three types? Resonance are of three types. Do you want to understand what are these three types? 1, 2, 3. Three types. What are these three types? See, kids. First is being one atom resonance. What is this one atom resonance? One atom resonance means, kids, that negative charge is most stable on the biggest atom. Already I told you that negative charge is most stable on biggest atom. This already being explained. Now second type is back bonding. You must have heard this name, back bonding. And third one right now I've told you, mesomeric effect. Now kids, once these three things are clear, now you must be thinking about what is this back bonding. What is this back bonding? See to it. Kids, what is being back bonding? Once the things are clear, then only you can do the questions. Otherwise, you won't be able to do the questions, kids. To understand it, just see. Because back bonding, most of the time people forget about back bonding, and that's why they are getting failed. If you forget about back bonding, if you're not able to understand back bonding, you won't be able to do anything in your life. So remember that back bonding holds a hell lot of weightage. Back bonding. Just to have back bonding, there is one donor atom, and that is bonded with the gainer atom. What donor atom should have? Just remember, donor atom must have at least one lone pair. And the gainer atom, who should act as the gainer atom? Just see the gainer atom. Who will act as the gainer atom? Just remember, must have low energy vacant orbital. Now kids, if this is of 2p, this can be of 3d, or this can be of 3p. It's like this. And this is generally, if it is 2p is the best. 2p is the best. Why 2p is the best? If it is from 3p, then it can donate its electron to itself 3d. So I would like to say the donor and the gainer relation is like that. If this is 2p and that is 2p, the donor is 2p and the gainer is 2p, then this is excellent back bonding. Excellent. If donor is 2p and gainer is 3d, then better. And this is 2p and that is 3p, then it is okay back bonding. Okay, so the back bonding is like this. Now you must try to get the what you must be asking for the example. Now see, if anyone is asking that compare the stability, the two things and their stability, if I say that it's CF3, it's Cl3 plus, see kids, the carbon is in need of, the carbon is having only 6 electron, and fluorine, you know that is having lone pair, the donor. Now just see the kids, this will donate. Donor is 2p, donor is 2p and gainer is also 2p. This is having just 6 electron and this is having 8 electron. So 2p pi, 2p pi, the best, excellent back bonding. Donor is 2p and gainer rishta, means equality bonding, bonding of equality is good. Now here carbon is in need of electron because it is having only 6 electron, but chlorine belongs to which period? Which period? If you see chlorine's period, fluorine, chlorine, this is 1, 2, 3. So gainer is from 2p, gainer is from 2p, but donor is from 3p. So that bonding is 2p pi, 3p pi. So this is more stable, that is less stable. So this is being more stable. I hope that everyone is able to understand. Everyone got it, kids? Do let me know in the chat section if you got it. Let me see the chat section. What kids are saying, my kids? Hey kids, do let me know you are able to understand the back bonding. Kids, do let me know. Now back bonding changes the hybridization also. Sir, I can't understand resonance. Can you define it again? Okay. Okay, let me write down the definition. Once again, please, little bit confused. Okay, Faisal and what is happy. Okay, just wait, just wait. Let me write down first the definition of resonance. Definition: when a single structure can't explain, when a single structure can't explain all the physical and chemical properties of that molecule, and then we require more than one structures. These structures are known as canonical structures, canonical or resonating structures, and the phenomena is known as resonance. Now, to explain it, if you see, this is calculate one structure of benzene. I cannot say this is benzene, this is the canonical structure, and this is another canonical structure. These two are resonating or canonical structures. They are not benzene, these are canonical structures of benzene. Not a single structure can give all the properties of benzene. So I would like to say that the pi electron is not fixed. This is always moving like fan. So this is known as true structure. This has true structure, or I can say resonance hybrid. Now my dear students, the expected energy was 86 kilocalorie per mole, but experimentally it was found only 50 kilocalorie per mole. Now we will say what's the resonance energy. That energy was found to be less than expected. So resonance energy, we will say final minus initial, 50 minus 86, that is minus 36 kilocalorie per mole. This is stabilization of benzene due to delocalization of pi electrons above and below the ring. Now you got it. First two, let me know everyone got it. It's clear. It's clear what is resonance. Crystal clear, kids. Do let me know. Wow, Sahana, fantastic. Thank you. Now I'm going to deal with applications of resonance, aromaticity and anti-aromaticity. The first application is application number one, the best application and the most important application, I would like to say. The first application, kids, first application. Are you ready? Is everyone ready, kids? The most important application, aromaticity and anti-aromaticity. Here I will write aromaticity, and that side I will write down anti-aromaticity. Kids, what is required for a compound to be aromatic and what is required for a compound to be aromatic? One point, first point is common in both of them. To both of them, one point is common. What's that? Common point. Anyone? Any guesses? Common point is at least one planar ring. This is the common point, at least one planar ring. Now the second point is not common. This is the first point. Second point, number of pi electrons, number of delocalized, not the pi electron, number of delocalized, mark my words, number of delocalized pi electrons must follow Huckel's rule. Here this side must follow Huckel's rule. What's that? That is 2 pi electrons or 6 pi electrons, keep on adding 4 to it, or 10 pi electrons and so on. Now this side, the second point is this side. For anti-aromaticity, the second point is number of pi electrons must be in multiple of 4 pi or 8 pi or 12 pi, like this, so on, the pi electrons. This is the difference point. It should have these many pi electron, that should have that pi electron. Now the stability also I am going to tell you, kids. Any confusion? In aromaticity and anti-aromaticity, is there any confusion? Do let me know. If this is not clear, you won't be able to understand anything. Tell me green hearts, show me green hearts if it is clear, kids. One point is common, second point is not common. Kids, what are you doing? Where you got indulge? What's going on? Show me green hearts if you got it. Very good. Now see, kids, let me show you. The stability of compounds is like this. Aromatic compound seems to be more stable than its non-aromatic. And then it's anti-aromatic, highly unstable. Highly unstable, kids. Highly. This is the stability order. These compounds are highly unstable. Now, how to find out? Let's take some examples so that we can understand. Are you ready, kids? Is everyone? How's the Josh? Do let me know. Show me some fire along with some emojis, kids. How's the Josh? Let me tell you aromatic compounds, that if you see this, you know very well that this is having planarity, or for planarity you should know all of them, they should be sp2 hybridized. All atoms sp2 hybridized. Now, right now you don't know that what is a sp2 hybridized, because machine sir will take class on this chemical bonding. So let me tell you how to find out. All double bonded carbons are sp2 hybridized. All compounds having carbocation sp2 hybridized. sp2 hybridized, carbocations are sp2 hybridized, boron 1 are sp2 hybridized, carbonyl group is being sp2 hybridized, carbon with a negative charge and adjacent carbon being double bonded is sp2 hybridized. All of them, they are being sp2 hybridized. Remember that. They all are sp2. Can you get it, kids? If you see such type of compounds, they all are responsible for what? Planarity. They all are responsible for planarity, right? They all are responsible for planarity. So this is planar, and how many pi electrons doing resonance? So definitely 1, 2, 3, 4, 5, 6. So following Huckel's rule, it's being aromatic. Now, let me give you some more examples. Kids, if you see this compound, this is known as furan. This compound is having total 8 pi electrons, but these two are localized, means not doing resonance. Why? If any atom is having more than one lone pair, then only one will take part in resonance. Remember that. An atom having more than one lone pair then only one will take part in resonance. Means delocalized. The another one will remain localized. So anyone is delocalized because 1, 2, 3, 4, 5, 6. So planar, following Huckel's rule, so aromatic. Got it? I hope aromaticity is clear to all of you. Now, you must be thinking, sir, how to find out the compound is anti-aromatic. Sir, give some example. Okay. So see to it. If I write down compound like this, and if I write down compound like this, just see the difference in between these two compounds. So this is having 2 pi electrons, and that one is having 1, 2, 3, 4 pi electrons. Both are being planar. This ring is planar. That ring is also being planar. But this is following Huckel's rule, so this is declared to be aromatic kits, and this is anti-aromatic. So please give some more examples. So definitely I will give you some more examples. Just see to it. If I write down ring like this, draw it properly, sir. It's not looking good. Sorry, kids. Let me draw it properly. Now it will really look good. Looking good. Nice. Nice. Now see, kids. It is having 1, 2, 3, 4, 5, 6 planarity rules, 6 pi electrons, so it's declared to be aromatic. It is having planarity, but pi electrons, if I ask you 1, 2, 3, 4 pi electrons, so it is declared to be anti-aromatic. Got it, kids? I hope you got it. Everyone understood aromaticity and anti-aromaticity. Do let me know in the chat section you got it or not. This hard work will definitely make you one successful person, kids. See, Sahana is so active, kids. Are you active? Show me green hearts. Your teacher is working hard for you, kids, and you are also working. Yes, counting star. Pakka one question is going to come from this. Definitely one question will come from here. Thank you, Aliza Sayed. Now, the place where maximum kids will lose marks. Let me show you the place where maximum people definitely are going. Does 4 pi means anti-aromatic? If the ring is planar, if ring is planar, then 4 pi electron means anti-aromatic. Okay, if the ring is planar. Now see, kids, where people are losing marks, let me show you that place. Definitely people loses marks at this place, known as the place is known as anulines. Have you ever heard the name anulines? Anulines words, have you ever heard? I don't think. Monocyclic, compounds with alternate pi bonds. this is the place where maximum kids are going to lose marks. If I say this is the smallest aniline, what name they have kept? Either count carbon or you count pi electron, they will remain same. So its name is 4-aniline. Planar, 4 pi electrons, so it is anti-aromatic. Got it? Now, benzene, you know very well, benzene, what do you call it? Benzene is your 6-aniline. Either you count carbon or you can count number of pi electrons. Now, kids, I would like to tell you one thing. Just remember 8-aniline, 10-aniline and 12-aniline. Whatever your mind is saying, don't think about your mind, don't believe on your mind. Just remember these are non-aromatic. Whatever your mind is saying, that's another thing. But just remember these are non-aromatic. Now definitely you will ask, sir, why? These are those compounds which looks like something else, but actually they are something else. How many? If you want to know the reason, I can tell you the reason, but just to let me know in the chat section that you want to know the reason. Then definitely I will tell you the reason. Sumit, very good. Do let me know, I will tell you the reason. These are the compounds, they are looking like something else. Okay, see. Because assertion and reasoning will come and they will ask you. They will ask you in assertion and reasoning. See. 8-aniline. 8-aniline will look like this. Will look like this. And it will look like planar. It's looking planar, but this is the wrong structure of 8-aniline. Remember that this is not like this. This is wrong structure. Its correct structure is tub shaped. Remember this. It's actually tub shaped. Non-planar, and the ring is non-planar, then definitely non-aromatic. It has to be non-aromatic. This is the wrong structure of 8-aniline. Now, let me tell you 10-aniline. What's the problem with the 10-aniline? Just see, kids. So see, these hydrogens, if you know cis trans a bit, these hydrogens are going outside, but this hydrogen is coming inside. It's due to cis and trans, and this hydrogen is also coming inside. The two hydrogens are coming inside. Why they are coming inside? See, this is cis This is cis, but there is trans. This is also trans. Now how to find out trans? This is cis. If on the double bond you are getting C, that means they are going same side, hydrogen or on same side, so cis. And if you are getting this Z, the hydrogen is going this side and hydrogen is going this side, this is being trans. So due to this trans, see, the sigma bond and pi bond, they are like this. But if hydrogen is colliding, these two hydrogens are transferred, they are colliding, so one will get a little bit shifted this side, and if this is going shift a bit this side, then sigma and pi bond, they are perpendicular to each other. This will go out of the plane. The rest of the pi bonds, they are coming like this, but they will shift, so they will destroy the resonance. Are you getting? If I say all the pi bonds are like this, but due to this transangular effect, this pi bond is going out of like this, then this will not be able, suppose this is like this was supposed to be like this, all the pi bonds are doing resonance, pi bonded electron, but due to transangular effect it is shifting like this, then this will not be able to form resonance with others. So we will say due to this transangular effect, let me remove that. Due to transangular effect, there is SIR. What do you mean by SIR? There is SIR, steric inhibition in resonance, steric inhibition in resonance, and due to which ring has become non-planar. Now the ring has become non-planar, and non-planar ring is non-aromatic. That's simple. So these reasons will come and you have to answer it like this. And the same thing is with 12 aniline. Same 12 aniline is having the same reason. Right, kids? One more thing I would like to tell you. If the compound is given like this, no, this is not up to the mark. Let me draw it once again. It was not nicely drawn, okay? Now it's perfect. This example is given in NCERT. It is known as tropolone. What NCERT written? Tropolone. Then you can see this compound. These pi electron are the part of this ring 1, 2, 3, 4, 5, 6, but this has got freedom to move, and this pi electron will move like this and it will be like this. Now see, kids, it will remain like this, and this is telling us number of things. 1C, 1, 2, 3, 4, 5, 6. Aromatic, this is also, that is also. So it will remain in equilibrium, and delta G we will say is negative for this. The reaction is spontaneous, or the process, not the reaction. The process is spontaneous in the right hand direction. So this pi bond is moving, so charge is there, and because of the charge we will say dipole moment is equal to Q into D. So due to charge, polarity, high polarity is high. this compound's polarity is high, and we will say this pi bond is having free rotation. It is free to move, free rotation. Now you will ask, so what is this? Please explain in detail. Let me show you. Let me show you. If I write down in place of this, if I draw this compound, just see this compound. Now, if you want to apply the same process, if you want to rotate this pi bond, my dear students, if you want to rotate this pi bond, this compound will look like this. Just see to it. It will become like this. And now see, kids, right now it is having 1, 2, 3, 4 pi electron. It has become anti-aromatic. And my dear students, here 1, 2, 3, 4, 5 pi electrons. It's non-aromatic. So non-aromatic is comparatively being more stable. More stable. So this is having Trojan rotation. For this, delta G is positive. This will not move in the forward direction, and this pi bond is having Trojan rotation. Any type of question can be given by examiner, so aware. Keep yourself updated. Now let me know in the chat section, kids, you are able to understand. Is everyone able to understand, kids? Yeah, how the questions will get framed, I will show you. I will show you. Now things are clear to all of you. Everyone just do let me know. Palak, I am not tired. Okay. Show me green hearts so that Baba HSP should become active. I want to see the green heart so that, Palak, you're right. I was a little bit tired. So let's go with the questions, right? This is really tough question. Toughest question. This is of year 2016. In 2016, examiner has given toughest question. What should be the answer? Let me know in the chats. Let me know in the chats. This is really very good question. A really very good question. This was the question. Yeah, Harisha has given the correct answer, 2 and 5. How many of you want to know why this 2 and 5 is the answer? 2 and 5 is the correct answer. How many of you want to know? How many? Now, secrets. This has got freedom to rotate on both the sides. You can say it can go on this side, then this will come over there. That is the freedom. Or it can go on this side, it will come over here, right? Now first let me rotate that side and let me draw. This is going this side, then you will get it has rotated. Positive charge, pi electron over here. Now once again it will get rotated. Now out of these two, which one is more stable? See, positive and negative are nearest, so this is more stable. They are nearest. These charges are nearest. So charge is on 5th carbon. This is more stable. This is less stable. Now let me move like this. Once again it will move. Now negative positive nearest. So this is most stable, this will not form. This carbon is second, so it's stable on second and fifth. Got it? If clear, then show me green hearts. Let me see that it's clear, kids. Show me green hearts if you're really liking the explanation. Sumedha is saying, wow, that's really awesome. Okay, that's really awesome. Now see, kids. What type of questions will be asked on this? These are the questions will be asked on aromaticity. They are asking which of the following compound is non-aromatic. Let me see. Let me know in the chat section. Do let me know. C. Some are saying C. Kids, fast, fast. Now see, kids, I've told you what is required. You can see clearly this carbon is sp3 hybridized. Can you see? So ring is non-planar, and non-planar means non-aromatic. Right, kids? So the answer will be B. Which of the following is least stable? Just see to it and do let me know. Can you see? Is it clearly visible, kids? D, yes. All are aromatic except this. You see, this is sp3 hybridized. So it is non-aromatic, and non-aromatic are less stable than aromatic. This is aromatic. This is also aromatic. Furan. Pyridine is also aromatic. So D is the answer. D was the answer. Now, another question, what they are saying, which of the following chemical system is non-aromatic? Do let me know the answer. Non-aromatic. Counting star, thank you. Do let me know. First one is the answer, right, kids? First one is the correct answer. Why? This is sp3, non-planar, non-aromatic, right? Now once again see the question. Let me have a sip of water, kids. Do it and do let me know. Most stable means aromatic. Yes, kids. Do let me know your answer. Some are saying A, some are saying B. Let me tell you, kids. This is having 2 pi electrons. Aromatic, right? This is having negative charge, anti-aromatic. 1, 2, 3, 4, 4 pi electrons, anti-aromatic. What they are asking? Stable or unstable? Which is most stable? This is anti-aromatic. This is non-aromatic. So only one is being aromatic. So this is the correct answer. Got it? Now aromaticity waste, you got it. This question. Do let me know the answer. Do let me know the answer, kids. Unstable at room temperature. Now see, this is aromatic. This is anti-aromatic. So one is this answer. This is, leave it. So will become anti-aromatic. So definitely D should not be there. So this can't be the answer. And A must be there. So this can't be the answer. Along with A, B, why it can't be the answer? B is there, which are unstable. So this is the correct answer. And why I said this can't be there? That was wrong. Could be there. What's happening? Okay, you got it. Now see, kids, acidic strength. Just see to it and try to answer it. Acidic strength. Let me check it out in the chat section. How many of you can answer it, kids? Fast, fast. I want to see answer. B1. Let's see. We have to focus on the negative charge of this carbanion. Negative charge on this carbanion. Just see, kids. This OH due to plus M or plus R will donate electron at ortho and para and the charge increased. So which of the following is weakest acid? So definitely this is going to be weakest because this will apply minus I. So will withdraw. So B is the correct answer, you kids. So winner, B should be the correct answer. Very good. Fantastic, kids. That's really awesome. Really awesome. Now here, let me see whether you are able to answer this question. Then I will say you are genius. Definitely, I would like to say you're a genius. Let me check it out. How's the Josh, kids? First of all, do let me know how's the Josh. Really, you are enjoying it. Sana is going for third. Rest of other kids, do let me know. Prachita is also going for third. That's really awesome, kids. Oh, fantastic. So, okay, you are enjoying. Now, let's see whether Baba is able to solve this question or not. Should I solve like a kid? Hey, phenol, phenol, phenol. Phenol, phenol, phenol. People will say, no, no, naughty, naughty, naughty. Minus M, minus R. Put to delta positive. Wah, wah, wah. Charge will decrease, so it should start with 3. How many? Oh, only one is starting with 3. We got the answer. Yeah. Suppose, kids, if I'm getting bored, I will start dancing. Now I'm feeling good. Kids, at least show me some green hearts. Baba, what Baba is doing, kids. Hey, everyone, just do let me know. Show me green hearts. Okay, now see, kids. This one. Now this one is a really good question. Let's see how many of you can do this question. This is awesome question, kids. Awesome. Let's see this one. M for mesomeric effect, R for resonance. Kids, M means mesomeric effect. I taught you now. R means resonance. Right now I taught you, no? I taught you or not? Mesomeric and resonance. Let's see what's your answer. Everyone just to let me know. This is really a nice question. Good. Okay, let's see. Divide and rule. These two are phenol and these two are carboxylic acid, right? So answer will be from this. This is methyl plus H. Hyperconjugation, I taught you hyperconjugation, del negative. So 3 will be more than 4. Starting with 3 then 4. So only this is the answer. So it should be the correct answer. Yeah, this is the correct answer. Now, kids, I would like to give you, after GOC, I will give you hydrocarbons in the form of questions. Are you ready? GOC we have completed. So we will go through hydrocarbons through questions. Are you ready for the conversions? Is everyone ready for the conversion, kids? Do let me know. Conversions. We will go through conversions. Are you ready for that, kids? Do let me know. Do let me know, kids. We are going to deal with hydrocarbons. And we will cover up hydrocarbons through questions. First of all, do let me know that everyone is ready, so that what type of questions will be asked in hydrocarbons, I will move through that. Just do let me know, kids. We will cover hydrocarbons through conversion questions. Show me green hearts if you are ready for this. Along with some fire, what type of questions will be asked in hydrocarbons? We will deal with the hydrocarbon with the form of questions, right? What type of questions will come? Let's see. Let's see. Question number 1. This is going to be your knowledge. Sit with full on energy, kids. Calcium carbide plus water gives A. A reacts with H2PD. C gets B. B reacts with O3, zinc and water, gets C. Now you are supposed to find out C. This is the first question, right? Let me check it out who will answer it. Then I will say who is the genius one. Kids, now your time, actually your time starts now. Let me check it out. No options. And now, no, after hydrocarbon, I will teach isomerism. Isom. Wow, Prejwal ready. Wow, wow. Everyone claps for Prejwal ready. Correct answer. Absolutely correct. Prejwal ready. Calcium carbide. Just see calcium. Ionic bond, carbide is like this. And water, if you're going to treat it with water, kids, acetylene is the answer. Just see, oh my God, such a acetylene, this is here, acetylene, this is acetylene, and this is having two acidic hydrogens, but reaction is Lindlar's catalyst. So no cis and trans because double bond is dead. Ozonolysis, the bond will break from here and 2 moles of formaldehyde. Really awesome. Now second question. On the spot I am going to make question. Just see kids. What is E? Let's see who can answer this question. What is E? So Medha, don't worry, you can answer it, just try it out. What is E, kids? Yes, kids, what's E? I think Sahana, just a little bit. Kids, right now we are not having this much of time to take whole chapter, kids. That's why I'm going through questions. Lalita, already I have taken lecture on this. You can see anytime the previous one. Lalita, this time we cannot move through the whole chapter because counting star, no, don't go. Yeah, I will take isomerism. Now, see kids, what's the correct answer? I will take isomerism also. The first reaction is Kolbe's electrolysis. Now, let me tell you the trick how to do the Kolbe's electrolysis. Baba HSP's trick. I've told you number of times. Now, once again, I will explain. Just see CH3, CH2, C double bond O, Na. This is trick for Kolbe's electrolysis. Now see, water is also there. Just see kids. Break it from here and join it over here. So this will be butane. This will be 2 moles of carbon dioxide. All these things will take place at anode. This much at anode. Now at cathode you will get hydrogen gas. And in this solution you will get NaOH. So that will increase pH. I hope you got it. Kolbe's electrolysis, everyone got it. So this is butane. Now major product on the secondary, free radical, now Sedgwick product, butene. Now during ozonolysis it will break from here. You will get 2 moles of acetaldehyde, and that's why I said you people are closer to it. Ethane, Clemenson's reduction. Can you see? Ethane. How many of you got it? Just show me green hearts if you're liking it, kids. The way I'm teaching, the way I'm telling you hydrocarbons kits. I will cover up each and everything in this way. Kids, do let me know you are really liking it. Okay, now see. Next question. I will cover up all the reactions of hydrocarbons. See kids. What is C? What is C? Anyone? What's being C? Fast. Don't worry. But just to let me know the answer. It's hit the like button. Why it's not 1.5? Benzene. I think Prajwal is right. My goodness. One kid is there who is doing questions so speedily. I think Prajwal Reddy is right. Let me check. Benzene. ESR. Chlorobenzene. He's doing with rocket speed. Now Grignard reagent RMGX. And definitely LiH4 will transfer. Oh my god, claps, huge round of claps. Absolutely correct answer. This kid is really doing awesome. Wow. Huge round of applause for this kid, kids. Huge round of applause. D. What is D? Let me see. Prajwal Reddy. Will you find out D also? No, even ChatGPT can't do this question because I am making right now. I am making fresh questions. So even ChatGPT can't do these questions, kids. Wow, Sahana. Fantastic. Huge round of applause for Sahana. Absolutely correct answer. Oh my God, Sahana, you are rocking. Absolutely correct answer. Huge round of applause for Sahana. This KOH, K positive will come over here, will steal this bromide, so positive charge, and OH negative will come over here, will steal this proton, so negative charge. So first you will get CH2 double bond CHBr, then NaNH2 will come. NaNH2 will come, this is A. NaNH2 means Na plus will come over here, and NH2 negative will come over here. This will steal this, so you will get plus charge. This will steal this, so negative charge. You will get acetylene, but with excess of this hydrogen, because acid base reaction will take place. NH2 negative will come further, steal this. NH2 negative will come further, will take this. You will get disodium acetylide. Now methyl is in excess, so from both the side methyl chloride will come. Methyl chloride will come, and it will take away this NaCl. So you will get CH3, C triple bond C, CH3. Lindlar's catalyst will always form cis. So absolutely correct answer given by Sahana kids. Huge round of applause for Sahana. This is really awesome. This question was a really awesome question, and nicely answer is explained by Sahana kids. So huge round of applause for Sahana. That's really awesome. Now you want more such type of questions to cover up the whole hydrocarbon? Some more questions you would like to move with? Sayyid Mariam, what type of topics? What type of topics? I haven't left any topic in hydrocarbon. Sayyida Mariam, we have gone through each and everything. We have not left even a single topic. The aromaticity, the basic strength, carbocation, everything. Do let me know. Sayyida Mariam, we have gone through. Oh, she is spammer. Oh my God. Oh my God. I was not aware of that. She is spammer. Okay. Now, kids, let me give you some memory charts for hydrocarbons, right? Let me give you so that you can do such type of questions, okay? The first mind map. I can understand that everyone can't do all the questions, right? Mind maps, so that everyone can easily, but say thank you in the form of green hearts. If I am going to give you mind maps to clear, to do any question of hydrocarbon, then show me green hearts. I want to see green hearts that you are thanking me, kids. Now, first mind map starting with CH4. Just see. Do the chlorination. Chlorination, I want to see green hearts, then only I will tell you, kids. Cl2 H nu, this is known as free radical substitution reaction. You will get methyl chloride. Now, methyl chloride on doing Wood's reaction, if you want to become expert, twice of Na dry ether, known as Wood's reaction. You will become hero if you go like this. Then doubling of compound, you will get ethane. Now to move ahead, once again do chlorination. Cl2H nu, once again free radical substitution reaction. What will you get? Ethyl chloride. Okay, now do the reaction with KOH alcoholic. Heat, you will get ethene. Now, if the reaction would have been done with KOH aqueous, then the product would have been formed as ethyl alcohol. Now, from ethyl alcohol, you can get this ethene by reaction with concentrated H2SO4, 443 Kelvin, and further you can get back if you react with water. Now, if you react it with bromine water, then the reddish brown color will get decolorized. You will get CH2Br, CH2Br. Now the reaction which I have shown you right now, KOH, first KOH alcoholic, heat, then NaNH2, you will get acetylene. Now acetylene on reaction with 1% HgSO4, 40% H2SO4 with water, you will get acetaldehyde kits. Now acetaldehyde on oxidation with KMnO4, acidic medium, you will get acetic acid. That on soda lime reaction, you will get this. Now this on reaction with PCC, you will study in class 12th, you will get this, and this on reaction with NaBH4, you will get this. How is the mind map? Just to let me know in the chat section. This is the first mind map. I will give you more mind maps. Do let me know, kids. First of all, do let me know how is the mind map. Okay, Cunesia. I'm not saying that you are a spammer. Who told you? Who said? Cunesia, you are a very good student. Now, tell me, kids, you are liking it? Everyone just to let me know. Thank you, Afifa. Thank you. Now kids, do let me know you're liking this mind map, then I will give you the second mind map. Kids, do let me know. Thank you, Janvi. Thank you. Just after this, let me take questions of that isomerism also. One more hour, it will take 1 more hour, right? Okay. Some kids are not able to understand in this way. Let me tell you, don't worry. Let me tell you, don't worry. You kids are like my own kids, very good students. Let me tell you. See, let me tell you some important name reactions. Some important name reactions. Just see, the first reaction is known as Wurtz reaction. Have you heard the name Wurtz reaction? Not like Wurtz Khalifa, it's Wurtz reaction. If you take Rx, Rx is alkyl halide. This can be 1 degree or 2 degree alkyl halide, right? Two moles of Rx and 2 moles of sodium. Then what will happen? They will eliminate out in this way. Now you see what product you will get, kids. RR twice of NaX, double of the compound alkyl halide got converted into alkane. Now can you understand, kids? Those who are not able to understand, now tell me. Let me show you some reactions based on this. Let me show you some reactions based on this. What's reaction? Let me show you, kids. See, kids, if I write down CH3, CH2, Cl, if the question is given like this, Na, dry ether, what product you will get? So what you are supposed to do, kids? This was the question, how to get the solution. CH3, CH2, Cl, Cl, CH2, CH3, twice of Na. Now what you are supposed to do, kids? Remove this. Now you must be getting, kids. So you will get CH3, CH2, CH2, CH3. How many of you got Wurtz reaction? Known as Wurtz reaction. How many of you got it? Kids, Wurtz reaction is clear to how many students? Do let me know. Now you are able to understand Wurtz reaction, kids. Sayyid Mariam, purification we will clear in class 12th after once your Everything is clear, quantitative and qualitative, that is after 12th. And isomerism, yes, we will do after this. Okay. Okay, Sayyeda Mariam. Do let me know, is it clear? Very good, very good. After this hydrocarbon, we will deal with isomerism. Don't worry, don't worry. Yes, PYQ is enough after this. Yes. Now, let me tell you ESR mind map so that you can understand each and everything. Right? But before moving towards that, one reaction, name reaction is soda-lime reaction. Just see, soda-lime reaction. The trick I will tell you, also known as decarboxylation reaction. Decarboxylation. This is also known as lab method preparation of alkane. Now, how to do it? Kids, just see the simple technique. You are provided with R, C double bond O, O, H. In this mechanism, NaOH is used in axis and quicklime is used as catalyst. Carbanion is the intermediate on this H plus. So carbon dioxide will eliminate out, and what you will get? You will get R, H plus carbon dioxide, and this carbon dioxide will form a bond with NaOH to give Na2CO3, to give Na2CO3, right? Now let me give you example of this decarboxylation reaction. Just see to it. Suppose if somebody has given you this question and he is expecting product from your side, what answer you kids will give? Kids, do let me know. So what you are supposed to do? Just make carbanion of it. This proton will come over here and this carbon dioxide will get released. This will get released. So one carbon shortening of chain, there is shortening of chain, right? Shortening of chain. So the product you will get with one carbon less. So somebody is giving you question, kids. Now somebody has given you the question like this: benzoic acid. Now that examiner has given question like this, that what product you will get. So just remove carbon dioxide and you will get benzene as the product. Remember that beta keto acids, note beta keto acids undergoes decarboxylation simply on heating. No need of all these chemicals. Why is like this? See to it. If I write down, it's even the board is getting now see its carbanion is resonance stabilized. If you see its carbanion, this is resonance stabilized. Can you see this will do resonance over here, stabilized by resonance. So this carbon dioxide will eliminate out easily simply on heating. If you heat it, simply if you heat it, this CO2 will eliminate out and this H will come over here. So the answer will be CH3 CO CH3. Kids, if you got it, soda lime reaction, I want to see green hearts. I will not take too much time, kids. After this, let me give you, very good, let me give you one memory chart for ESR, and then I will take isomerins questions, right? And then it will get completed. Just half an hour more, kids, not more than that, right, kids? Is it okay? Just half an hour more. Now, kids, 10 minutes break, okay. So, let's give you the mind map after 10 minutes, kids. 10 minutes break. Let's take 10 minutes break, kids. So let's meet after 10 minutes, okay, kids? Everyone, are you back? Show me the green hearts. So let's it go. Let's it go. Let me tell you the trick for ozonolysis. Whenever you deal with ozonolysis, you can do any question. If you know this trick, the basic fundamental trick, whenever you are provided with any alkene, I will tell you the ozonolysis trick for alkynes also. This is R1, this is R2, this is R3, and this is R4. Anything can be like that. And if you do the ozonolysis, gets what you're supposed to do. They will give you thing like this, O3, zinc and water. What you're supposed to do, kids, along with the sigma bond, wherever it's located, the pi bond and sigma bond, break it from here. Once you break it from here, what you will get? You will get like this R1 over here, at this place R2, just place at this place oxygen, and there also you are supposed to add oxygen, nothing else, nothing more than this. It's very simple. Let me explain on the next. Already I have explained. You can solve the questions. Suppose if they have given question like this. Now see, what I've told you, you're supposed to do only this thing. O3, zinc and water, my dear friends. So what I've told you, along with sigma, you break the pi bond and put oxygen. So you will get oxygen over here. This is R1 and R2 being same. And there CH, double bond O, and CH3. It's simple. It's simple or not? It's very, very simple, kids. You got it? Have you got it? Now, if suppose by chance they are giving you tough question, if the tough question has been provided to you, you can see. Let me show you, kids. Till now it's clear. Till now it's simple or not. Just to let me know it's simple or not. Let me see in the chat section. It's really simple or not. Oh, Kevin thought, that's really awesome. You're thinking for my health. Wow, that's really awesome. But let me complete this, the ESR graph, and then questions of isomerism. That's it. It will not take more than 1 hour. It will not take more than 1 hour. So see what I was telling you. See, and Kevin, thank you for thinking my health. That's really awesome. I'm loving this thing that kids are thinking, even thinking for Baba HSP's health. That's really awesome. Love you. Now see, kids. Suppose they have given question like this, CH2 double bond CH. CH2, CH double bond C, CH3. Now 1 and 2 pi bonds are there. So 2 moles of ozone will get consumed. 2 moles. 2 moles of O3, zinc and water. Now break the bond from here. So broken the bond from wherever bond is breaking, just remember. from wherever bond is breaking, just you are supposed to add oxygen over there. That's it. These are the three products. Clear, kids? Got it? So ozonolysis of alkene is being clear. Now let me tell you the ozonolysis of alkyne. R C triple bond C R. Now here already 2 pi bonds are there, so sigma bond will not break. 2 pi bonds you are supposed to break. R C C R, it will remain intact, and just place oxygen at this place. So this is your answer. Let me give you example for this. CH3 C triple bond C CH3 1, CH3 C triple bond CH2 CH triple bond CH. So if you do the ozonolysis, just see your product is getting matched with my product. Check it out. Just check it out. These are the products. So now I will let you know ESR and then questions of isomerism. It will take not more than 30 minutes. Ready for that? This much. Are you ready, kids? Kevin, really? Wow, really? See, nice thought. Wow, Kevin is writing, okay, sir, for your age, don't repeat this. You must have family and responsibility. Thank you for your sacrifice. Oh my God. Kids, see, there is Kevin. Such a mature thoughts. Wow, Casper. Now, Casper, you are able to understand. You said that converts it that way. Now, this way you get it. This way you are able to understand. Do let me know. Very good, Casper. Now, see, I take care for each and every one. Are you getting my point? Now, ESR mind map. ESR, let me give you ESR. ESR means electrophilic substitution reaction. In this, the first one is halogenation. Halogenation. How to do halogenation, just see. Now this will take away this one, this will take away this one, wrong. This will take away, hydrogen will go and chloride. So this one, this will take away this one. So you will get this product. Now, how this reaction is actually taking place, let me tell you the mechanism. The mechanism is first step, Cl2 will be reacting with anhydrous ale, Cl3 being the Lewis acid. This will snatch its chloride. So generation of an electrophile. Electrophile will get generated. The second step, this electrophile will attack on benzene ring. So benzene ring will get partial positive, partial negative. So this chloride positive will come and attack. It will attack over here. So you will get positive charge at this place. This chloride, you can write in this way, right? Now, this is the second step because this was aromatic kits. And this is having sp3 hybridized carbon, non-aromatic. Now, some people are counting just pi electron and they will say anti-aromatic, but the ring is not planar, so non-aromatic. So this is unstable. So slowest step, rate determining step, slowest step RDS. Now third step, what is going to happen? Now this H will go away with Cl negative, which was stolen in the starting. So this will get negative and negative positive once again. Aromaticity is back. So this is first step. I hope the mechanism is clear. Do let me know, kids, in the chat section. Do let me know, kids. I think I made the mechanism clear to all of you, kids. Everyone. Now, nitration. Just see the nitration. In nitration, only one step is very, very important, the first step. And that is very, very important. See, kids, nitration. This is your benzene. Concentrated HNO3 plus concentrated H2SO4. We will get the product as nitrobenzene plus H2SO4 along with some water. Now, my dear students, during this reaction, there is one thing very amazing. This acts as base. We know that HNO3 as an acid, but here it is acting as a base. I will prove it. Act as an acid, and this is known as nitrating mixture. What? Nitrating mixture. Now, if I tell you the mechanism, kids, just see and focus on the mechanism. Who is stronger acid? H2SO4. So let me tell you this mechanism on the next page, okay? On next page, because it require more steps. So first step, H2SO4 is stronger acid, it will donate proton. Now that proton that donated by this H2SO4 will accepted by NO2OH, the nitric acid. Its lone pair is going to accept this proton. My dear students, this proton will attack over here. You will get NO2, O positive, H2. Now oxygen is saying, hey Baba, I can't tolerate this positive charge. So we will say, okay, if you don't want to tolerate this positive charge, go away, get away as water. You will get NO2 plus and water. Now my dear friends, let's summarize it. Let's summarize it, what is left and what is deleted. Let's just see to it. This will cancel out with this. This will cancel out with this. So what we are left with? We are definitely left with H2SO4 plus HNO3 plus this is going to give you HSO4 negative, NO2 plus, H2O. Now kids, this is reversible. One question has been asked on this in 2016 and 18 also. What will happen? Question was, what will happen if we increase the concentration of KHSO4, if we add KHSO4 to this solution? Question was, what will happen if we add KHSO4 to this solution? KHSO4 means HSO4 negative. So Lee-Chatelier principle says if you increase the concentration of HSO4 negative, then it will come back, and once it is going to come back, it will come along with this, and if it is coming along with this, then the concentration of NO2 plus will decrease, and if the concentration of NO2 plus is decreasing, that means nitration will decrease, because this is the actual nitrating agent. Kids, I think you are getting my point. This is known as nitronium, this is the actual electrophile. If you add KHSO4 to the nitrating mixture, the equilibrium will go back and the nitration rate of nitrogen will decrease. Kids, got it? Do let me know this point. Have you got it? Have you got it this point, kids? Do let me know. Wow, Seba Anil, everyone is thinking about my help. My God, kids, do you really respect me? Really, kids? Really? Sarthi, very good. Thank you, Gacha. Thank you, kids. After once the class is over, will you put comments? Really, kids, I have started loving you, kids. Oh my God. Sahana, Marsha, Casper, Sevanil, C kids. Oh my god, oh my god. Mustaq Ahmad Bhatt. Wow. You really, oh my god, kids. What is this, kids? You started loving your Baba. You really this much of respect. Really. Now, sulfonation. Really, it's nice to see, kids. I'm really glad to see this much of respect for me, kids. Really glad. Really, really. Dil se, from my core, internal core of my heart, kids. Now, in two ways you can do sulfonation. One, by using concentrated H2SO4, 2 moles or excess, and the better will be done by oleum, that is fuming H2SO4. This one is better. This one is better sulfonating agent. Now you must be thinking why it is better sulfonating agent. I will tell you, kids. But remember that this sulfur belongs to 3p. So this is a reversible reaction, not a stable bond, reversible. Now why oleum is better sulfonating agent? Let me explain, kids. Mechanism, for that we have to see the mechanism, the root cause of each and everything. If I use concentrated H2SO4, and why 2 moles of H2SO4 are being required? You see H positive, HSO4 negative, and this H plus will attack on another molecule of HSO3, HSO3OH. Now this is acting as an acid as well as base. This is the most important point, kids. Point to be noted, my lord. Acting as an acid, acting as a base. That examiner can ask this question because it is donating proton as well as accepting protons. So you will get HSO3 O positive H2. Now oxygen will say, I can't tolerate this positive charge. So if you are not going to tolerate this positive charge, then what will happen? HSO3 O positive H2, then we will release water, eliminate out water, then you will get HSO3 positive. Now this is also having positive charge, so one more step, HSO3 positive, water will take this H plus, you will get SO3 plus H2O. Now let's summarize it. What is we are getting over here and what's getting deleted? Just see what's getting deleted. This H plus will cancel out with this H plus, this will get cancelled out with this one, and this will get cancelled out with this one. These ones are got cancelled out. Now what is this H2O? Well, H2O is taking, so it will no, it will not cancel out because this will become H3O plus. This will become H3O plus, right? Now, so you will get 2 moles of concentrated H2SO4, twice concentrated, because Lee-Chatelier principle says if you use concentrated H2SO4, then reaction will move in the forward direction. You got HSO4 negative and you got SO3. So this is the point to be noted, my lord. In these many steps, you are getting SO3, the actual electrophile. In these many steps. But if you use oleum, you know that oleum, what is oleum? Oleum, it's H2SO4 liquid and dissolved SO3 gas. Already gas is there, or you can summarize it. You will get H2S2O7. This is your oleum, fuming H2SO4, because fumes of SO3 are there. Already SO3 is there. That's why it is better sulfonating agent. This one, you got sulfonation. Now Friedel-Crafts alkylation and acylation. Devanshu Kumar saying, if life is chemistry, then boil your ego. Oh my God. Oh, Sarthi, you are having all these notes. Good, good, good. Now, Friedel-Crafts alkylation. Friedel-Crafts. Alkylation. It's very simple. It's Friedel-Crafts alkylation. You can immediately do it. Just see to it. If I write benzene, if I write RX, if I take Lewis acid like anhydrous AlCl3, this is Lewis acid, it will take away this X and this carbocation will form. And remember that whenever carbocation is formed, always think about rearrangement. So rearrangement may take place to give more stable carbocation. So then your product will be alkylated benzene. Now, for example, one very well-known example is there for this reaction, kids. That number of times this question has been asked, and propyl chloride is reacting with this. What should be the product? They are asking like this. So what you're supposed to do, kids? Just remove this chloride with this Lewis acid. You will get this carbocation. Just think about rearrangement. You know very well that 1,2 hydride shift. If it is taking place 1,2 hydride shift, then you will get more stable carbocation. And this will go and attack on benzene ring. So your answer will be cumene as the major product. Your cumene is the major product, kids. Got it? This is major one. Along with this, number of other minor products will be formed. But this is your major product. It's major product. Now, last but not the least, Friedel-Crafts acylation. Now, this is superior to alkylation, superior to alkylation. Why it is superior? Because of two things. Why it is superior? Because of two things. No rearrangement take place in this, and no further acylation. Now see, it's very simple. RCO, I will tell you the reason also why further acylation and rearrangement does not take place. Once again, it will take away this X. So you will get this carbocation, and just see why no rearrangement, because this is already stabilized by back bonding. Back bonding is taking place. So back bonding is 2 atom resonance. I have told you already the back bonding. So this will not do any rearrangement. And see, once the product has been formed, this is meta director. This is meta director. Electron withdrawing group is there. Minus M minus R is there. So no further acylation. Kids, just to let me know how you're feeling now. Kids, how you're feeling now. Kids, really, kids, really. And now revising your notes, all this looks easy. Thank you, Sarathi, thank you. Bangalore Prathu Rajesh, thank you, thank you. Oh, kids, you are enjoying. This is the best thing. You kids are really feeling good, comfortable. This is giving me lot of energy. Now I'm back. Now, one note, and then I'm going to start isomerism. One note, one note. Note is that aniline and all meta directors they do not show FCA. What is FCA? Friedel-Crafts alkylation and acylation. Now, this is all, but before moving ahead to reactions which generally kills your marks, anaconda reactions, two anaconda reactions. I have to write over here, otherwise you will lose marks in your exam. See, kids. This is ESR reaction, so we will use anhydrous AlCl3. This was C6H6 and this is C6Cl6. Its name is hexachlorobenzene. All right, no problem. This is an example of ESR, no problem, but see kids. This is benzene, C6H6. Now see, this is C6H6Cl6 and its name is BHC. Mind my words, BHC. The full form of BHC is benzene hexachloride, benzene hexachloride. But there is no benzene, but the name is benzene hexachloride. Mark my words, no benzene but name is benzene hexachloride. So examiner will give question that BHC, asserts in reasoning, BHC is aromatic because it follows planarity rule and Huckel's rule, and kids will say yes. But see, this is not benzene, this is not benzene. Remember this, not benzene but name is benzene. It's not aromatic also, not aromatic. Are you getting my point, kids? And it is also known as gamexene powder or 666, or its name is lindane. These many names are there. So this is really comparative anaconda 2 reactions. So always do the study of these 2 reactions all together, otherwise they will kill your marks. Yeah, still isomerism pending. Now we are going to start with isomerism, kids. Are you ready? Are you ready? Oh, Afifa is writing, I used to hate organic chemistry, but you made it so easy. Oh my God. I don't hate it anymore. All the teachers I have studied from in the past, I never understood. Oh. Afifa, please keep this message, and once the class is over, I want to see this message. Will you write? Just keep it with yourself, and then once the class is over, I want to see in my offline, I want to show it to my offline students. Thank you, Vishal. Thank you. Oh my God. Now 20 minutes more. Wow, everyone is able to understand now. Yes, for Lalita, Sarthi. Oh my God. Chalo, let's set go. Let's set go with isomerism, okay? Are you ready, kids, for the isomerism? Show me green hearts if everyone. Thank you, thank you, thank you. Let's set go. Let's set go. Now see kids. Okay, so answer you have seen, so I will not start with this question. You have seen the answer. Okay, let's start from here, right? The total number of structural isomers possible for this compound. Before starting this question, the another question can be asked: the number of structural isomers possible for C4H9Cl. These are the two questions generally they ask. Now see how to solve these two questions. Either this question they will ask, halogen they can place any halogen. So let's see, let me take a fresh page to solve such type of questions. Remember that first of all, to solve such type of questions, we should know that C4H10, if I am being provided with C4H10, how many structural isomers are possible? 2, CH3, CH2, CH2, CH3, N-butane, N-butane, and isobutane. N-butane and isobutane. Agreed? This is your N-butane and that is being your isobutane. So this is the basic. Everyone, we should know the basics. Basics should be very much clear. Now if you replace this hydrogen or that hydrogen and you place chlorine, 1-chlorobutane, same. And if you replace this hydrogen, they are same. So from here you got two alkyls. Am I right? You got two alkyls, N-butyl and sec-butyl. Now see, if you replace this hydrogen, this hydrogen is same thing, and if you replace this hydrogen, it's different. From here also you got two alkyls where you can place either chloride, bromide, iodide. To total you got 4 alkyls. That means now no need to write down all these things. You have to put it in your brain that C4H9 forms 4 monovalent radicals. Always you have to keep this in your brain that C4H9 forms 4 monovalent radicals. Always. This much is clear. I hope this much is clear. Let me see in the chat section that this forms C4H9 forms. Oh, rock with N Naveen. Wow. 4 monovalent radicals. This is clear to all of you kids. Now see kids, same thing I will do with the another one. Another one was C5. So remember, keep in your brain that this forms 4 monovalent radicals. And C5H11 forms 8 monovalent radicals. Remember this, learn it, cram it. Now you will say, no, sir, I want to visualize it. So kids, let me show you. So write down C5H12. Now this will form 3 structural isomers, N-pentane, isopentane, and neopentane, right kids? Let me write down their names also because important. N-pentane, isopentane, neopentane, now if I remove one hydrogen from here or here, that means same. If I remove from here, that is different, and if I remove from here, it's totally different, right? So 1, 2, 3. I have got 3 monovalent radical from here. Now see the second one. If I remove from here and here, they are same. If I remove from this place, that is methyl but different from this, because these two methyls IUPAC name will be different and that will be different. Now if I remove from here, that is different, and if I remove from here, then it's different. So 1, 2, 3, 4. Oh my god, I have got 4 monovalent radicals. from here, 3 from there, and in this they are same. So this will give 1 monovalent. Number of times they have asked the question, new pentane will give how many monovalent radical? 1 type. So 3 plus 4 plus 1 is coming out 8. Already I have told you 8. Now just see what should be the answer of your where it's gone. So answer will be, do let me know what should be the answer. 8 should be the correct answer. Kids, till now everything is clear. Do let me know. Till now everything is clear, kids. Got it? Got it, kids? Do let me know. Everyone. Very good, Chaitanya. Now, even the board is hanging. He is also thinking that, oh my God, when you are going to leave me. So let's go. Yeah, let's make it go. Now this question is really awesome. Just try to do this question. I think you have seen the answer of earlier question already. The answer was declared. So let's move to another question. The number of chain isomers. So how many of you feel difficulty in making chain isomers, the number of chain and structural isomers for this? So right now we have done. So with the help of that we can do. For that we are having 3. So this can't be the answer, this can't be the answer, and if it is 3, then this can't be the answer. So elimination round, this should be the answer. Let me see whether am I right. Number of chain isomer 3 kids. I said that can't be the answer. Now I have to try. I have gone for this. Oh ho. Now kids, what is this? Even I have done mistake. Ayyo Ranga Swami. Now I have gone like this. Just see. So these 2 can't be the answer. Let me check. The C6H14, it's 3 or 5, right? 1, 2, 3. Chain isomers, na? Chain isomer. 3, 4, 5, 6. 1, 6 carbon parent chain. 1, 2, 3, 4, 5 carbon parent chain. 1, 2, 3. And 1, 2 carbons. So how many carbons? 6 carbons are there. It's 1, 2, 3, 4, 5 only. So let me make 4 carbons parent chain. 1, 2, 3, 4, 5. So 3 I made, but more than this not possible. Yes. Oh, great question. Good question. Good question, kids. Very good question. Got it? Now you have to solve it. Tell me, a functional isomer 1-butene. Do let me know the answer, kids. Now your turn. You also want to answer these questions. Do let me know. You are so intelligent, Prithu Rajesh. Number of students are intelligent. how you are doing all these questions? Kids, how you are doing? See, let me tell you the explanation of this question. Functional isomer of 1-butene. 1-butene is so 2 pi bonds are there, or you can say C4 H3 to 5 and 6. So if I write down like this, 1,3-butadiene, 2 pi bonds here also. So this is alkene, that is alkyne, both are having same molecular formula, so they have relation of functional isomer. This is butene, only 1 pi bond, only 1 pi bond can't be the answer. This is having 2 pi bonds, right? And it's not necessary 2 pi bond, its function got changed. One is being alkyne, another one is being alkene, and their molecular formula is different, but their molecular formula are not, their molecular formula are same, but they being different. See, butene, 2-butene, so C4H8, but this is C4H6. This is also C4H8. You can write down their names. The molecular formula is not same. I hope that everyone got it. You got it, kids? Do let me know in the chat section. It's clear, or should I explain once again? Thank you, Sahana. Thank you. You really, kids, you are respected kids. Really awesome. Really awesome. Everyone got it till now? Till now, is it clear to each and every one of you kids? Yeah, I can understand. It's long way. It's long way. I can understand. I can understand, kids. Yeah, it's isomerism. It's going on. Thank you, Alina Sheikh. Thank you. Thank you. I'm telling you each and everything. I'm explaining each and everything, kids. See, this is the answer. Methoxyethane and propanol are the example of isomerism. Tell me what's the answer. What should be the correct answer for this? Let me see in the chat section what should be the answer. Let me check it out. What's the answer, kids? Everyone. Now it's the morning time. It's the morning time. No need to take rest. It's the morning, morning. It's the morning time. C, everyone is going for C. Let me check it out, my dear students. It's a methoxyethane. La 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 la. It's being methoxyethane and propanol. This is, my dear students, this is propanol, right, propanol. So they are having 1, 2, 3. So this is being ether, that is being what? That is being alcohol. So their functional group is being different. So they are being the functional isomers. Am I right, dear students? Oh, already you have given the answer C. You are better than me. You are better than me, my dear students. Wow, 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 wow. So how many of you want 10 minutes break? How many of you want 10 minutes break? Thank you, thank you. 10 minutes break required. Rudranali, wow, sir, you really made chemistry easy like you said you would. Oh my God, kids. Okay, no break. Some are saying required, some are saying not required at all. So let's finish quickly, right? That's the best way. No need to go for the break. Let's complete it quickly, right? That's the best way. Now, geometrical isomerism. We are going to deal with, see, nice representation. This, both the two bonds are coming like this. Da da da. I'm cis, I am cis. They are going like this, one towards coming towards your side, one going away from you. I'm trans, I am trans. Cis and trans, they are not able to convert into each other at room temperature because of this pi bond. This pi bond is doing restricted rotation due to pi bond. There is restricted rotation. There is restricted rotation. Now you will say, how, sir? How? How is that possible? Let me show you, kids. Now if I say that I'm having one carbon at this place, one carbon at this place, the hydrogen is suppose lying on this side and one more hydrogen is lying this side. This is being CH3, this is being CH3. And if I say there is being pi bond, how the pi bond formation will take place? Just see, kids. Now, if I say this is pi bond, so first of all, let me tell you, this is the boundary surface diagram. It's not the pi bond. It's not the pi bond. Let me make it clear. It's the boundary surface diagram, right? Do you know the difference? You must have studied atomic structure. This is just the boundary surface diagram. It's not the pi bond. First thing. Now, if I move a bit towards this side, then probability of finding electron will keep on decreasing, keep on decreasing, keep on decreasing, keep on decreasing, keep on decreasing. Now, this and this together is orbital. Otherwise, that was boundary surface diagram. Now, see, it's touching at these two places, and this is pi bond. Now, if I want to make it trans, first of all, let me draw it clearly, otherwise you won't be able to understand. Just see, this bond is going this side and this bond is coming this side. That bond is going this side, this bond is coming this side. So, hydrogen, let me draw with different color. This is hydrogen coming out toward this side, and that is, let me draw with another pen, blue pen. This is methyl going on that side. Now, I want to fix this, and if I want to rotate, then that keeping this fix over here and rotating on that side. So, why you are not rotating the full? If I rotate full, then the methyl, both the methyl will come same side. If I say both the methyl are over here, if they go, they will go like that. But I want to keep this side constant and I want to rotate that side, then the pi bond will break, this bond will break, and breaking of bond is not a good thing at all. Breaking of bond is not a good thing at all. Kids got it? So for breaking of this bond, energy is required, and that energy is not available at room temperature. That is another thing, that if you supply some chemical, if you put some heat over there, that's why doctors, they are always prescribing that keep your medicines in the dark room. Never put medicines in the exposure of sunlight or some chemical, otherwise doctor has given you cis medicine and that has got converted into trans. So this is known as restricted rotation. I hope restricted rotation is clear to each and everyone. Is restricted rotation clear? Let me see the diagram. Nice diagram, kids. Oh, rock. I don't have any answer to this question. What should I say, kids? Do you have any answer for this rock with and Naveen questions? Anyone is there? PDF I will share in the Telegram, okay? In the Telegram I will share PDF, right? Now, thank you Vaishnavi, thank you, really thanks. Thank you Naveen for understanding. Okay. Okay. Thank you Sayyida. Thank you. Now see kids. My board is working slowly. Board is working slowly. Now see, nice diagram. See, free rotation about this single bond. This is single bond. Whenever there is single bond, and that's why compounds having single bond will show conformational isomer. They will not show geometrical isomer. Will show what? Will show conformational isomerism. Single bond. If there is being single bond, no restricted rotation because there is no pi bond. So single bond, whenever there is single bond, they will show conformational isomer. Can't show single bond, can't show GI, right? So leave it. This much is okay. Now, here is the question. Okay, before doing this question, okay, just try, then I will explain. Try it out, then I will explain. If you're not able to do it, I will explain. Let's see. I will tell you conformational isomerism. Yeah, sure, I will complete within 6, okay? Tell me what's the answer, kids. Thank you, Afifa Sheikh. Thank you, really thanks. Kids, do let me know. C. Okay, let me check it out whether your answer is right or wrong. The alkene that will exhibit geometrical isomerism. Now remember that whenever we are having alkene, these are the carbons, and remember that each sp2 hybridized, these are being sp2 hybridized carbon. So the condition is that each sp2 hybridized carbon must be attached with different atoms or groups, different atoms or groups. What I want to say that if this is X, then this should not be X, this should be Y. This can be anything, no, nothing to do with that. But if this is same, then also it's okay. But they should be different. Here, X is not equal to Y, they are different. Whether they are having relation with that, it's okay, and no relation, then also it's okay. Nothing to do with that. They should be different, right? Now, so if I say 2-methylpropene, if I take 2-methylpropene, just see, 2-methylpropene will look like 2-methylpropene, propene, 2-methylpropene. How to draw 2-methylpropene? I think this is 2-methylpropene, and these two are same, right? These two are same, so can't show GI. Now what should I say? Take 2-methyl, 2-butene, 2-methyl, 2-butene, butene, 1, 2, 3, 4 carbons, and 2-butene, 2-butene, 2-methyl, so 2-methyl. Or 2-butene. 2-butene means, sorry, I have to place double bond here because it's butene. So 1, 2, 3, 4, 2-methyl, 2-butene. So these two are same, these two are same, so can't show. Propene, so it's clearly visible that it cannot show, right? Cannot show. So only this is the answer. B is the correct answer. Have you given B as the answer? Have you given B as the answer? Have you got it? No. Let's see. Let us deal with a little bit tougher part, right? Little bit tougher questions, tough questions, right? It's tough questions. This is a bit tougher question, right? Let's see how many of you can give the answer, then I will explain. This is a bit tougher part, right? God will help you, Nan Naveen, definitely. Just see to it, whatever I am teaching, then definitely you will get benefited. Some are going for B, some are going for C. Now kids, before moving ahead, let's take one break. Kids, will you remain awake if I take 10 minutes break? If I take 10 to 15, will you remain awake or will you sleep? Kids, do let me know. If I take 10 minutes break, then will you remain awake or you will sleep? Thank you, thank you. So I will explain this question after the break, kids. Okay. Thank you, thank you. That's really awesome. So let me put here 10 minutes break. Let's meet after 10 minutes, kids. Everyone, let me check it out. I've washed my face. And what's about you? Let me check it out in the chat section. I want to see green hearts. Let me sit in front of screen and see, are you there? How many of you are there? I'm feeling sleepy. Some of you are writing, kids. Let me check it out. How many of you are active? Just to let me know. Everyone. Only 20 minutes more. 20 minutes more. Yes. Everyone, just show your presence and hit the like button if you are new. If you are new, hit the like button. I want to see like button to be smashed. Like button to be smashed, kids. I want to see your attendance. Yes, kids. Now let's it go. Oh my God, Sahana, that's really awesome. Sahana. Avyahana. Okay, let's it go. Let's see the answer for this question. How many stereogenic centers are there present in this compound? The one who is responsible for showing geometrical isomer, because it's not chiral. So see, let's see the stereogenic centers. So responsible for GI or OI. Now see, kids, stereogenic, first of all we should know what does it mean. Stereogenic center. Stereogenic center means something responsible for showing configurational isomer. For showing configurational isomer. What do you mean by configurational? Configurational means GI or OI or both. Optical isomerism, right? So here no chiral carbon, no such type of thing. So see, this carbon cannot show GI because it's dead. But we can see this double bond. This thing is different, that thing is different. So this is stereogenic center. So it should be, I would like to go for B. According to me, B should be the correct answer. So B is the correct answer. Now see the second question in front of you, kids, on the screen. How many stereogenic centers are present in this compound? Let me see your answer in the chats. Do let me know how many stereogenic centers. Do let me know your answer, kids. We have to do all the questions. Then only we can say yes, we are on the right track. Yes, kids. What's your answer? Do let me know in the chats. Fast, kids, fast. Sahana is going for 0. Casper tired. Just 15-20 minutes more. Not more than that, kids. Not more than that. And I think Sahana is right. I don't know why I think Sahana's answer is right, because they have written Me. So Me is what? Me is methyl only. Me is methyl and this is methyl, they are same. So I would like to say this double bond is dead. Dead means which can't show GI, can't show GI. So we have to go for 0 as Sahana has said. So 0. So see, both are same. GI not possible. The explanation is also given. So let's go for another question. The alkene that exhibit geometrical isomerism is. So I think this question is same. We have already done. So it was butene. This was the answer. So not to waste time. This we know. We have already done that question. Now geometry. This question is really awesome question. This you can say a little bit tougher side, mediocre question. I would like to say it's being mediocre question. Let me write down. It's being mediocre question. So try your the best. Let's see. Mediocre question. How many of you can do this question? Just see to it. Everyone just see to it. How many of you can do this question? I would like to see the answer in the chat section. Sahana is going for D. Kids, those who want to sleep can sleep. Kids, take care of your health. So I would like to say yes, you can see the recording, but I have to take the class, because if I'm not taking the class, how you will watch recording? Okay, kids, you won't be able to watch the recording if I'm not taking. D for doctor. Everyone is going for D. So I think your answer is and this is same, so can't be the answer. Here this is same and that is also same, so can't be the answer. Here this is same. Oh my god, so all three are wrong. So definitely this is different, this is different. So D is absolutely correct. Congratulations, congratulations kids. Wow, congratulations. How are the questions? These questions are really good questions. And geometrical isomerism is not shown by. Answer is given, I don't know why. Okay, answer was given over there only. This is really awesome question. Awesome question. So let me see the answer in the chat for this question, kids. FIFA Sheikh is still with full on energy. That's really awesome. FIFA Sheikh. Sahana is going for 2. Sahana, you are so intelligent. I think 2 is the correct answer, because I think only this is the center for showing stereogenic center. Yeah, 2 is correct. Sahana, congratulations. How you got this much of intelligence? You're really doing the best, the best. Now, how many geometrical isomers? Oh, this will take time. I think it will require a brain also. So if your brain is still working, let me check it out what answer you are going to give in the chat section, because it's really requiring brain. Thank you, Alia Muskan. Thank you. Lingus is going for 1. Okay, Shanvik, all the best. Do let me know, kids, what's the correct answer. So let's see. You're taking too much time. If I tell you that I'm having something like this, just see. If I say I'm having something like this, let me make triangle, okay, let's say this is triangle, I made triangle, and if I place 3 pens, this is triangle, I made triangle, just see, and if I placed one over here, one over here, one over here, so one can go down and 2 up, 2 up, 1 down, all 3 up, 1 down, 2 up. Now anything else you can make? Anything else you can make? I don't think so. So answer is 2. See, all up or all down. Either I can say all up or all down, same. They will remain same, right? Now any two up, 1 down, or I can say any 2 down and 1 up. So these 2 possibilities. Really getting it? If any doubt, just write down. If you're liking it, if you got it, show me green hearts, and if you have doubt, then write down doubt if you're not able to understand. Do let me know, kids. If you got it, I want to see green hearts. Yes, kids, yes. Yes, kids. Thank you, Sahana, thank you. Thank you, Boost Gaming, thank you. So everyone got it. Now next question, okay? Next question. Just see the next question. How many geometrical isomers are possible for given compound? So once again, I want to see answer in the chats. What's your answer? Do let me know what's your answer, kids. Let me see the chat, what answer you are giving. B. Chaitanya Maskare is going for B. Rock with Nabeen, Afifa Sheikh, everyone is going for B. So they are asking for geometrical isomers. So see, kids, I think this is active. And this is also active. Oxime time, right? So 2 are active. So total stereogenic center are 2. So 2 raised to power 2. I will go for 4. I don't know why. So I want to go for D. Let me see. Yeah, I was right. Stereogenic center are 2. So 2 raised to power 2, 4. Got it, kids? You got it. You got it. Just to let me know. You got it or not? Everyone, just to let me know. I was right. Hey, fire for Baba. Fire for Baba. Now another question. How many geometrical isomers are possible for given compound? 2 compounds are there. Let me see what answer you are going to give. Yes. Sana is going for A. Rest of others. Uli is going for D. Srushti is going for A. Now Baba has to interfere. Let's see, kids, what should be the answer. This is active and that is active. For this, two are active, but the terminal are same. Remember that when terminal are same and they are even, so total number of GI will be equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to n by 2. And n is number of active double bonds. N is number of active double bonds. So it will be 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So 2 raised to power 1 plus 2 raised to power 0. So 2 plus something raised to power 0 is 1, 3. First answer is 3. And second answer, these two are different, so 2 raised to power 2, and that is 4. 3 and 4. I will go for D1. I will go for D1 because here you see, here this terminal group is different from this. That means R1 is not equal to R2, but there R1 was equal to R2, so they are having different formula. When R1 is not equal to R2, total number of GI is equal to 2 raised to power n. So this 3 and 4 is the correct answer. Let me check it out. Yeah. Green hearts for Baba. I want to see green hearts. Let me check it out, kids. You are really liking the way I am explaining each and everything. Kids, you are really liking the way I am explaining. Do let me know, kids. You are really liking it. Okay, Alia Mushkan. That's really awesome. Very good. Now, next question. Next question, kids. Oh, this is really awesome. See, first of all, the slides are really good. I made for you, kids. I really made for you, kids. The slides are really good or not? Really awesome slides. Okay, now do it. Do it. Let's see who is going to do it. Thank you, Alia Muskan. Thank you. Now do it, kids. Boost Gaming is for going for D. All of the above. Okay, let me see, kids. Let me see. Baba is also going to see, kids. Which one is Z configuration, right? In this is senior. In this is senior. So Z. Here, out of this bromine is senior, and out of this carbon and 2 carbons. Yeah, Z. So 2 are Z. So no need to do it. No need to do it. So Z is the correct. All of these. Oh my dear students, you got it. How you are doing, kids? How? I can't understand. Absolutely correct. Now do this one. Let me check it out. What's the answer for this question? Let me check it out. Congratulations. Thank you, Alia Muskan. Thank you. Yes, kids. I want to see your answer. Yeah, FIFA, definitely. Thank you. So, yeah, kids are going for D. Let me check it out. Let me check it out. Each and every example, just see here. This is senior, here CHO2. This is Z configuration. But they are asking for E, and this is senior, here this is senior, once again Z configuration, and in this is senior, and there this is senior, once again Z configuration. So only one is left, so I think this will be the answer. No need, but then also this is senior, and there that is senior, this is E configuration, so this is your answer. How many of you have given this D as the answer? Then you can show the green hearts if your answer is correct. Those who have given D as the answer, right? Yeah, that's really awesome. That's really awesome, kids. Now let me change the type of questions, right? Now let's go with different type of questions, kids. Yeah, tautomerism based questions. This is really awesome question based on tautomerism. Tautomerism is exhibited by. I want to see the answer. How many of you can give the answer? Alia Muskan, yes, just this is the last 10 minutes. The each and everything will get completed, and then for 5 minutes I will take for the conformational isomerism. Thank you, Kunisha. Thank you. Thank you. Really, thanks. Srishti is asking what is tautomerism. Yes. Yeah, Boost Gaming is going but C. Okay, let me check it out whether your answer is right or wrong. So see, tautomerism is exhibited by, see, this is already enol, so it can convert into keto. 1, 1, 2, 3. This hydrogen can come over here, and this double bond can go over there. So it will be like this. So it will show and this will also show because it is having alpha hydrogens. So that means this cannot show. Why? Because its hydrogens are vinylic. Vinylic, all of them are vinylic hydrogens, so will not show. And this one will show. This one will show. So 1, 2 and 4th. 1, 2 and 4th. So third will be the answer. Third one. How many of you got correct answer? Third one is the answer. Yeah, 1, 2 and 4. Yes, this question. Let me check it out. Who is going to get the correct answer? Just 5 to 10 minutes more, kids. Five to 10 minutes, kids. Fast, fast, kids. Very good, Rock. That's really awesome, Rock. I want to see the answer. B. Okay, let me check it out. B is the correct answer or not. The pair that represents chain isomer, 1, 2 carbon parent chain, 1, 2. So this is not the answer. Propyl alcohol, isopropyl alcohol. Here also parent chain is being same. Parent chain is same, that 1, 2, 3, 1, 2, 3. 1, 2, 3 parent chain is same. So this is also not the answer. 2-methylbutane, 1, 2, 3, 4. 2-methylbutane, 1, 2, 3, 4 parent chain is of 4 carbon, and neopentane. Neopentane, 1, 2. So here the parent chain is just of 3 carbons, 1, 2, 3. So definitely their parent chain is different. This is the answer. Yeah. Now kids, I will take 10 minutes to explain conformational isomer. I have gone through each and everything. Right? So 5 minutes for questions or optical. We have gone through, and 5 minutes for conformational, right? So see, optical isomerism. What is the necessary condition for showing optical isomerism? Who is going to give the correct answer for this? One and only one necessary condition. So remember that people will say chiral carbon. Chiral carbon, people will say, 99% people will say chiral carbon. So big wrong to this. This is absolutely wrong, not the chiral carbons. Then what is the necessary condition to show? Remember that compound must be asymmetric. Then how to find out compounds must be asymmetric? For that, the compound should not have pos, that is plane of symmetry, and cos, that is center of symmetry. shouldn't have pos and cos. Remember that, right? One more thing I would like to say, that if a compound is having just one chiral carbon, remember that. Note, if oh my god, what is this? If any compound, if any compound board is not working, kids. Board is taking too much time. Just a second. If any compound, what is this? What it's writing? If any, if any compound is having only one chiral carbon, then it will never have pos and cos, and the compound will always be optically active. Now, how to count chiral carbons? Calculate total number of optically active isomers. So remember that, kids. In this, I would like to tell you the simple thing and the most important thing. Case A, if compound doesn't have any pos and cos in any of its representation, then total number of optically active isomers is equal to 2 raised to power n, where n is equal to number of chiral carbons, number of chiral carbons, and in this number of meso will be 0. Meso will be 0 means no meso will be there. So total number of optically active isomers will be equal to total number of optical isomers also, because there is no meso. This is very important thing. Just 5 minutes more, kids. Let me finish. 5 minutes more. Okay, kids? Okay, kids? Yeah, Rock, it's right. Now see, kids, let me explain. For example, if I take this compound CH3, CHOH, COOH, this is known as lactic acid. So lactic acid is having just one chiral carbon. The chiral carbon, who is the chiral carbon? Chiral carbon means the carbon which is attached with four different atoms or groups. So this carbon is attached with this, and this. So chiral. So total number of optical isomers will be equal to total number of optically active isomers, that is equal to 2 raised to power 1. One chiral carbon so 2. Out of these two, one is dextrolactic acid, another one will be levolactic acid. So what's the relation they are holding? They are enantiomeric pair, and if we mix this enantiomeric pair, if we take mixture of enantiomeric pair, that is known as racemic mixture. Mixture is known as racemic mixture, and the process will be known as racemization. Is it clear, my dear students? Is it clear, my dear students? Let me give you one more example of this. Suppose if I have been provided with compound like this, CH3, CHCl, CHBr, CHOH, and CH2CH3. Now you see, on the extreme right hand side there is something else, and on the extreme left hand side there is something else. So no chance of having any type of symmetry. So there are 3 chiral carbons. So number of chiral carbons are 3. So total number of optically active isomers is equal to total number of isomers is equal to 2 raised to power 3, that is being 8. Now I hope that till now it's clear. Then I will explain meso. Then I will explain meso. Is it clear, kids? Till now it's clear or not? Do let me know. Yeah, Afifa, I know Afifa Sheikh, just 5-10 minutes more, just 5-10 minutes more, right? Now see, meso. What is meso? And when to get meso? When compound does have cos, plane of symmetry, or cos or both along with chiral carbons, along with chiral carbons, along with for example tartaric acid, for example mesotartaric acid, so let me draw mesotartaric acid. Let me draw over here so that better understanding should be there. COOH, COOH, HOH, HOH. So see, this is the plane. This is the plane of symmetry. You can see it is dividing the whole compound in two equal parts. Can you see, kids? It's dividing the whole compound in two equal parts. Can you see, kids? So this is plane of symmetry. So plane of symmetry is present. So this is known as mesotartaric acid. Are you getting my point? Clarity is there or not? I don't think any problem is there, kids. This is the heading mesotartaric acid and this is the structure I have drawn, and there I have written this is plane of symmetry. Is it clear? Do let me know. Show me green hearts if it is clear to each and every one, kids. Kids, do let me know. Now, if, oh, Sahana, everyone, are you there, kids? Oh my God, kids. Still, are you awake? Just 5 minutes more. 5 minutes more. 5 minutes more. Now, if anyone is asking that tartaric acid, how to find out number of total number of optical isomers for tartaric acid, then how will you find out, kids? So any compound, I would like to say case number 2, I have taken case number 1, now case number 2, if mode stopped working, if any compound is having, pos or cos in its sum of the representation, and the number of chiral carbons is even, then heat up. The board has heat up and now it's taking time. Then total number of optical isomers is equal to 2 raised to power, as I have written earlier also, 2 raised to power n minus 1 plus 2 raised to power p minus 1, where this portion is total number of optically active isomers, and this is for meso. Now For tartaric acid, I will explain with the each and everything with visualization as well as with the formula. So let me explain with the help of formula first, then visualization. One side visualization part, one side formula part. So see, this side formula wise I will tell you, on this side visualization. Okay, tartaric acid is COOH, CHOH, CHOH, COOH. So, two chiral carbons are there. So, let me apply total number of optical isomers. 2 raised to power n minus 1 optically active plus 2 raised to power p minus 1, where p I haven't written. Once I have written, but this time I don't think I have written over there p minus 1. So this time I think I have not written over here. P is equal to, where p is equal to n by 2. P is equal to n by 2. So 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So 2 raised to power 1, 2 raised to power 0, 2 raised to power 1, 1. So it's coming out 3. 3 means 1 meso, 2 optically active. But formula never guide us, never make us visualize anything. Formula just increases the speed. So let me draw tartaric acid. COOH, OH, OH, H, H, COOH. Now you see two chiral carbons are there. There is no plane of symmetry, because if you put this is OH, this is H, there is no plane of symmetry. No pause. So if you see the right hand side, it's mirror image of this. Right hand side one is the mirror image of it. So these two are optically active, and the relation in between two, they are enantiomer of each other, enantiomeric pair. Now see kids, one more I will draw. Where to draw? Let me draw upper side. Now this form, if you see, now kids, I have to complete it speedily. Why? Otherwise, you know, YouTube will say, what are you doing? That is not allowed. Going near to 12 hours, YouTube starts scolding. What are you doing, man? What are you doing? YouTube will start scolding. Oh. So see, this one is having, if you check it out, this one is having plane of symmetry. Can you see, kids? It's having plane of symmetry. Can you see, kids? It is dividing the whole compound in two equal parts. Can you see? This one is having plane of symmetry, and this is meso. That I wanted to tell you. This is meso, meso. So These two are optically active, that is optically inactive, but still optical isomer because it is rotating the light. So kids, I think each and everything is clear, kids. Kids, each and everything is clear. Now I think only one thing is left, that is conformational isomerism. I will take 7 minutes for that and then the class will get over. Okay, just now the conformational isomerism for 7 minutes, then the class will get over, right kids? Just for 7 minutes you have to stay back. Let me tell you conformational isomerism, then the class will get over. For this, presence of at least 3 regular sigma bonds are necessary. That means if I write down H2O, do you think that it will show conformational isomerism? No, it will not show. Why kids? Why kids it will not show? Water will not show conformational isomerism. The reason is 1 sigma bond, 1 more, so only 2 will not show. If I talk about H2O2 hydrogen peroxide, it will show kids, because how many sigma bonds are there? 1, 2, 3, so will show. If I talk about methane, methane is having 4 sigma bonds, but do you think they are regular sigma bonds? Regular sigma bond, that means you can count without lifting your pen. Without lifting your pen, 1, 2, only 2 you can count, so will not show, will not show, will not show. This will show. If I ask you ethane, if I ask about ethane, then what do you think that ethane will show? Do you think that ethane is going to show conformational isomerism? Yeah, sure. 1, 2, 3, so it will show. Now, who will show, who will not show, that's clear. That how it will show, what happens during conformational isomerism, this will take very less time. So it's about to complete. Shanvik, Sahana, very good. Wow. Wow, thank you Sahana, thank you, really kids, thank you. Really, it means a lot. Now see kids, there was one scientist, Sohars. There was scientist named Sohars. He has seen the compound through sideways. There was another scientist named Newman. He has seen the compound from front. Now, let me tell you about ethane. He has drawn one line like this and said draw Y over here. This Y, that means hydrogen, 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 and there also hydrogen, just the hydrogen, and he kept his I over here. Hydrogen, hydrogen, and he said this is eclipsed form. Just you see at the back of hydrogen they are hydrogens, so it's being eclipsed form. According to him, this is eclipsed form. Now it will rotate, keep it fixed, rotate this one. So on rotation, keep this one fixed, although all they are rotating, but just to understand, keep this one fixed and rotate another one. So sometime it will be like this also. Out of infinite positions, it will be just in the middle of that. That is being staggered form. So they are free to move because of single bond. They are converting into each other. So this is known as eclipsed, least stable. And that is being staggered, being more stable. Rest of all other forms in between these infinite means most stable and least stable, they are known as gauche or skew. Now the same thing was seen by scientist Newman. He said the front carbon I will make with a small circle and I will put this Y like this, no problem. Hydrogens over here, no problem. And the back carbon, he said, I will draw with big circle. The back carbon, he said, I will draw with big circle. This is a small circle. He said to draw with big circle. So he has taken big circle and then he draw the hydrogens. Now if I draw hydrogen at the back of hydrogen, eclipsed form, it will be eclipsed. We won't be able to see the hydrogens which are lying at the back of it. So this is eclipsed form. What is the problem with eclipsed form? The problem with eclipsed form is that the bonded electrons are lying too much near these bonded, and the bonded electron will create tension that is known as torsional strain. Tension is strain. Torsional strain is maximum. And the atom to atom repulsion, this is known as van der Waals strain. This is also being maximum. So both are being maximum. So now let's see staggered form, keeping the front one constant, the small circle, 3 hydrogens over here, and let me draw this. This is now at the maximum distance, 60-degree angle. Now the bonded electrons are too far, so torsional strain is minimum, and atoms are far away, so van der Waals strain is also minimum. This is more stable. Now you can see and you can judge, you can do whatever. So that side it will go more, this side less. Everyone, now last 1 minute I will tell you when gauche will become more stable. It's not always that the Staggered is going to become more stable. Sometimes gauche whenever there is hydrogen bonding. So let me write down one note. Yeah, just 1 minute. Whenever there is hydrogen bonding, remember that in case of hydrogen bonding. In case of intramolecular hydrogen bonding, in case of last 1 minute, intramolecular hydrogen bonding, gauche will become more stable. Gauche will be more stable. I hope everyone got it, kids. This is done and dusted. Clear to all of you, kids. Ooh, I have told you, I taught you each and everything, kids. Okay, kids. Thanks for your best efforts. Bye to all of you. Good night. God bless you. May Almighty God help you with all happiness and prosperity. Thank you. Really thanks. Shanbik, Sahana, Driller Hirsch. Bye, kids. Really bye. Bye, kids. Alia Muskan, Srinivasan, good morning and thank you. Thank you, really rock. Really, kids, for your hard work. Really salute to your hard work, kids. Bye, kids. Bye, everyone. Good night. Good night. Sahana, Rachita, Afifa Sheikh, thank you, Afifa, Ramu Parumul, yeah, yes, media, love you, Sahana, Rachita, Shanvik, yeah, YVS, good night. Kids, once the video is over, once it's becoming offline, will you put all your these comments? Just make a copy of these comments and put over there, right? Will you? Just to let me know. Will you put? Yeah, what was the best, what you like most, everything, right? Buy kids, buy kids. Really buy. Take care everyone. Bye Bignesh Pillai, bye Shanbik Anthony, Rockham High School, bye night.